always felt harder than rain. Scared I would take my broken heart to the grave.
Woo. Good morning, everyone, and welcome to jPrime. So today, everything is against us. The public transport is against us. Even they say that it's the jPrime server, but I'm sure that it's the software running on Spring there, because the jPrime site is not running at the moment. Yeah, it's Spring, that's why. But anyway, welcome everybody. We are happy to see you again after 1 year of thorough preparation from our side, especially from Naiden's side. He was the most thorough of us all. So yeah, let's start. Let's kick it off. So not sure how many attendees we have because the server is down, but for sure it's more than 1,100. And we have again 30 sponsors, even this year when most of the companies have their issues with sponsoring events and HR and whatever. So yeah, we also have 30 sponsors. And of course we have 27 speakers, and everyone from them will be here around. We don't have speaker room where we confine them, that nobody can ask them questions. They are rock stars, but not in the sense of the rock stars. And yeah, we are.
By the way, it's very funny. If you see the slide, by the way, the slide is not ready because I didn't finish it yesterday, and I asked the guys to finish it today, and nobody actually cares. So yeah, that's why jPrime is not written in the yellow box. You can see it under the 10 years. My God, why didn't you fix it? Yes, and 4-time X attendees, that means that the server is down, nobody knows where it is. But it's so nice that this hall is full, and it's so nice that actually we are bigger than Java 1 this year. So Marta was a Java 1, it was only for, just 1 second. Don't touch, don't touch. And we are even bigger than Dell Nexus, and what makes us really, really happy is that 10 years of jPrime, we're getting only bigger and bigger. Even the world is getting, you know, what happens to the world. So it's getting ridiculously down, but we are only getting bigger, and this makes us completely happy. So applause for ourselves. Yay! We're getting bigger. Yay!
By the way, even jPrime, the first edition of jPrime was bigger than Java 1 this year, but anyway.
So by the way, just to say something, in 2015, we didn't expect it that we will become such a big conference. We were 350 people in the first year. And just a little retrospective, 2015, yeah, maybe you remember it as yesterday, you know, Star Wars The Force Awakens was released. But 2015, Java 8 was the base version. 2015 was the year when everyone was speaking about smart stuff, you know, smart assistant, smart home. Now everything is AI. We'll see what is in another 10 years, but yeah, we are super happy, at least I am super happy, that as a community, we managed to make a conference that is bringing together more than 1,000 people when we started with a budget of zero experience and 350 people. I haven't checked the conference at all, the slides at all, so.
Yes, I will help Naiden here. It was very funny because when we started jPrime, you know, it's a little retrospective from our side, but I really enjoy this story. So Ivan came and said, let's make a conference. We say, yay, let's make a conference. We can do it. After a few days, 6 big sponsors, which are now our co-organizers. By the way, big applause to our co-organizers. Yes, they trusted in us. Yes, they believed us. And they say, here you are, a lot of money. Make a conference. And now we are...
And I bought beer.
Yes, and we bought beer. Yes, exactly. So here you are, a lot of money, make a conference. And none of us was able to make a conference. And what we did with the money, we did our website. because we didn't know what to do and how to do, which is now down, but you'll be surprised that this very same website works for 10 years, although it's written in Spring. Yes, and it's, yes.
And
No,
although
no,
it, was,
nobody's
it
perfect.
was upgraded this year for
Yes.
first time,
First time upgraded from
thanks to Duichin.
Yes.
The website is up.
Oh, sorry. Get back the slide, please. What are you doing, man? Please don't fix the website right now. It's not the moment to fix the website. Ah, okay, the website. Give me the slide back, please. Yes, give me the slide back. It's left arrow, please. Left arrow. No, not left arrow. Yes. So, just to finish this. So, 10 years ago, no, yes. No, stop. Please stop. So, it was one-day conference with about 450, 30 attendees. Yes, just to finish my stuff. So, because our motto was, because nobody told them this is impossible, they did it. So this was the motto. Nobody knew how to make a conference. Nobody knew what to do with the tons of money we have received. In February, we came the idea of jPrime, and in May, we already had the conference. So I believe this is for applause. Yes. Yes, and for 400 attendees, which is a good for a conference, we made it to 1,200 attendees. By the way, who was at the very first jPrime 2015? Raise your hands. And we even have speakers from jPrime 2015. Heinz is back. So good. Good to see you here. And yes, once again, from 430 we got to 1,200, which is one of the biggest conferences in the world right now.
No time. Okay, so yeah, as every year we made sure to have great speaker lineup, and this year was very hard because of the changing dates. We coincided with two other conferences, one in Germany and one in Poland, I think. Yes, and we have speakers that are traveling today from Poland, or yesterday came from Poland, and today, tomorrow are going to Germany. And crazy stuff, but yeah, they're perfect. So that's why I want your applause for the speakers, and stop doing this. Okay, a little bit practical stuff. As every year, this is Hall A in your agenda. You can see the agenda here on the badge as well as on the website, which is up. Then the tent is Hall B. Something new this year: the workshops are in the incubator building. We'll place there some signs, road signs, tabelki, to show you where to go for the workshops. So the workshops are not anymore here in the back. We try to do a better accommodation for the workshop. Then the lunch is not here, but the lunch is in the tent outside. There will be there is coffee, water. Beer will be after lunch, of course. And yeah, if you have any questions, you can ask the people in red t-shirts. Yeah, this was for the closing, but
there is some black market ticket stuff going on. Price gouging, I don't know. We tried to buy one, we got scammed, so. Short slide about AI. There's a lot of AI sessions, and a friend of mine recently said, I would fire anyone who's not using Cursor AI. What I saw here talking to people and speakers is that that's definitely not true. And then everyone says that senior developers will still have a job, so that's a good thing. And then my personal experience is that debugging is still my job, so it still sucks, and it's the worst part. There's a lot of AI sessions. Enjoy. Again, especially this year, thanks to all the companies that supported us. Ivan just said, and I'm gonna quote in Bulgarian, професионализъм от всякъде бате, тук що ми го прошепна, не знам как не дават пари. So, thank you so much. the tent is outside. You know that. It's a lady yesterday stopped me and said, "What is this tent? Why is it here?" First time I'm seeing this tent, and I'm like, "No, this tent has been always been here for the last 4 years." So you know what to do. There's a stamp book, and then you win. You win what?
I have a mic, yeah. Okay, so as we did the last few years, there is a stamp book. So if you manage to collect all the stamps from our sponsor booths, you get a special jPrime gift. So don't hesitate, go talk to the companies and get a really cool gift. So.
And yeah, please, next year, don't try to ask for the stamp before the opening. There's no stamps at the booths before the opening.
Yeah.
They are distributed right now, so but don't go away.
Okay, yeah, thanks to Coworking Premium, we have actually 2 areas where we can chill and code or have a meeting or whatever. One is on the right side, once you exit the hallway. The other one is again on the right side, but you can go down. There is a table even on the first floor or -1 floor where you can also sit, where probably will be more quiet if you
And the beer will be
wanna
closer.
fix something. So it's also something interesting. We don't have a lecturers or lecturers room or anything like that. The idea behind this is that we want all the speakers to be together with all the visitors. So I know that the speakers are not super happy from that fact, but the idea is to have a maximum networking, and maybe that's why Coworking Premium is giving us a networking space for free. But the idea is to have maximum contact with the speakers, because we believe that this is the biggest value from the conference, probably. Okay.
Okay, so there will be beer for free.
We hope it's enough.
Okay.
We have set up Wi-Fi. I checked ours is 10 times better than the competition, so you can connect to ours. It's a lot faster. Yeah, it's the one is whole A and the other is whole B. This is our professionalism we're talking about. So I'm gonna leave this wide for a bit. This is us.
So it's still better than the competition. Even if it doesn't work. So.
Okay, so there will be entertainment zones downstairs, as every year. Our biggest sponsors and co-organizers have prepared some really interesting things. The entertainment starts this afternoon, not now, this afternoon. And you can go there, and if you don't have anything to watch or you are tired of watching sessions, then you can go there and enjoy something and chill out and have beer.
Nice.
And at the end of day 1, as always, again, these big co-organizers and big sponsors will give away some goodies, good stuff. So be here, and we'll use Night and Random to share some gifts with you.
I think it has been refactored since then, but.
Marto?
Yeah, so if you remember last year we announced that we did a free Java Academy, and the initiative continues. So it grew, I would say, quite significantly with a few hundred people, which makes us feel that Java is still on the edge. It's still a big demand. So if you have people that ask you where I can study or get more into Java, this is one option. Also this year at Java, they announced a new learning platform called Learn.java, so maybe you can check this out as well. So it seems that... But our is better.
Because it's in Bulgarian.
It's in Bulgarian.
Some people are thinking, oh, this is super junior, whatever. There are talks about Kafka and so on. So it has a lot of nice content. And maybe thanks to Marto and Java User Group Academy. Maybe the bad side is that Softuni doesn't have Java anymore because we have better free training. I don't know. But yeah, if you
No,
have
the-
friends or students that are
Again,
starting, it's a
the
great.
big thanks to this initiative goes to the entire Java community because there are sessions from more than 10 people. So big thanks to the community for this. And yeah.
Само върни за малко. Just before that, I'm not sure that there is a slide about this, but there is on YouTube, you can search for Bulgarian Juke. This is where you can find also the Academy, but also we have recordings from all the jPrime editions from all the years and probably this year as well. So if you see that there are multiple talks at the same time, don't worry. At later point, we will have all the talks uploaded, so you can just visit whatever you want. The only thing that will be missing is the workshops. So if you are wondering, should I visit a workshop or a talk, better visit the workshop because that's the only way and only chance to visit it.
Добра идея. Тук има 1000 места, workshop има 20.
Still,
Okay, let's go
it is
on.
better value.
Okay, so yeah, another new initiative that we start this year. I'm not sure if Ivan Yonkov is around in the audience. Show up, raise your hand.
Probably
No,
not yet.
maybe not. Okay, so we wanted to bring the spirit of jPrime outside Bulgaria, so why not do it in New Zealand? You may think, how do we relate as a community to New Zealand? In no way. Just that they have really a good Java ecosystem, so if by chance on 2nd of November this year you're around New Zealand or the region, you get a free
course.
ticket.
It's a few hours drive, yes.
Yeah, it's a short distance away, so yeah.
So if you are there, you don't need a ticket, just find Martu.
Okay, yeah, this slide is for J Professionals. So if many of you have visited J Professionals before. This year we had in Sofia, sorry, it was last year. Yeah, and we plan to have J Professionals in September in Plovdiv again. So you're welcome.
Yeah, the important point here is first there is a call for papers where you can submit if you want to make a talk. It's on the Juke website, so juke.bg, and there is a call for papers button on the top right corner, and you can just submit the talk. The idea of J Professionals, if someone missed it, the idea is to have a more smaller, hipster-friendly conference. You can talk in Bulgarian. If you have never made a talk before, that's a great test or try. We had a lot of successful speakers that started with J Professionals. They made a monthly event in
Some
their
of them will
company
be
and have,
here at JPrime. They will have a talk.
yeah.
Talks at JPrime.
And I think even internationally, at the end, they made a talk at some conferences. So come to Plovdiv. We will have beer for sure.
Yes, and we are happy.
And nicer weather for sure.
Yes, it's much warmer in Plovdiv. Yes, and we are happy that from this year we have restarted our meetups. The meetups, like typical meetups we had before the COVID. We are happy that we can gather in companies. They give us some halls, and we invite speakers as well. So we really hope that we will continue these good traditions. How many of you have been to this meetup? Erase? Okay, lovely. So hopefully we're going to make a monthly meetings and invite great speakers. Yeah. So just watch for the events at our jug.bg site, please. Yes, and before actually having fun and drinking responsibly, I have a question. Do you see that 1 zeros behind? Yes, do you see? Do you have any ideas what is written there? Okay, how many software developers are here? Yes. Can you read what's written there? Yes, I think Vlado can read. Vlado, say it loud. What is written over there? Exactly. In binary, this is 10, 10, 10. What does 10, 10, 10 means? 10, yes, that means, first thing, 10 years of jPrime, so it's many tens. And what are we celebrating this year? 30 years of what? Exactly, Java. So yes, Java makes 30 years, and we are celebrating it here. And I hope that This somehow demonstrates our attitude. So once again, by the way, hold my mic to my face. Yes, I want to we to show, I want we to show the world, show me the mic, that we are great and big. So, as I say J, you say Java. As I say J, you say Prime, okay? Ready? J,
Java,
J,
Prime,
J,
Java,
K.
Prime.
So, we are 1,200 people at jPrime, and let's make this conference really awesome. Thank you for coming, and have fun.
Enjoy jPrime, and yeah, you can stay here or you can visit the other talk in the other room. Enjoy jPrime.
Ще и помощ.
Той Хайнц ми казаха, че е закачен. Хайнц ми казаха, че е закачен, направо го по най-бързия начин го такове.
Кой ще го представи? Мите? Митя, трябва да го представиш. Марто, ти не можеш да представи някой в другата зала.
Отивай.
Айде, отивай.
Okay, great. So nice. Yes, like a Jubilee edition. Oh my God, we're getting so old. I remember that when Java was 8, like really 8, and I was 20 something. Okay, so I'll just, it's plus 1 minute. Okay guys, please take your seats. Yes, so we were a little bit like, take your stuff if you want to. You want to take something?
Just wait for
Okay. Okay, by the way, people on my left, a lot of places on your right, or on your left if you look at this. So please don't stand at the entrances. Yes, just come in. There are lots of free spaces over there, and they are very good big monitors. You can see everything. So Hans, you ready?
I'm ready. Let's go for it.
Yes, okay, so let me introduce our first speaker. This first speaker is a great friend of mine, and many people who have been on jPrime 2015 actually know that he was our first speaker at our first jPrime 2015. So it's a really good tradition for us to start like every 10 years
Exactly.
with our great speaker, Heinz Kaboutz, who make his way from Crete to actually open the jPrime 2025. Heinz, so happy that you're here, and great. And please welcome Heinz Kaboutz.
Thank you so much. It's an absolute pleasure to be back. And I remember the first jPrime. I actually forgot about it because I just remember this place, this particular location. And I remember we were in another location somewhere else. And I met Ivan, and the first time I met him, he was walking at about, 9 o'clock in the morning, carrying a beer. And I thought, this is definitely going to be a very different type of conference. And this is just a fantastic place. So I love coming to jPrime. I've missed a few sessions, a few editions, unfortunately. What's interesting is that the very first talk I gave 10 years ago was about concurrency. And now we again have a talk about concurrency, the hidden art of thread-safe programming. And we're going to look at the Java-util concurrent package. So what often happens is it's really hard when you're doing a talk to get the timing right. And quite often at the end we're a bit rushed. So what I'm going to do a bit differently today, I'm going to start with questions. All right? So here's a chance to ask some questions about Java to concurrent that you've always wanted to ask. We've got space for 3 questions. Let's have them. Come on. Don't be shy. So we're doing the QA at the beginning rather than at the end. So is the slide a race condition? No, it's not a race condition. Out of order slides. That's actually a great idea, but then that's not a question for Java concurrent. Don't be shy. Go on, ask. Anything about Java concurrent that you've wanted to ask? We can't continue until we've got some questions. So, oh, there's a hand. Excellent question. How do you get good at concurrency? And that's a really, really great question. How do you get good at concurrency? Great question. It's a fantastic. I've got a great answer for that. Let's hear another question. That was a fantastic question. Yes, sir. Sorry, I didn't quite hear that.
What are the milestones we need to keep in mind when we're designing a concurrent?
Okay, what are the milestones? I'm going to reword that a little bit. What are the milestones? Okay, I'll just put it down. We need to keep in mind when designing an application. Okay? Third question. Oh, that's a great question. Thank you. Okay. Is structured concurrency the silver bullet? All right. So I'm going to answer the second question first. What are the milestones we need to keep in mind? Because I'm not sure I understand the question correctly, so I'm going to reword it a bit. It's basically what I think you're trying to ask is, what do we need to consider about concurrency when designing our application? Right? So basically, anywhere where there's something which is accessed by multiple threads, which is quite often, any data, and this is all about data, not about programs as such, it's actually shared data. Whenever we have shared data, we need to either make sure that data is synchronized correctly, not necessarily the synchronized keyword, but generally, or it must be immutable, or it must be unshared. And if we follow those principles, it really helps us to, it really helps us to get an application which is thread safe. All right. The first question, which I really like a lot, I'm going to answer in the middle of the talk, and the last one at the end of the talk. All right. So I'm going to start by looking at a class called Java Vector. Who knows Vector? Okay, actually some of you. Now that's a very old version of ArrayList, which is a thread-safe version of ArrayList. It is synchronized. Most methods are synchronized. And the way it was in the version 1.0, because this is a very, very old class, they had all the methods which changed vector, which did a write operation. All those methods were synchronized. And the methods which were not write methods were not synchronized. So there actually were concurrency bugs in version 1.0 of vector. This is what it looked like. We had a protected int element count. We had a public final in size, which returned the element count. Now, the element count is a field, and remember, with concurrency, we're talking about shared data. That's what we're worried about, to make sure that that is thread safe. And there's a synchronized add element which prevents race conditions on the change, but the problem is that size could return stale values. So what could happen is that I read the size, but I'm seeing the size of what it used to be, not what it actually is at the moment. In Java 1.1, they introduced a race condition into vector. Now, this is a kind of a weird one, because you look at it and you go, where's the race condition? All they did was they added implement serializable. But that actually causes the race condition, because what happens now is that they, if I'm writing a vector into an output stream, at the same time as I can change it, then I'm going to get a vector output that's mangled with incorrect data. In Java 1.4, they fixed both problems. First of all, they made also the read method synchronized. So you have, for example, the size being synchronized. But also they made the write object synchronized. So they fixed both problems. That's Java 1.4. All right? 1.5, oh, sorry, actually, in 1.4, so when they made so what they did, let me just double check, just show this again. They added a write object method, which then writes to the object output stream, making that synchronized, meaning that you can't write to the object output stream whilst you're busy changing the vector. But that introduced a very, very strange type of deadlock, because if you've got vector 1, which points to vector 2, and vector 2 points to vector 1, and you write vector 1 and vector 2 with two different threads at the same time, you could get a deadlock. And I wrote about this years ago. This was still Java 1.6 when I wrote about it. And I said, there's no ways anybody would ever do this. Nobody would ever have a vector point to another vector and then write them both at the same time. But it turns out somebody actually did this and logged a bug, and IBM fixed it, and that fix went into Java 1.7. So this is now the 1.7 version. We can see that write object has been changed. We first make a put fields. We then put the elements, we clone the element data, we make a clone of the array, and then we write the fields without holding the lock. So we do the actual write fields without holding the lock. And this prevents the deadlock. The deadlock happens when you first get one lock and then the other lock, and then the other time you get it in the opposite order. So that gives you the deadlock. So all's good, right? Well, no, because in Java 1.8, they introduced for each. And for each does the following. We're iterating, it's synchronized, we're iterating over the collection, and we're calling action.accept element data. So it's very easy to cause a deadlock in Java 8. Because what you can do is you can say for each, and then all you have to do is say contains in another vector, and do the same thing in the other vector, and again you get the same situation where you are first getting the one synchronized lock and then the other synchronized lock, and you end up with a deadlock. And then there are other deadlocks as well. For example, if you say vector 1 dot equals vector 2 from one thread, and at the same time vector 2 dot equals vector 1, then again you can get a deadlock. But so what can we learn from this? We learn from this that there are lots of very strange edge conditions that could cause a deadlock. Deadlocks normally are not such a problem, because if you get a deadlock, you will see your deadlock in your stack trace. And at the moment, you can only see them for platform threads. In the future, we'll probably see them for virtual threads as well. But for now, you just see them for platform threads. The other thing is that we don't always see these bugs when we do tests, because our tests don't expose the concurrency bugs unless we're looking for them specifically. Some of them are really, really hard to find. You need to know what to look for. So I started a couple of years ago writing courses which nobody will ever want to buy. You might wonder, why would I write course and nobody ever want to buy? Because I really wanted to dig into Java concurrent in a level that no one's ever done before, right? And so this is what I started here, and that's actually what I'm talking about here as well. You see, writing correct thread-safe code is a challenge, and this answers already the second question to some extent. You see, we've got a rule book. We've got the law, the Java memory model. And the Java memory model describes how threads must communicate between each other. It has rules for happens before, in which order things must happen, access safety. But the problem is you don't know whether a class adheres to the memory model 100%. There's no test. There's no way of taking your class, putting it into a test and say, right, our code now complies 100%. So we have to run our code and hope it works correctly. And some bugs are extremely hard to detect, and this is what makes it so hard. Normally, when you write some calculation, you can run it through the test and see if the answer is correct. But here we can't, because here we run the test, we don't actually know whether our code is correct if the test passes. It's a bit like driving laws in Bulgaria, right? And Greece. All right. So here's a very interesting bug that I saw in the bug database. There's a very rare situation on lock support. There's a class called lock support, and somebody at Google discovered that sometimes the threads wouldn't get unparked. And so he wrote a test, a really smart guy, wrote a test, let it run for a whole week, and a whole week of CPU time, he managed to get it to cause this problem. So it's like running it over and over and over again, thousands, millions of virtual machines starting up and so on, until eventually he found a situation where the thread would not unpark itself. And extremely hard to discover and diagnose. And so the recommended workaround was to do the following. In any class that uses lock support, so if you use lock support inside your class, you would say static, and then you'd load the class, you'd say ensure loaded lock support.class. And you'll find this in a whole bunch of different classes, like, for example, concurrent hash map. Anywhere where you see lock support being used, almost anywhere, they have this weird code snippet. So what I did was I searched through and I found there are a few places where they don't have this, but this is all new code. So I don't know whether this is a problem or not. I don't know today. It was a problem in Java 7. I'm not sure it was a problem in Java 8. I don't think it's a problem in Java 9. But if you said to me, here's a gun against your head, is it a problem? I would say, I don't know. Right? And the funny thing is I logged a bug against the class which didn't have this. And the people who really know this stuff, they're also not sure. So nobody really knows. And unfortunately, this is really tricky. So one of the reasons I started on this path down of really studying in great depth Java concurrent is in Brian Goetz's book, Java Concurrency in Practice, he basically says that don't write your own synchronizing classes. Use what's in the Java concurrent. So I thought to myself, well, what magic do they have that's different to our magic? Like, are they that much cleverer than us? I mean, probably, but and I'll explain to you now why this is useful to study. First of all, by studying it, you learn what is available, but you also learn how to write robust thread-safe classes. I found a whole bunch of bugs in Java concurrent classes by studying existing classes. So I found bugs in other classes by studying existing classes. All right. Now, good versus bad code. We all make mistakes. Everybody makes mistakes. In German, there's a saying, Vertrauen ist gut, Kontrolle ist besser. It's good to trust, but it's better to check up on it, you know? And that's where we have this test-driven development, unit testing, and so on. That's really important in order to make thread-safe code. And it's also best to rely on well-known, well-used synchronizers. So, for example, if I need to choose between concurrent hash map and concurrent skip list map, I would rather use concurrent hash map because it's more used. Right? If I need to choose link blocking queue, link blocking deck, I'd rather use link blocking queue because it's more used. So you always take the class which is most used. And anybody can report a bug on Java code. And I've reported quite a few, especially recently. And these are, I did one in link transfer queue quite a while ago, and then one in concurrent skip list map. Since about Java 10, concurrent skip list map hasn't been doing parallel streams. You think it is, but it's not. And it's been like this for ages. Nobody noticed it. And then one in arrow blocking queue, and then 5 in link blocking deck. Right? Now what I've done is I've now bundled them all into one bug, so hopefully in a month or so that's going to get all fixed. But I've never used link blocking deck in my own code. I was looking at link blocking deck to use for my course, for the teardown course, but I've never used it in my own code. I've used link blocking queue quite a lot, and I've not found a single bug in link blocking queue and looked at it very, very in great detail. How many of you have used link blocking deck? Right, okay, I think. Concurrent hash map, anybody? Right, there we go. That's exactly my point. So if you look in the JDK, concurrent hash map is used hundreds of times, and then you've got copy and write array list, concurrent linked queue, concurrent linked deck, future task, and link blocking queue, and these are used quite a few times. And then the rest is not used very much. So my suggestion is use the ones which others use a lot, and you'll have a smaller chance of there being bugs. Not zero, but less. So use the most used ones because that's where probably the least bugs are, because others have found them for you. And that's also the reason why we don't want to write our own synchronizers. Because if we write it, if I say, somebody has written, I don't know, some clever synchronized, sorted list, and nobody's heard of that. Nobody's used it, so therefore you have a high chance of bugs. Oh, something. This is for a free gift, a course. If you want to take a picture of that, you'll get a free data structures course. I tried to make it as big as possible so you can all see it. Hopefully it'll work. And hopefully the internet, this is actually a test of the internet to see if the network works. Now if you missed that, it's tinyurl.com/jprime-25. Write that down. And that's going to expire this evening. So make sure to get it before this evening, otherwise it won't work. tinyurl.com/jprime-25. All right. So let's look at something else, which is striped 64. So what I want to try is to increment a number 100 million times and see how quickly that happens. So let's go to here. We write some code. We're going to say int stream.range 0,100 million. We're going to say .parallel. And then for each, we're going to let's start with atomic long, var atomic equals new atomic long. I was traveling to Israel once, and I had this long interrogation, why am I going there? And they said to me, why are you going? And I was going to teach Intel, do some training for Intel. And they said, can you show us the course? And I opened the course, and it was on the slide about atomic integer. And I said, let me just go to the beginning of my talk. So here we can see if I run this atomic integer, atomic long, 100 million times, see how long it takes to complete. 5.4 seconds. Right? So it runs for quite a while to finish, 5.4 seconds. If I do the same thing with the long adder, and I say again int stream.range from 0 to 100 million in parallel, and I say add the increment, and I put again a timer around that. It's going to be the adder time. We see how long that takes. So the other one took 5.5 seconds, and this, less than 100 milliseconds. So you can see a massive difference between the two. One takes 5.5 seconds, the other one takes 100 milliseconds. So what I want to look at here is how does it actually work? How does it run so quickly when the other one takes a long time? And so let's have a look at this magic. And if you look at long adder extends a class called striped 64. And it uses something called lock striping. Instead of having a single shared variable, we have multiple shared variables, which we then merge when necessary. So when you say long value at the end to get the sum, it's going to add up all the values. But what happens with striped 64 is when you construct the first long adder, it stores the value inside a transient volatile long base. So you've got a volatile long base over here, and that's just a 64-bit value. So what happens is if you do a compare and swap, and you lose the race, then what happens is that they expand that to be an array of cells. And they basically spread the cells assign the threads between the cells using it's like a pretty weird randomizing function to try and reduce the probability that two threads go to exactly the same cell. So that's how they do it. And that information is actually stored in the thread itself. All right, so you've got your cell over here. The cell is contended. What contended means is that they make the object bigger so that it lives by itself in its own cache line. You mustn't forget that there's always memory running underneath, and hardware which is running our code. And if we have multiple cells sitting in the same cache line, and you update the one, they both have to be flushed out to main memory. So by having it contended, each cell will always live by itself in a cache line, will never share with anybody else. You don't get false sharing or true sharing. All right. So that's how it works. And so what happens is the first time that you get a conflict, it will create a cell array of size 2. If you get another conflict, it's going to double it again to 4. If you get another conflict, it's going to double it to 8. And it's going to keep on doubling it until you get to an array which is not greater than the number of hardware threads in your system. So I've got 12 threads in 12 cores in my machine, my laptop. So it's going to go up until, not bigger than to the power of. So it'll go up to 16. It won't go beyond 16 threads. So it doesn't matter how many threads I have, concurrently updating it, it's never going to go to more than 16 cells. But they distribute amongst the threads so that you have a fairly good distribution of the threads to the cells. You don't have all threads going to a single cell, for example. That's how it works. So it's really amazing. And the long adder basically uses this and also the long accumulator as well. So the best way to deal with contention is to not have contention. It's to reduce the amount of contention. Contention is a real performance killer. And you'll see this in lots of different cases. All right, let's look at something else. So let's say that we've got a service that takes some time to get started. And other parts of the code are depending on the service. So what we want to do is we want to wait for that service to start, but we don't want to worry about things like interrupted exceptions everywhere. You know, those are a pain. Nobody likes interrupted exceptions. So what we're going to do is we want to look at different ways to do this, and also avoiding having to worry about catching interrupted exception. So I define an interface called starting gun, and I've got two methods of wait uninterruptedly and ready. So the threads, which are the parts of the code that are waiting for the service to start, we'll call await uninterruptedly, and the one that starts the service will say ready once it's done. All right. So I'm going to show you three approaches, and this actually answers the first question also a bit, how do you get good at this? The first one is doing it just from first principles. And here I've got a starting gun monitor, implement starting gun, and the reason I call it monitor is that it's using synchronized, and synchronized is also called monitor locks. So here's my, I've got a field called ready, Boolean ready equals false. I've got a method called await uninterruptedly, which is synchronized. And I first of all start by saying interrupted. I remember what the status of interrupted equals thread.interrupted. And then I say while not ready. So what thread interrupted does, it also resets the state to no longer be interrupted. So it's like you remember it, but you don't keep it interrupted. I then say while not ready, I try and wait. It needs to be a while loop. So you wait, keep on waiting. If you get interrupted, you get an interrupted exception, you'll simply remember that. You say interrupted equals true, and then you'll continue waiting until you exit normally from the wait, and you are ready. Now the wait is problematic. The wait is not fully compatible with virtual threads. So it will work to some extent with virtual threads, but not entirely. All right? So we need to be a bit careful with that. And once we are ready, we go here, if interrupted, thread.current thread.interrupt. Okay, so we re-interrupt ourselves, and we exit from there. And the ready will simply say ready equals true. It's a synchronized method, and notify all, which wakes up all the threads to now continue. So this is, as far as I know, is thread safe. I believe this is correct. I had a talk in Germany, and somebody complained about something, but I think they're wrong. I think this is actually correct. But you see, it's very low level, and it does have a problem with virtual threads prior to Java 24. Let's look at another way of doing this. We could also do it like this. We could say, let's simply use countdown latch, which is similar to what I want to do, but what we'll do is we will catch interrupted exception and just sort of ignore it temporarily until we exit from there, and then we re-interrupt ourselves when we exit. So the code's almost exactly the same, but I don't have to worry about synchronized. I've got something which is compatible with the fork join pool. It's compatible with virtual threads. So it's like a little bit better approach to doing it. Right. Now the third approach, first of all, the first one has a bit of a problem. As I said, virtual threads don't work too well, and it's quite hard to do that. But both times I have to catch the interrupted exception, and it actually makes the exception itself, which is we're still paying the cost of creating the exception. So another approach would be to use exactly the same as countdown latch. So here's what we do: is we go to we take countdown latch, and we do a copy and paste of the inside. Now, normally you're not allowed to copy and paste code from the JDK, but this is one exception. The Java concurrent libraries actually are in the public domain. So we're going to copy and paste it here, and I'm going to. I just need a few of the class, not all of them. So basically, I need this abstract queued synchronizer, The int count is always going to be 1. So I can just say set state 1. I don't actually need this. I can do it like that. I don't need the int count, getting the count, because it's always going to be 1 or 0. I could have an isReady. I'm going to here simply say equals new sync. That's the sync. Delete this, don't need that. Await is going to be almost exactly the same, but it's going to be await uninterruptedly. And so here, I'm relying on the abstract queued synchronizer, and here I'm going to say acquire shared rather than acquired shared interruptedly. And that does all of the code that I wrote for me in one line. So that's the same as what we saw over here, all of this await uninterruptedly, except we're not actually generating an interrupted exception. It's saving it for later, and so that's all I need to do. Await acquire shared, and then ready would be the same as, let's delete this, I don't need that, I'm not going to use the timed await. That's going to be the same as countdown. So ready will be release shared 1. And the rest I think I don't need. I don't need the get count. I can delete that. I'll delete the toString as well. So this is my code. It simply is going to be let's put this up here. It's simply using the countdown latch, but simplified, using the same code, copy and paste of the code. All right, let's double check that it's correct. So I've got a test for that. Starting gun, this one over here. And hopefully I didn't make a mistake. And I don't think I made a mistake, but you know, these things are hard to test. So these are the different ways of doing it. Which one's best? Well, sort of in a way, the best is the last one, but it's a lot more work. And I think that the second one might be better, because I'm relying on a class that is in the JDK, the countdown latch, and if there's a mistake there, then we can fix it there, and it's fixed for everybody. All right, let's look at something else, the linked blocking queue. This is quite a fun one. So the linked blocking queue has a design, it's like a linked list, but it has 2 locks, one for putting and one for taking. One to put something in, one to take something out. And so this means that I can have 2 threads putting and taking at precisely the same time. If I've got a single producer, single consumer case, you typically have higher throughput on this than on a queue which has a single lock. But it can be quite interesting if you've got a single producer and multiple consumers. Because what happens is you've got a single producer putting elements in without any contention, being able to put it in very quickly, but at the front of the queue, you've got the multiple consumers fighting over the lock to take elements out. And the queue gets longer and longer and longer, and you get lots of full GCs whilst it's trying to clean everything up. The interesting thing, though, is because you've got 2 locks, you've got the put lock and the take lock, you cannot rely on visibility with the locks because they've got different locks. So the way they do this is they've got an atomic integer for the count, and they piggyback off the atomic integer in order to make sure that you're seeing the changes made by on the other lock. So let's have a quick look at this demo as well. So I'm going to make a test method here, pass a linked blocking queue, and no, that's wrong. Let's create a method here, and that's going to be just a blocking queue of queue, and we'll call it integer. Okay, and then we're going to go comma. That's going to be, the 1 is going to be the number of consumers. So that's going to be the number of consumers. We're going to start with 1. So we're going to have over here pretty much what I want to do. Var pool equals executors dot new cache thread pool. Then I'm going to say thread dot off platform. Oh no, pool dot submit. Sorry, and it's going to be over here. I'm going to say 0 up to 10 million. And I'm going to say put into the queue the value of 42. I'm going to have the same value so that you don't have to make objects for the integers. And then once I'm done with that, I'm going to say 0, it's going to be the consumers up to the number of consumers. And we're going to make pool submit. This is going to be 10 million divided by the number of consumers. And we're going to say q.take. Right? Luckily, IntelliJ has seen me do this before, so the AI has sort of remembered my previous demo. So we print out the time, and we also print out the q.get class. Let's run this code. And we see the link blocking queue took like a second to do this work. And let's do this a few times. 0 to 10, so we don't just do it once, do it a few times, and we'll see how well we performs on the link blocking queue. So sometimes it does better than other times, and one of the reasons is that sometimes it's doing a GC whilst it's running the test. So let's do a system GC at the end. You would never do this in real code, but in the test it's okay to do this, so that we can clear it and hopefully get more consistent results. So looking about 750, 800 milliseconds per data point for the link blocking queue. Right? Let's try the link blocking deck now. Now the link blocking deck is a bit different because it has a single lock that it uses for put and take. Because you can add in at both ends of the queue, they can only do it with a single lock. And if you run the code now, you can see that it performs a little bit worse than the link blocking. Oh, that one was better actually. But most of the time it performs a bit worse than the link blocking queue. Right? Let's take the array blocking queue, which also has a single lock. Let's give it 10,000 elements, it should be enough. Array blocking queue. And again, it's okay, it's about a second. But it's not as good as the link blocking queue, which was consistently about 750, 800 milliseconds. All right, now let's try this one with 2 threads. And now the 2 threads, whoa, look at that, that's nice and fast. Amazing. Let's try the link blocking deck with 2 threads. Pretty good. All right. And let's try the link blocking queue with 2 threads on the consuming. Oh. And it's actually gotten worse. It's a bit like link blocking deck at the beginning. And this can happen. You see, this link blocking queue is used by the fixed thread pool. So if you have, for example, a fixed thread pool of size 1 thread in there, and you give it a bunch of jobs to do, short jobs, it's going to be able to pull them out very quickly without contention because it's one consumer. But the moment you have 2 threads inside your fixed thread pool, those 2 threads are fighting over the lock for take. And so they have massive contention on there. And so you end up with it actually being slower than with a single thread. Here's another fun one, the array blocking queue. This does weekly consistent iteration. And so, for example, if you have a queue and you've got 1, 2, 3, 4, 5 in there, and you make an iterator, you get the first 3 items, and you then add another 5 items to that. You then end up, if you keep on iterating, you see the rest of the items. If you try to do this with an array deck, or an array list, you'd get a concurrent modification exception. But because this is thread safe, it actually works. So, but there's a problem with array blocking queue in that it's basically an array that's a fixed size, and if you keep on adding and taking elements, it's going to go wrap around the array, right? And so behavior is going to be slightly different to how linked blocking queue iteration would work. However, what's interesting here is that you basically somehow array blocking queue needs to notify its current iterators that it's wrapped around. So the moment it wraps around, it notifies more. But there you've got a problem, because if array blocking queue kept all of its iterators alive, that would cause a memory leak. So what they do is they use weak references to point to the iterators in order to keep them sort of alive, as long as they still have some elements inside. Right. I want to quickly show you this one other thing. Don't have that much time left. And that's the double-check locking on the copy node array list. So the copy node array list is fairly simple class, but here it gets interesting, because what they try and do is they've got a couple of places where they really try to avoid getting the lock and doing something. So if you remove an item from the copy node array list, the remove object is an order n operation. So if you've got a very large copy node array list, it's going to take as many steps possibly to find whether the object's there or not. So what they do is they first run through the array to check whether the item is there or not. So it iterates through it, looks for it, and only once it's found the object does it call another remove method, which then actually goes and removes the item. Now, I'm going to show you some code that you probably have not seen before. I'm going to take a guess here. I hope not. Right? So here's the code, and you click on that, and look at this. Did you know that you can put a label on an if statement? Right? You can we all know you can put a label on a for loop, but you can also put a label on an if statement. So if the snapshot is not the current one, in other words, the snapshot has changed, they then put a label here. Now, I've never written code like this myself. Now, don't take a photo and use that in your own code. This is not my code. This is copy node array list. And when you look at the code in Java concurrent, it's very specifically written in a certain way. And what they're trying to do is they're trying to minimize the number of bytecodes, and they're trying to write the bytecodes in such a way that the just-in-time compiler and hotspot profiler can optimize them optimally. Right? So this way you don't have very much duplication of the code. And I took this code and I refactored it. I wrote it differently. And whichever way I wrote it differently, it always was easier to understand, but it all resulted in code that wasn't as optimal. So you'll find this quite often in the concurrent libraries, where they've got some horrific code that's hard to understand, or you have to really think about it to understand it, but there's a reason behind it. Right? And that's, again, a reason why we shouldn't write our own, rather use what's there. So we've come to the end. Unfortunately, as I mentioned, I'm going to GeekOn in Krakow, and I accepted their invitation first because they invited me first, and so I have to leave sort of lunchtime. So if you'd like to chat to me, I won't bite. Don't worry, I love the Bulgarians. And so I'm really, really happy to be here. Please speak to me after this. I'm very happy to chat. If you're not on my newsletter, you should sign up. It's javaspecialists.eu. And don't forget, if you haven't got this yet, grab that. We've got another 1 minute for a question, if there are any last questions. Oh, there's a question about structured concurrency. Thanks. Let's answer that as well. So structured concurrency is absolutely fantastic for describing most of the complex workflows that we need to do. So if you're working with virtual threads, which I really recommend you do if you work with concurrency, then structured concurrency is the way to go. Unfortunately, it's not fully baked yet. And I'm not quite sure why they're taking so long to complete the structured concurrency. I think they want to make sure it's 100% correct. So I would recommend that if you're doing virtual threads, that you do it with structured concurrency, even though it's still on preview. Because with that, it makes it so much easier to write your concurrent code correctly. And that's all we've got time for today. Thank you very, very much for joining. And I'll be here until 12 o'clock.
Join me in death. We are so young, our lives have just begun, but already we are considering escape from this world. And we've waited for so long for this moment to come. We're so anxious to be together, together in there. Whoa, won't you die tonight for love? Baby, join me in there. Won't you die? Baby, join me in there. Won't you die tonight for love? Baby, join me in there. Won't you die? Baby, join me in there. This world is a cruel place and we here only to lose. So before life tears us apart, let death bless me with you. Won't you die tonight for love? Baby, join me in there. Won't you die? Baby, join me in there. Won't you die tonight for love? Baby, join me in there. Won't you die? die? Baby, join me in there. Won't you die tonight for love? Baby, join me in there. Won't you die? Baby, join me in there.
Always, this is not what I do. It's the wrong kind of place to be thinking of you. It's the wrong time for somebody new. It's a small cry, and I got no excuse, and is that alright? Give my gun away when it's loaded. Not alright. If you don't shoot it, how am I supposed to hold it? Not alright. Give my gun away when it's loaded. Not alright. It's the wrong time for somebody new. It's a small cry, and I got no excuse, and is that alright? Give my gun away when it's loaded. Not alright. If you don't shoot it, how am I supposed to hold it? Not alright. Give my gun away when it's loaded. Not alright. Looking back on all the time we spent together, you wanna know right now if you wanna be my lover, wanna be my lover. Go ahead and take your time, boy, you gotta feel secure. Before I make you mine, baby, you have to be sure you wanna be my lover, wanna be my lover, wanna be my lover. La da da dee da 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 da. La da da dee da 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 da. La da da dee da 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 da.
life a little hard. Two minds that once were close, now so many miles apart. I will not falter though, I hold on to your hope. Simply that where you belong, see how I love it You're not alone. I'll wait till the end of time. Open your mind. Surely it's plain to see. You're not alone. I'll wait till the end of time for you. Open your mind. Surely there's time to be.
For the stars, if it feels right, then aim from my heart. If you feel like and take me away and make it okay, I swear I'll behave. You wanted control, so we waited. I put on a show. Now I'm naked. You say I'm a kid. My ego is big. I don't give a shit. And it goes like this. Take me by the tongue and I'll know you. Kiss me till you're drunk and I'll show you. Want the moves like Jagger. I got the moves like Jagger. I got the moves like Jagger. I don't need to try to control you. Look into my eyes and I'll own you. With the moves like Jagger. I got the moves like Jagger. I got the moves like Jagger. It's hard when you feel like you're broken and scarred. Nothing feels right, but when you're with me, I'll make you believe that I got the key. Oh, so get in the car when you ride it wherever you want. Get inside it and you wanna steer, but I'm shifting gears. I'll take it from here. Oh yeah, yeah. And it goes like this. Take me by the tongue and I'll know you. Kiss me till you're drunk and I'll show you. Want the moves like Jagger. I got the moves like Jagger. I got the moves like Jagger. I don't need to try to control you. Yeah, look into my eyes and I'll own you. With the moves like Jagger. Moves like Jagger. You wanna know how to make me smile? Take control on me just for the night. And if I share my secret, you're gonna have to keep it. Nobody else can see this. So watch and learn. I will show you twice. Head to toe, ooh, baby, rub me right. Yeah. And if I share my secret, you're gonna have to keep it. Nobody else can see this. Hey, 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 yeah. And it goes like this. Take me by the tongue and I'll take me by the tongue. Kiss me till you're drunk and I'll show you. Want the moves like Jagger. I got the moves like Jagger. I got the moves like Jagger. I don't need to try to control you. Look into my eyes and I'll own you. With the moves like Jagger. I got the moves like Jagger. I got the moves like Jagger.
Captured effortlessly, that's the way it was. Happened so naturally, I didn't know it was love. The next thing I feel is you, holding me close. Who was I gonna do? I let myself go, let myself go, let myself go, let myself go, let myself go. And do I fly to the stars? I hope this night won't last forever. Oh, 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 ain't nobody knows me better, makes me happy, makes me feel this way. Ain't nobody knows me better than you. Knows me better than you. Ain't nobody knows me better, makes me happy, makes me feel this way. Ain't nobody knows me better than you. I've been waiting for you. It's been so long.
Okay. Please take your seats. So we are 2 minutes behind the schedule. So I hope you had your coffee. Yes, it's free. And lovely. I have a question to you. How many of you are using open tracing? Okay, you're totally screwed. Yes, because nobody uses open tracing anymore. It's dead. And the open telemetry is the king now. And I'm quite happy that our great friend, Nicola or Nicolas?
Nicola.
Nicola Frankel.
But it's written with an S because...
Yes, because it's ridiculous French language.
Yeah.
Yes. Yes, they put additional S's everywhere. Yes, so our good friend Nicola Frankel, who is actually speaking, how many languages do you speak? 7, 6, 11, 24?
4 or 5, depending on who you ask.
Yeah, and are we cursing or not? Yes. Yes, our great friend Nicola Frankel is here, and I'm really happy that he was going to give us to talk about the technology that we have to use in production because it's the king, and it's open telemetry, and we really need it in production. So, warm welcome, Nicola. Hello.
Dobre jutro, Sofia. Thanks to be here. I'm Nicola Frankel. I've been working for more than a couple of years in IT. I have experience, or trouble, depending on who you ask. I've been working both in the development side and in the developer advocacy side. So as I mentioned, I have quite a bit of experience, and when I started my job in IT, we didn't talk about observability, we talked about monitoring. And at the time, monitoring were a bunch of people sitting in front of a giant screen, well, much smaller than that at the time, and they were looking at dashboards all day. And if a dashboard looked like bad, then they would log in into the machine and start to understand what was happening by reading the logs. But unfortunately, it doesn't work like this anymore, because our systems are becoming more and more distributed. I'm not using the word microservices on purpose, because if you do microservices, probably you are doing it wrong. But there is no denying that the systems are becoming more and more distributed. So we invented a new term called observability. The idea of observability is you detect the problem before it happens. That's the idea, which is a good idea. I'm a big fan of Wikipedia definition, so I copy-paste them a lot. I let you read it. And this one is lacking, because they mention distributed system, which is a good thing, but they mention logging and tracing, and observability is built on 3 pillars, not 2. They forgot metrics. This talk is mainly about distributed tracing, but I have a couple of slides on metrics and logging as well. First, metrics. I believe everybody does metrics already. Who doesn't do metric? Who doesn't track any metrics in their system? Good. The only advice I can give you is most of the time we have been lost in time and we still track system metrics, which are useful, but not that much. Like if you tell the business that your CPU is used 50% or that your disk is 80% full, they don't care. So probably you should use the same underlying infrastructure to give them higher level metrics, metrics that talk to them. The number of orders in the last hour if you are doing e-commerce, the number of, I don't know, 500 errors that happened, the number of 404 or whatever. So just give them higher level and you will get something in return that's called budget, which is very good. Logging. Logging is another beast. At one point I had a whole talk dedicated to logging, because a lot of people do logging wrong. The first thing is what to log. When I was a young Java engineer, I realized that some developers did logging pretty nicely, and some developers didn't, or didn't do at all. And so that's a problem. How can I solve it? I'm smart. I will create a Java agent, or something that will change the code at runtime to actually log every input parameter and every return value. And this way, then I will have a complete logging for every function, every method in my applications. And the developers, whether they are good or bad, I don't care. Everything will be done for them. And then I forgot that some stuff can't be logged, and there are still input parameters, such as passwords, for example. So there is no magic solution in that. You need to be careful about logging. You need to take care about logging as much as you do when you do code reviews. Oh, you know, you didn't apply this proper principle, or this one can be simplified. You should do the exact same for logging. Here you have like 100 lines method. Of course, it should be separated into different methods if they can, but you should add logging statements to understand what's happening. Second problem. I mentioned at the time we were actually logging to the machine and reading the logs to understand what's happening to solve a problem. But nowadays, you can't do that. The first thing is you don't know which machine to log into, because, again, distributed system. Second problem, you probably are using containers. And containers, they come and they go. So the machine that produced the log might be long gone. So you are not logging to the machine. What you are doing is you are pushing all the logs from all the machine to a centralized logging system. And in order to push it, you need the log to be structured. And most of the time, the logs are not structured. So you have an additional component in your architecture that actually groks the line. This is the level, this is a timestamp, this is a thread, and this is the log message, and makes it a JSON out of it. This component is fragile, takes time and resources, and doesn't bring anything to the table. Why don't you produce your log in JSON already? Who is already outputting JSON logs? Good. I saw somebody very enthusiastic. 2, 3, 4. Well, you are not so enthusiastic. Okay, a couple. Tomorrow, not tomorrow is the conference, but on Friday, that's the first thing you should do. You talk to your ops guy, or if you are the ops person here, you do it yourself. You ask your developer to produce JSON output, and you remove this extra component that is actually like unnecessary. When I started to work, I was forbidden to ever log to the console. Everyone was supposed to write logs on files, because then you could actually like rotate the log files and archive them. And nowadays you are using containers. Where do you log? Console. So it changes all the time. If you are an architect, you also need to find the right system. Is it better to push or to pull? There is no right answer. There are benefits, pros and cons in each solution. You need to think about how long you should store the log. If you are working in banking industry, it's not the same as if you are working on Candy Crush. And then you have a system to search and display the logs. Here are a couple of systems. Myself, I know the Elastic Stack better, but whatever rocks your boat. Now comes the most important part, tracing. So again, a very nice definition from Wikipedia, which I prefer mine, to be honest. Basically, yeah, every time you should prefer yours, which is better. Every time you do your own definition of Wikipedia when it's not worth it. But I still like to have the original. Anyway, tracing is the way to trace a business request across a set of components in your infrastructure to understand the flow. Right? It's very easy when you say it. It has been very hard for ages. Why was it so hard? Well, there were a couple of precursors, companies who were interested in that, For example, you might have used Zipkin or Jaeger in the past, and they worked pretty well. The problem is they limited you. How did they limit you? Well, if you choose Zipkin, now you had to choose a library for your application that was Zipkin compatible. All the components in your infrastructure were to be Zipkin compatible. Same stuff for Jaeger or for open tracing. And so as an architect, I don't like it, because when I want to choose something, a component, I don't want to limit myself. I want to have as many options as possible to choose the best one. When it happens, in general, you need a standard. And not like in the XKCD comics, where you have 14 standards, and you have a standard to bind them all, and now you have 15 standards. You need a real standard. And in order to have a real standard, you need to have a strong organization to actually create it. And this is what happens. There was a specification called the Trace Context Specification written by the W3C, which is a strong governing body. Who knows about this specification? One hand, okay. I encourage you to read it. It's 20 pages. It's quite easy to read. Even I could read it. And basically, the specification tells about a specific HTTP header which carries several information and that is like propagated from component to component through HTTP. And among these information are the two important ones, a trace. So a trace is a single business request that flows across all the components. And a span. And a span is something that happens inside of the component. A span is bound to a trace, which is for sure. A component has at least one span. I mean, something must happen in the components. But multiple spans are also possible. And spans, if there are multiple, are bound by a parent-child relationship, so that a span can have a parent, and a parent can have multiple children. This is the graphical view, and now I must check if it works. Yes, it works. So you have a single trace here, and then you have 3 components, and you have 3 spans, 1 span per component, X, Y, and Z. And Y and Z are children of X. X has no parent, it's the first span. I mean, that's not super high-level engineering, right? It's pretty straightforward. Now comes OpenTelemetry, because you, as developers, could do the HTTP propagation yourself. You can create the header, you can create a new span ID, but we are lazy by nature. I am lazy. I'm a good engineer, right? I'm very, very lazy. And we want stuff to be done for us. And OpenTelemetry comes and say, oh, I will do that for you. I have libraries and SDKs and tools to do that. Make no mistake, OpenTelemetry is much wider than just tracing. It does metrics, it does logs as well, but it does the distributed tracing part. And actually, it's a merge of open tracing and open census. Hence, the comment by Dimitri that you shouldn't use open tracing anymore. It has been merged, so if you are using it, you should probably migrate. It's a CNCF-backed project. It's still in the incubator phase. It's Apache v2 license, so open source all the way, and it has more than 5K followers on GitHub, which is a lot. Here is the architecture, which is, again, not very hard. At the center sits something called the OpenTelemetry collector. The OpenTelemetry collector is not mandatory, but it's advised to use it, because all the sources that can create OpenTelemetry data can dump their data into the OpenTelemetry collector. The OpenTelemetry collector defines a format in which it receives OpenTelemetry data. So basically, you can implement your own OpenTelemetry collector. What happens after the OpenTelemetry collector OpenTelemetry doesn't care. So that's not their problem. So you can push it to your database of choice and make the choices that basically are adequate to you, whether you value long-term storage, whether you value like cost effectiveness, this kind of stuff. The good thing is Jaeger and Zipkin, they offer an OpenTelemetry compatible endpoint. So if you're already using one of them, you can just open the port of OpenTelemetry, and then you can switch your application to send OpenTelemetry data instead of the proprietary Zipkin or Jaeger data. And nothing changes. You will still get the same data in different format. You can store it in the same place. And afterwards, you are in a very nice place because now you are using OpenTelemetry, so you can change your infrastructure for anything that is OpenTelemetry compatible, which is the right benefit. Who here is a developer? Same enthusiasm, I like it. Not that many people, but let's say 2/3 of the room. So this talk was written for developers. I've told about the context. Now I will tell you, as developers, how you should start to do OpenTelemetry. If you are an ops person, who is an ops? Not that enthusiastic. Who is a DevOps? Yeah, whatever that means, right? Nobody cares. You are a DevOps, that's good enough for you. Okay, so if you are an ops or a DevOps, I hope that you can benefit from this talk anyway, so you can tell your dev colleagues to watch it and to tell them to start helping you do your job. So if you are a developer, there are two ways to approach OpenTelemetry. The easy way, which I really recommend. The first is called zero-code instrumentation. So basically, as a developer, you don't do anything. It's a runtime concern. For that, you must have a runtime. It can be either the JVM, or if you are using Python, the Python runtime, or Node.js, or .NET, whatever. So if you have a runtime, you have zero-code instrumentation. Or if you are running on Kubernetes, you also can have zero-code instrumentation. That is very nice. It means your developers are not bothered. They don't need to know anything about OpenTelemetry. They continue to produce their code to implement their business requests. It's basically zero code, meaning zero cost. It's a runtime detail. If you don't have a runtime, if you are using Rust or Go. Sorry, must wash my mouth. You don't have these benefits. So in that case, you need to get the library and do the work yourself. Though most of the frameworks, they do it for you. You just need to copy-paste the right snippet, and they will do it for you through filters or proxy or whatever. This is also the path that you can choose once you've got enough data. Like if the zero-code instrumentation gives you enough data, but you want more control over it, then you can also choose as a JVM developer or .NET developer to use the library yourself. My advice, be lazy. Do the zero-code approach before. Get a server somewhere in the cloud or wherever. Shadow IT. Don't tell anybody about it. Get data. Use the data to solve the problem. And then go to your manager and say, look, I have solved it with OpenTelemetry. Now, can we create a project and have budget? I've worked in companies before. This is a really, really nice way to start. Okay, I've talked a lot, and I believe in the power of demo. I mentioned I'm a developer advocate, and we have this reputation to do hello worlds, like stuff that just works in a very limited context. So I wanted to, yeah, it makes you smile, right? So I wanted something a bit more involved, so this is my hello world for OpenTelemetry. The first, it's an API. and I've worked in e-commerce, so it's supposed to mimic an e-commerce distributed architecture. So first, you go through the API gateway, and the API gateway goes to the first component. The first component is a catalog. The catalog is a Kotlin Spring Boot app, and it requires additional data. It requires the state of the stocks and the pricing. So I actually have other components to have the state of the stock. This is a Rust Axiom application, but it just centralizes the warehouses. So I have another warehouse here, also Kotlin and Spring Boot, but this one is in GraalVM. So there is no runtime, so I can't address it the same way. I have Go stuff because it's very popular for whatever reason. I have a Ruby one just for fun. I'm using also Quarkus with regular Java codes. The pricing is in Python and Flask. I have another Python application here, but I will instrument it with Kubernetes just to show you how it can be done. And because I've given this talk a lot of times, and at the beginning, everybody asked me, hey, look, how does it work with asynchronous messages? Because if you are using HTTP, everything is fine, but without HTTP, how does it work with Kafka or with MQ? So I've created an implementation. Here, every time you query the catalog, it publishes some like analytics in MQTT, a broker, and I have a Node.js TypeScript application that subscribes to it and that propagates the context throughout the message queue. Good enough for you? Okay, I won't have the time to describe everything. I will assume that we are in a Java conference because it's called jPrime, right? So I will show you stuff about the JVM and Java, but everything is on GitHub. To deploy it, I will use Kubernetes, so I will use a virtual cluster to like separate between my business app and my infrastructure. In both of my cluster, I will have a collector, so I will dump everything from all the components into this collector, and both collectors will dump their stuff into a Jaeger instance. Shall we start? So I asked the demo gods to be with me. It's always a good thing to do. The first thing that I will actually do is to create the infrastructure, and I will describe the code to you in the meanwhile. So here, I will create the infrastructure where I have, it starts very well. I have closed orb stack. Too fast. Okay. Now I will create the Helm chart for the infrastructure. Now I've created a virtual cluster inside the host cluster, so I will connect to the virtual cluster. So here at this point, I can alias k equals kubectl, and I will k get pods all namespaces. So you've got a lot of stuff. And if I connect inside the vCluster, it might take a bit of time until everything is fine. But if I do the same, you will notice that I'm completely independent. And this little idiot takes ages to start. So meanwhile, I will describe to you the code. I will start with the catalog. There is nothing related to OpenTelemetry here. And I can still tell you it will work. Because in the Docker file, so what should be a runtime concern because I'm using containers becomes a build time concern, but again, depending who is creating your images, it might not be the problem of the developer. This is a multi-stage Docker file. 2 stages. The first one, I create the jar. So I compile, I create the jar. The second one, I add the OpenTelemetry agent. And then I run it with the OpenTelemetry agent. Yes, it has worked. It was a bit slow. Now I can deploy it. How do you think it works with GraalVM? Because with GraalVM, it compiles to native code. I can't have an agent. Well, with GraalVM, I'm not in the same position. In that case, I need to use how Spring actually does OpenTelemetry. I can't rely on a generic agent. I need to use micrometer tracing, the actuator, the tracing bridge, and the exporter. That being said, everything has been deployed, hopefully so, and I can curl a product. And then I can go on Jaeger, and this is it, folks. This is a single request that goes throughout all the components. And I will focus on the magic stuff, so the catalog. I receive a request here. I already have a couple of additional information. And I can have several spans inside of it. Here you can see that the find by ID, I'm using coroutines repository. I didn't write a single line of code to instrument it, and I still see that it's here. I have the thread name. If you are interested about low-level stuff, I have the thread name. Here you can see that I'm making a GET request to the inventory. If you want, you can also see the overview of your architecture in real time. This is not a diagram that you invented and reality differs. This is what's really happening. You see how many calls from one component to the other. You see which component depends on the other. Granted, other components did that before, other tools did that before, but this one is fully free. This is OpenTelemetry. Okay? And GraalVM, you've got the same. Here you get the same request. So I didn't mention it, but I'm using Postgres to store all my data in different schemas, and I'm using Redis for the pricing because I'm using Python underneath, and it's very slow. Everybody knows it, especially the VM people. We like to like this other stuff. So Python is very slow. I put a Valkey, the open source version of Redis, but now Redis is open source again. So if you don't follow, that's fine. I don't know. So I'm using Valkey anyway to cache the pricing on the catalog side. So here I have a couple of requests. For example, you see here that I'm doing a GET, and you have the exact, so it might be a bit small, but if I make it a bit bigger, I don't know if it will be as nice. Can you see it? Right? Yes, perfect. So you have the Redis request here. And it's still written Redis, even though it's Valkey behind, it's still written Redis, don't ask me why. You can also see the set afterwards. We put the stuff in the cache. If you are interested, I'm also using the, where is the DB here. You have the exact SQL request that I am making. I didn't generate it. It was Spring that did it for me, or Spring R2DBC actually, and it's here. Again, cost for the developer, 0. That's amazing. We can do a bit better. I told you about zero-code instrumentation through Kubernetes, but now I really must ask the demo gods because it might not work. So I will deploy the second version. Meanwhile, I want to show you something here. I have a couple of interesting, like, Kubernetes-related stuff that the container ID, but not much, right? Not much. So here, what I want to do is I want to have Kubernetes-related data in my spans, which makes sense. Perhaps I could just kill it again, because this one is instrumented now, and redo a request. It should work. So here you saw this one appeared. This recommendation stuff didn't appear in the first request. This one did appear. What did I do? This one is a Python app. And who knows Python here? Okay, not many people. Here, I have nothing in my dependency, so this is the dependency port. I have nothing in the dependency port regarding OpenTelemetry. I have nothing in the build regarding OpenTelemetry. I instrumented through Kubernetes, and only through Kubernetes. I added a new component, the OpenTelemetry operator, and in my manifest, in my Helm chart, I actually added one line. One line. So even the image creator doesn't know about OpenTelemetry. It's only the Kubernetes admin who knows about it. Of course, you don't have as much detail, but it's still good enough. You've got the GET request, and you've got the select. So that's poor man's information, but it's still better than nothing. And again, the cost is even lower than if you are using the runtime, the Java agent, or whatever. So thanks to demo gods, because it worked today. Okay, that's not bad. Can we do better? Now we have enough data. Sorry, so something I wanted to mention is now I've got additional data here. Again, I need to make it bigger. So I have stuff related to Kubernetes itself. I have the cluster name, I have the container name, the deployment name, the namespace, the node name, the IP. What did I do to change it, to get that? I'm using the official OpenTelemetry collector Helm chart, and I added only 2 seconds. Sorry. I need to remove my glasses, probably. Yeah, I'm at this age. It's in values, here. It's here. I added those 3 lines of code to get data about Kubernetes. Only that. So this is basically, again, like very low effort, and you get a lot of value if you're interested in your infrastructure, how it works to get data. So now we can do better. We already have a couple of spans inside our regular Java app. But imagine we want to have more control. We want to create more spans. We want to really understand what's happening inside. So the second step is to actually use annotations. So in order to use annotations, I will need to have an additional dependency, unfortunately. And in that case, this is the dependency that I want to use. This one, I have one additional dependency. I will just deploy the version, and I will comment the code. Where is my source? Kotlin catalog. So I knew Sebastian would be there, so I'm using Kotlin DSL, right, with the Kotlin router, obviously, the coroutine router. But then all my code normally is without annotations. But here I'm adding this OpenTelemetry annotation, so I can actually say, here I want this to create a span. And I want this method to create a span. And I want this method to create a span. By default, the name of the span would be the unqualified class name plus the method name, but you can override it. So here, instead of being product handler dot fetch product details, it would be product handler fetch. And I can add additional data. For example, let's say I have a bug, the pricing seems off. My assumption is that perhaps I'm getting the product ID X and I'm querying product ID Y for the price. So I want to see the price in the product ID in the span. So I can add one additional span attributes and I say product ID. Now, if you are a clean coder, again, whatever that means, it's not that great because you are passing the product and you need to artificially extract the product ID just to be able to annotate it. It's not that great, but again, it gets the job done. Now we get the product ID. If I make a request, and I will ask for ID 3, it's not this one. I don't find it. It should read something like fetch. If it's not fetch, then it's not this one. It's not this one. I'm on the wrong branch. No, I'm on the right one. The demo gods are not with me now. Let me check, please. So catalog app, Docker file. No, this is the right stuff. Here, let's try one again. I don't know. I don't see my fetch. I see my fetch. Sorry, it was a bit below. Was it there before? Okay, I don't know. Here is my fetch, and here you can see the product ID. So it was there before because I asked for product ID 3. Here it is. And now you can do the same in the Python application and check that everything works as expected. I have 6 minutes, so I will finish. Now, the real problem is, how does it work with asynchronous messages? So far, everything was done for us by OpenTelemetry agents or libraries or whatever. What I'm doing here is I will explicitly use the full power of the API to get the trace ID, to get the span ID, to construct again. So the specification call it trace parent. That's the name of the header that is propagated from like calls to calls. And I will put it as metadata in the MQTT queue. Let's do it. So I do this, I do the checkouts, and I do the upgrades. Takes a bit of time. Meanwhile, I added an additional dependency. The full power of the API is now at my fingertips. If I do the call, yes. Here you have this new analytic stuff. It's here. Do you see it? It's very small, but there is this new component and here. Here I have a new span called filter. Where does it come from? So now I have the full power of the API at my fingertips. What I did is I created a filter around my calls. So every time there is a call to any of those endpoints, it goes through this analytics filter. The analytics filter, of course, as MQTT configuration, gets the global OpenTelemetry instance. And now from it, I can actually, instead of letting the OpenTelemetry agent through the annotations or like implicitly create the span, I can create the spans by myself. So now the spans are not bound to a method, but I can create spans inside my methods myself. So here, that's what I'm doing. I'm creating a span, and I am putting it the parent, so I recreate by myself the parent-child relationship, right? And here I have this, so analytics filter span. And what I'm doing as well is inside the message, I will get, so since I have a global I have the OpenTelemetry instance, I can get the span context, so I can get the trace ID, I can get the span ID, and there is an additional stuff called flags, and I put everything inside the message as metadata. I'm using MQTT5, so I have access to metadata. If you are using MQTT3 or before, then you just need to make it part of the message. That's less clean, but it works as well. Then I put it, and on the Node.js side, I recreate the context from this. And hence, my message becomes part of the whole trace. And I have asynchronous and synchronous call inside of the same trace. That's all, folks. Thanks for your attention. You can follow me on the black screen. Let's do it again. Yes, you can follow me on the Blue Sky, on Mastodon, on Twitter, but Twitter, you know, is dying. If you are interested, no, it's not dying. You don't know. For me, it's dying. It's dead already. Dead man walking. If you are interested in the repo, everything is on GitHub. If you are interested in trainings as well about OpenTelemetry, I'm creating one full of classes and workshop one day. Ping me on any of those, and you have 2 minutes for question, or you want the coffee. It's up to you. Okay, no questions. You can find me the whole day, and have a good day. Thanks. Hello?
pushing all the buttons and hoping it turns out right. Always pretending I know best and I'm in control, but I don't know about this time, not this time. Boy, you're playing my heart like an arcade video game, like a past to win. Why are you playing my love like an arcade video game, going insane? Going insane. Going insane. Going insane. Going insane. Going insane. Oh, yeah, I've played the game. I'm running out of hearts to give away. One too many breaks, and I can't put me back together again. Boy, you're playing my heart like an arcade video game, like a past to win. Why are you playing my love like an arcade video game, going insane? Going insane.
In the back of my mind, there's a memory. You were holding my hand tight, kissing on a moonlit street. And I've been missing you since then. Yeah, I still smell you on my sheets. Loving you is sweet, sweetheart. Losing you is killing me. Baby, I can't breathe. Baby, I can't breathe. I remember your eyes like a warm sunset, rolling on my king-size bed. Moments that I can't forget. And I've been missing you since then. Yeah, I still smell you on my sheets. Loving you is sweet, sweetheart. Losing you is killing me. Baby, I can't breathe. Honey, I'm on my knees. Baby, can you hear me? Honey, you're all I need. Baby, I can't breathe. Baby, I can't breathe.
Don't you wanna be free like a waterfall, flowing on the riverside, places you don't have to hide. Sometimes you're alone, there's no one to turn to, feeling you'll be left outside, struggle with a heavy mind. Just breathe in life and light it up. Pray for those who lost it all. Yeah, you know we are one alliance. Why going back to nowhere? We played a game, we kind of lost it. We cannot change, going under. The road leads back to nowhere. Don't you wanna be free like a waterfall, flowing on the riverside, places you don't have to hide. Someday you find love, somebody to run to, walking by the ocean side, meet you at the mountain night. Just breathe in life and light it up. Pray for those who lost it all. Yeah, you know we are one alliance. Why going back to nowhere? We played a game, we kind of lost it. We cannot change, going under. The road leads back to nowhere. Yeah, the road leads back to nowhere. The road leads back to nowhere. Yeah, the road leads back to nowhere. You can't win if you can't give in. The road leads back to nowhere.
But you're waiting for me now. Or should we leave it in the past? I wanna make you proud. I wanna make it last. If you need a place to hide, I'll be your getaway. I will meet your tide. Get lost in the space between you and I will never break your stride. We can hold on, soak it in, wouldn't let it slip away before it begins. We could stay awake for hours, we can knock down all these towers. If you need a place to hide, I'll be your getaway. I will meet your tide. Get lost in the space between you and I will never break your sign to light up, yeah. And your heart is out of sight. I just wanna feel mine. Hey you, I'm gonna be the one for another one. Hey you, maybe then you'll know that I was never one. I don't wanna see you, I don't wanna fear you tonight. You don't wanna know me, you just wanna make sure you're right. I'm gonna be the one for another one. Maybe then you'll know that I was never one. I'm gonna be the one for another one. I don't wanna feel you tonight. Got me. Got me. Can I hear you? Got me. Got me. Can I hear you? I don't wanna call you. I don't wanna know what you think. I'm the one you go to whenever you feel like you're about to sink. I don't wanna just forget you, but I wanna be fine. I'll be waiting for a sign to light up, yeah. And your heart is out of sight. I just wanna feel mine. Hey you, I could become the one for another one. Hey you, maybe then you'll know that I was never one. I'm gonna be the one for another one. Maybe then you'll know that I was never one. I'm gonna be the one for another one. I don't wanna fear you tonight. Got me. Got me. Can I hear you? Got me. I don't wanna see you, I don't wanna hear you tonight. I don't wanna fight you, you don't wanna know if I feel right. Oh, I can't see the color running through your veins, and I can't breathe, and everything you do is bad. Love me. Oh, I can't see the color running through your veins, and I can't breathe, and everything you do is bad. Oh, I can't see the color running through your veins, and I can't breathe, and everything you do is bad. Love me.
It's what my heart needed. You stayed with me in the moments I felt most alone, until I didn't feel defeated. Without you, I would not be me. Without you, I'd never feel complete. It's the way you know you'll stay with me night and day. broken glass while I'm thinking in my head. I mind my own, I don't even break a sweat. Oh, this madness is insane. Why you still live in vain? I'm not the one, you're the victim of your own mistakes. It's time to hear the lights under the street lights, under the street lights. I'm not the one, you're the victim of your own mistakes. Untold stories, they were left behind. Silent breeze, I got nothing on my mind. This madness is insane. Why you still live in vain? I'm not the one, you're the victim of your own mistakes. It's time to hear the lights under the street lights, under the street lights. I'm not the one, you're the victim of your own mistakes. You're the victim of your own mistakes.
I caught myself looking back again, remembering the things you said, the memories of love we shared, the talk of growing old together. We were meant to last forever, but I miss the nights we used to go wherever, staring at the sky, counting on the stars, getting lost in your eyes, the perfect paradise. So take me back to the place where I belong. Cause I can't do this on my own. Yeah, I know you said it's over, but I won't leave this alone. Follow me, let's go through this black hole together. 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 As a dream and drift away, I hear a voice calling my name. I open my eyes and you're there. I hear you say, we're gonna run away to a distant hideaway, where we can stay forever, be together. Come with me to another galaxy, where we can be until the end of time. So take me back to the place where I belong. Cause I can't do this on my own. Yeah, I know you said it's over, but I won't leave this alone. Follow me, let's go through this black hole together. Let's go through this black hole together. Let's go through this black hole together.
last chance to find a little something good in this mess we've made. Don't tell me that it's over. We could start again. Life can make you sober, but I told you thick and thin, 'cause we don't quit. I'm all in, just don't fade out, 'cause I'm here now. If you need escape, we'll find our way. Just don't look down, 'cause I'm here now. Oh, oh, I'm here now. Oh, 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 'cause I'm here now. We'll find new streets, just know that I'm right by your side. Oh, I promise that I won't leave. I know we'll make it through this time. Don't tell me that it's over. We could start again. Life can make you sober. I told you thick and thin, 'cause we don't quit. I'm all in, just don't fade out, 'cause I'm here now. If you need escape, we'll find our way. Just don't look down, 'cause I'm here now. Oh, oh, I'm here now. Oh, oh, 'cause I'm here now.
When the tides are high, you can't keep pushing. It's getting harder to breathe. When the people crowd around your space, know you were safe with me. When the storms above start pouring, and you've got a lot to lose, my heart will keep on falling for you. I'll carry on and take the weight for you. When the storms above start pouring, and you got a lot to lose, my heart will keep on falling for you. I'll carry on and take the weight for you. try to let go of all of the nonsense that you put me through. I give it up to you, I do it all for you. Maybe this feeling's overdue. You're uninvited, you wanna hold me close, but I know what you have to. Yeah, yeah, yeah. Why are you hiding? Tell me what must I do? Come to you, come to you. You're mine, mine, mine. It's right, right, right. It's right, 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 right now. Why are you hiding? Tell me what must I do? Come to you, come to you. You're mine, mine, mine. It's right, right, right. It's right, 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 right now. Why are you hiding? Tell me what must I do? Come to you, come to you. I try to let go of all of the nonsense that you put me through. I give it up to you, I do it all for you. Maybe this feeling's overdue. You're uninvited, you wanna hold me close, but I know what you have to. Yeah, yeah, yeah. Why are you hiding? Tell me what must I do? Come to you, come to you. You're mine, mine, mine. It's right, right, right. It's right, 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 right now. Why are you hiding? Tell me what must I do? Come to you, come to you.
I'm drowning in something and I can't come out. Just show me loving. I need loving. Me, myself, ain't enough. It's like being a doctor to a crushing heart. I want you to know how bad it hurts. You got me beside along my heart. Are you dreaming of me now? The way I do. Are you dreaming of me now? The way hold me, lover. I need you, lover. 'Cause I'm falling in too quickly and I can't break free. Just hold me, lover. I need you, lover. Me, myself, ain't enough. It's like being alone in a crashing car. I need you to know how bad it hurts. Hearing the sound of my broken heart. Are you
Streams in places where performance is really important. Brave souls. Yes. So the other ones aren't using, I mean, because I've asked you and you, like there was like a whole forest of hands, I would say, of people using streams, right? So I guess we have like some hesitation towards it, right? And that's maybe the issue. So do you remember what Java 8 was a thing, 4,000 years ago? Everyone was like, yeah, we'll just toss dot parallel and we'll like reveal or use all the power from the computational power. It's just one method call and yeah, it'll be awesome. It wasn't, right? For like a few reasons. Again, I'm missing this like a brilliant math friend. Let's say I have this call, this method. Actually, let me go for the code. And I hope I didn't mess this up. Or maybe I did. Of course I did. Never mind. Okay, so we have this something. This is the implementation of concurrent mapping, or this like enriched, right? Kind of like think about this thing. I have 100 elements, okay? And I have this method, which is slow to double. It just doubles the number, only slowly. It takes 1 second to double, okay? Now the question is, how long will this whole thing run? I guess longer than Gunnar's implementation of like 1 billion like a rows or something. Any guesses, how long will it take? Can I get 5 seconds? Can I get 7 seconds? 1.5? 3? Don't be shy, it's time for fun. 15? 1? 26, someone said. There is one correct answer, I'm afraid. It depends. But if someone asks you, as it tells you it depends, then you obviously, like, how do you tell an expert? Because like, these self-made people, it depends, and you feel gaslighting, right? The real expert will tell you it depends on. And what's the on thing here? Yeah, like a CPU, like a size or common fork join pool, right, and so on. Exactly. So let me go here and just htop. So as you can see, I have 12 logical cores, right? And let's assume nothing else is running right now. So I have no noisy netbus. So how long will it take? Sorry? 4? Why 4? Okay, let's just skip it. Okay, let's just run it.
Sorry, I've run the wrong demo. Sorry, it's on me. So, time for a quick joke. How many ears did Captain Kirk have? 3. Left ear, right ear, and the final front ear. I brought it from Colorado, people. It's a good joke. 9 seconds. Why 9 seconds? Because 100 elements, each taking 1 second, so they divide it into batches of 12, right? So I have 12 times 8, that's 96, plus remaining 4 elements is the 9th second, okay? Perhaps we can do something about this, and the thing would be this, using gather is map concurrent. By the way, just so we make it clear, it was never a good idea to use Java's streams for like side effects, operations, using like HTTP calls, like data enrichment this way, okay? And I think it still doesn't. I mean, it's still not a good idea. But now let's say I'm using this map concurrent thingy. And why map concurrent thingy, right? We've established, okay, just one more question. How long would this take if I decided to go this approach? Huh? Roughly twice as long, right? So there is this thing, and I even asked like Victor Klank, who's the main author of this JEP, right, for stream gatherers, why isn't this thing advertised properly, right? So now it's like me, I have to annoy you about this thing, which is map concurrent. Like I like it so much, I even wrote, I don't think I ever wrote a blog post about a single API call, right? And I wrote it because I think it might be like really, really useful, right? So now if we do something like this, right? And as you can see, oopsies, I'm just switching between the lines, right? So I'm going this, and I'm using map concurrency, and it's the same tools, slow to double. How long will it take now? 1 second, someone said. Let's see. You were right. Who are you? Yes, I'll put a swag for you, okay? This lovely elastic webcam blocker. It's really nice because it's like bends, it's flexible. Elastic, right? Yes. Yeah, 1 second. Of course, it's a little bit cheating, right? Because this slow to double is doing, see, demo only please, thread sleep. So this is a good candidate to be run in parallel by stream gatherers, right? But of course, like they can be many more. In short, if this method is slow because it's CPU bound, going map concurrently won't give you anything. But if it's blocking due to other reasons, right? When virtual parts, threads can be like unmount and then mounted again, maybe it can be useful. But again, like streams, third side, like side effects, maybe no bueno. Right? Why is it still like kicking here? Sorry. Yeah, so we established 1 second. Okay, I guess we have time for more demos. Very, very fortunate. I have more demos here. Okay, so let's go for palindrome. Do you know what a palindrome is? Do you know what's palindrome of Ipswich? Does anyone have a dead parrot? Okay, I've learned what a palindrome is at the university, and then I ended up watching, what was it called? Monty Python, the Dead Parrot sketch. Really nice one, crème de la crème. Okay, now we'll be dealing with other sets of words, right? So I have diamond, jacket, race car, sherry, dolphin, and so on, and ends with radar, okay? And the task is the following. We need to find the palindromes, okay, among these words. So what we can do, first I'm mapping all of them to lowercase, right? Then I'm creating a sequential gatherer, which is this one. And as you can see, I'm ignoring my current state. What I'm just doing is I'm pushing downwards elements which have replaced all white space characters with nothing, right? And so basically this could have been a map call, which shows us that if we had only gather method, we don't need anything else, map, filter, whatever. Gather method could be, in theory, the only intermediate method in streams, right? Then we have filter is palindrome, and palindrome is, fun fact, if you reverse the word, it's still the same, right? Then it's a palindrome. right? And then, right, as you can see now, I can use this unique by length gatherer again. So I can map, gather, filter, gather, do whatever. It's just like a good intermediate operation. Right, let me run it. And these are the palindromes we have, right? Again, when they are unique by length, right? So we have race car, without space, kayak, noon, and so on. Does it make sense? Okay? I don't know what's the meaning of life, but I can try to answer like any other questions, okay? Now, let's go for pairs, okay? Some say that Java doesn't have tuples. And the answer is, in German, this is a good answer, jein. Haben wir hier jemanden aus Deutschland? Okay. Außer Gunnar? Nobody. Yeah, so the jein is like yes and no together at the same time, kind of like a Schrödinger's answer, sort of this. Am I explaining this correctly? More or less, yes. Jein, okay. See? Very nice. This is it. Maybe we should have this in standard API, I don't know, but this is how much it takes you these days to create like a tuple of 2, right, a pair of any type. Anyway, I want to combine these elements into pairs, all right? This is it. Right, this is, let me make this smaller and maybe, okay, maybe I should have added in like a line break here, right? So what we do here is this. This array list is our accumulator, right? And I have this integrator of a state element in downstream. And if our state is empty, we consume the element and add it to our sort of like a intermediate state or internal state, right? If the state is not empty, what we do, we push a pair, which is the previous element, right, and the current element. Fun fact, since Java 21, you can get first on sequences, right? And then we empty the state, which is remove first, and we return true, and so the story goes, right? And here, what you see in action is this finisher. I was told once, I don't know if it's true, that in France, when you invite people to a party, all right, and 13 guests show up, this is like terrible. Because it's like bad luck and so on. So actually, we can call an agency, and they will send a 14th guest. Okay, so this is like, let's say, let's do it this. If we finished processing all the elements, and our state is not empty, which means we have an element there, we can like, okay, this is the like, so you're not alone. Okay, like our artificial element, right? Let me run it here, and let's see if it works. See, yes, we have these pairs, right? So it's diamond, jacket, and so on. And we have at the end radar and our single, right? So radar is no longer single, okay? So this is the purpose of finisher, right? To finish with unfinished business, sort of, in this whole process of gathering, okay? Next thing is like length fluctuations, okay? Like, shameless plug, if you're into observability, then of course like Elasticsearch would be probably better. But let's say we need to detect these fluctuations. Let's say we have a sudden spike of CPU usage or sudden drop, right? So, and our autoscaler didn't scale down properly. Or you're monitoring in temperature, and when the temperature raises slowly, like 1 degree by 1 degree, let's say every 10 minutes, it's okay. If you see sudden increase, it might have been a Chernobyl, okay? So you want to know about this. So this is like this fluctuation. And in our example is this. If the length of 2 consecutive strings, it differs by 0 on 1 characters, it's okay. If it's more than 1 character, it's a fluctuation, and we want to be notified about this. I don't know. We need to like be paged, right? A text message, email sent, I don't know, big sirens, making a lot of noise, or whatever. Here I'm just printing it to the standard output, right? So what does it do? See, I'm calculating the absolute, right, difference of the length of the first element and the length of the second element. Because what this thing does, as you can see, window sliding creates me a stream of lists of strings. And because it's 2 here, we'll have like only 2 elements per each, right? So let's run this code and see these are the anomalies. So between noon and redder, there are 2 characters, right? So it's fluctuation. So as you can see, this is what you can use gatherers, oopsies, for these days too, right? And there are more uses. And there's, let me just go for another example, which should be, because I was searching for like more real life example, right? And again, timer, like for a shameless pun, right? And when it's about search, right, usually the good candidate is, yes, you know it, Elasticsearch, yes. So there are many reasons why Elasticsearch might be a good candidate. One of them is that unlike, let's say, the SQL, I just saw it when I was reading a book about Elasticsearch, right? One of the reasons is that fields can be kept in multiple times at the same time. It's not like live, like a live conversion or real-time conversion. It's just when you put data inside Elasticsearch, you can already say, okay, I want to have this field in this type and this type and that type, right? And one of the types is called ngram. Very good, very fortunate that we have you here, Gunnar. Sorry, like this couldn't have been better. Okay, so we have this thing called ngram, right, tokenizer. And do you know this situation when you type 1 or 2 or 3 characters, or let's say in e-commerce store, and it gives you a drop down with all the options, and sometimes the character in front the middle? Yes. I mean, maybe not so useful in Bulgarian, maybe not so useful in Polish, but really, really useful in German when you want to search, for example, for Heckscheibenwaschanlage. Okay, which is like rear window sprinkler, if I'm not mistaken. Yeah, Gunnar says like, okay. Sorry for butchering German. Yeah. So see, especially for languages like German, even if it says so here, like German, ngram tokenizers are nice. And what does it do? Let me just run real quick for you. So this is like without any additional parameters, right? When you tokenize as ngram this quick fox, it gives you the following, like Q, QU, U, then we go for UI, and so on and so on. If we change the parameters to be like minimum length 3 and maximum 4, for ABC, you get ABC, ABCD, BCD, BCDE, and the last one should be CDE, right? So it's like 3, 4, 3, 4, and so the story goes, right? Because you don't know how many, like, what would be your minimum to show in this drop-down, right? When people want to search. And this is especially important, for example, for all kinds of e-commerce or selling, because you don't really know what people are going to look for, right? Anyways, it's now not that I urge you to re-implement Elasticsearch. I mean, these sources are open source again, right? So there is no need for this, I guess. But let's say, let me first run it with the test. So I should have this test here, which is like, yes, this ngram test. Let's make sure if it runs and passes. Yeah, passing tests are the best tests, I would say. Yes. Yeah, so if we have A, B, C, and 3 and 5, we expect an exception because it should be like a difference maximum by 1. If we go A, B, C, D, and 3 and 3, we expect A, B, C, B, C, D, and C, D, E. And this is our example, right? So if I am running A over this string, right, A, B, C, D, E, with minimum length of 3 and maximum 4, this is exactly what I expect. These are my ngrams, right? Now, let's try to implement this using this ngram gatherer. So what actually happens here, right? Of course, I have like a constructor, right? These 2 fields. I check the invariant, so the length is correct and given and not negative and stuff. And my initializer for my internal state is going to be like string builder constructor, right? So my internal state will be string builder. And now, let me run this experiment, Gedankenexperiment, sorry. Yes. And this is our integrator. Remember the engine, right? So we have received the element. We append this element to a state. If we are processing A, we just append A to an empty string, right? Sorry. And then, is it the minimum length of 3? No. So we don't go here. Is it the length of 4? No. So we just continue processing with true. And so we process with B, and so we process with C. And now, finally, we have ABC in our accumulator, right? Temporary state. And so what we do, we push downstream ABC, the string of ABC, right? And then we jump here. Is it 4? No. So we continue. Here we put ABCD, right? So what we push down, ABCD, and was it the length of 4? Yes. So we remove the first character, which was A, and we push here, as you can see, BCD. And so the story goes. So as you can see, I received like 1 element, or 5 elements, which is like A, B, C, D, right? 5 characters. And I'm pushing like not always, sometimes in batches. So this is like, it shows you that stream gatherers allow you like, you don't have to state for like 1-to-1 or 1-to-many, right? You can map the elements however you wish, right? Yeah, this is the finisher. It doesn't do anything, as you can see. And isn't it beautiful doing nothing these days in Java? You don't have to go for this underscore ignored or whatever, just underscore, like totally nothing, right? Yes, sorry, I couldn't resist with this one. Okay, I would say this is it. Okay, one more thing, just before I forget. See, this is running on, sorry, Gunnar, one last German joke, okay? One last. This is running on localhost, or as some people in Germany say, localhost. And if you want to know how to run it, you go like elastic start local. You open this link, right? And if you have Docker running and internet running, then you can just go this thing, and this will allow you to run Elasticsearch and Kibana like on your machine, like a premium license. This is not production use. This is like evaluation purposes only, right? Okay, cool. So please remember, always, every conference, every meetup, every talk, right, whether the guy is from Poland or from Germany or God knows where, please provide the speaker your feedback and the organizers, right? So I don't know, sorry, how jPrime does it. Do you have an app? There's like a survey after the event. Please let people know, right? If you prefer to let me know, like sort of like privately or anonymously, I don't know who you are, so please fill this survey. If you're watching this on YouTube, right, there are 2 things you should do. First, hit the subscribe button, right? It's not going to be my channel, right? It's going to be jPrime's, okay? And the bell, maybe, I don't know. And then you can also fill this survey, even if you're watching this on YouTube. The link is somewhere, I don't know how they compile this, somewhere over there. If you fancy to follow me on social media, I'm on Xeter, Blue Sky, Mastodon, LinkedIn. No Instagram, sorry, no Insta. I'm one of the boomers, right? These are the slides. If you want to have the slides, the code and everything, this is the link. The link, sorry. In 3, 2, 1. Yeah, you take picture of this. I might want to take a picture with you in the meantime. How do you say cheese in Bulgarian? Okay, just say whatever you please. Okay, just so my boss knows I'm not slacking, sorry. Yes. This was Mnogo Bogadrodya. I shall be around for like 1 hour or so we can ask me questions about Elastic. If you want to run Elastic meetup at your company or whatever, please don't forget to get some swags, right? These are free, and the lucky winners, please come to the desk. Thank you.
Pictures of last night ended up all night. I'm screwed. Oh, it's a blacked out black, but I'm pretty sure it moves. Damn, last Friday night, yeah, we danced on tabletops and we took too many shots. Think we kissed, but I forgot. Last Friday night, yeah, we maxed our credit cards and got kicked out of the bar. So we hit the boulevard last Friday
Why'd you have to go and say that? Running out of time now, baby, tell me where's the love we had? I can't take the silence anymore, you gotta set me free. No, I just need an answer, take me from this misery. It's so cold when you leave me alone in the dark, yeah, it's freezing inside of my heart. Baby, I can't wait forever. Oh, can't you see it's now or never? It's so cold when you leave me alone in the dark, yeah, it's freezing inside of my heart. Baby, I can't wait forever. Oh, can't you see it's now or never? So come save me. Just come save me. Baby, I can't wait forever. No, I can't wait. No, I can't wait. Drowning all my feelings, I know I should put the bottle down. Ain't no sign of healing, so I get myself another round. I can't take the silence anymore, you gotta set me free. No, I just need an answer, take me from this misery. It's so cold when you leave me alone in the dark, yeah, it's freezing inside of my heart. Baby, I can't wait forever. Oh, can't you see it's now or never? It's so cold when you leave me alone in the dark, yeah, it's freezing inside of my heart. Baby, I can't wait forever. Oh, can't you see it's now or never? So come save me. Just come save me. Baby, I can't wait forever. No, I can't wait. No, I can't wait.
In the day, in the night, say it right, say it all. You either got it or you don't. You either stand or you fall. When your will is broken, when it slips from your head, when there's no time for joking, there's a hole in the plan. Oh, you don't mean nothing at all to me. No, you don't mean nothing at all to me. But you got what it takes to set me free. Oh, you could mean everything to me. I can't Don't be fooled by the rocks that I got. I'm still Jenny from the block. Used to have a little, now I have a lot. No matter where I go, I know where I came from. Don't be fooled by the rocks that I got. I'm still Jenny from the block. Used to have a little, now I have a lot. No matter where I go, I know where I came from. From living color to the scripts, to on the sex, to chain loaded this headline clips. I stay grounded as demons rolling. I'm real like for I told that real. That's just me. Nothing phony, don't hate on me. What you get is what you see. Don't be fooled by the rocks that I got. I'm still Jenny from the block. Used to have a little, now I have a lot. No matter where I go, I know where I came from. Don't be fooled by the rocks that I got. I'm still Jenny from the block. Used to have a little, now I have a lot. No matter where I go, I know where I came from. Broken this business, I've grown up so much. I'm in control and loving it. Rumors got me laughing, kid. Love my life and my public. Put God first and can't forget to stay real. To me it's a great thing. Fooled by the rocks that I got. I'm still Jenny from the block. Used to have a little, now I have a lot. No matter where I go, I know where I came from. Don't be fooled by the rocks that I got. I'm still Jenny from the block. Used to have a little, now I have a lot. No matter where I go, I know where I came from. Don't be fooled by the rocks that I got. I'm still Jenny from the block. Used to have a little, now I have a lot. No matter where I go, I know where I came from. Don't be fooled by the rocks that I got. I'm still Jenny from the block. Used to have a little, now I have a lot. No matter where I go, I know where I came from.
We stayed up all night, talking to each other, whispers under covers. You told me your life wasn't always easy. I said I know the feeling. I told you all about the scar on my shoulder, and you told me you were terrified of getting older. We stayed up all night, the first night. more, 'cause I'm gonna love you inside out. I'm gonna love you inside out. Nothing you say is gonna scare me now. Still gonna love you inside out. I'm gonna love you inside out. I'm gonna love you inside out. Nothing you say is gonna scare me now. Still gonna love you inside out. Love till we cried, made fun of each other, lost to one another. You held me so tight, and it felt like I was home, just the two of us alone. You said you don't wanna end up like your parents. They said, don't you worry, I'm not gonna let us. We stayed up all night, the first night of a million more, 'cause I'm gonna love you inside out. I'm gonna love you inside out. Nothing you say is gonna scare me now. Still gonna love you inside out. I'm gonna love you inside out. I'm gonna love you inside out. Nothing you say is gonna scare me now. Still gonna love you inside. What do you say, babe? 'Cause I wanna know. Oh, can I be there, babe? Through your highs and lows, yeah. When the lights come off and the night is done, everybody's left. Can I be the one if it's all I do? I'm gonna love you, ooh, ooh, ooh. I'm gonna love you inside out. I'm gonna love you inside out. Nothing you say is gonna scare me now. Still gonna love you inside out. I'm gonna love you inside out. I'm gonna love you inside out. Nothing you say is gonna scare me now. Still gonna love you inside out. I'm standing on the ashes. All the bridges are burned. I'm left with striking matches to the lessons I've learned. We're young and dumb and we don't even need a reason. Our hearts won't break 'cause we dance through the dying season.
Шефе, така. Okay, everybody. So had your coffee. Yes, found another job. How many of you have found another job here already? Okay, as I say another job, I say we are trying something completely different with this talk. So we're not only pure Java conference. And I'm very happy that we're going to talk not only about Java, but also about this amazing stuff called Topper. And we have somebody who is actually very much involved in it, like Bill Ginn. And yes, who is still doing microservices? For money, I mean. Don't hesitate.
Wow.
Who is doing monoliths? Who is doing microliths? You know what microlith is? It's everything else, yes. So, and I think that, you know, Docker is an interesting choice for microservices, so that's why I'm really happy that Bill Ginn is here, and he's going to tell us how to do it the best way. So, Bill Ginn, thank you for coming. Go ahead.
Cool. Awesome. Thanks for the introduction. All right. I'm super excited to actually give finally a talk in my home country. So thanks for the invitation. I have one question though. I'm curious how many of you, I know you are all using Java, but how many of you are using also other languages? Maybe not you, but your company have other teams that are using Java with Python, Java with .NET, Java with other languages? Yeah, okay, maybe 10, 20%, good. So in this talk, we'll see how you can create microservices in Java and also other languages, right? So I'm originally from Bulgaria. I studied computer science in Plovdiv. And since 2010, I've been in London. And I think I've done my fair share of Java programming. I've been committed to multiple Apache projects, such as Apache Offbeat, ISIS, Camel, Kafka, ActiveMQ, and so forth. So I've done quite a lot of Java. Then I started using more and more Kubernetes, right? And I have a book. If you go to this URL, katespatterns.com, you can actually get a copy, including a free copy sponsored by my previous employer. And more recently, I started working on Dapper at Diagris. And basically, we'll see in this talk what Dapper is and how it can help you create distributed applications in Java and any other language. To start with, we'll look in a couple of YAMLs, right? And we'll have a brief look into Kubernetes. And to guide this talk, I put together like a representative microservices architecture. I think this has the common elements of a microservice. Like you have a front end that talks to backend services through API gateway. In the backend, for this talk, we'll assume it is running on Kubernetes. So you have, shopping cart, checkout service. Most of these services talk to each other. Synchronous request reply. There is a message broker for asynchronous interactions. There is, of course, a couple of databases and even interactions with external services. And I would say one of the first things you will have to answer in that case, how can I run this beast, right? For example, how can I constrain services that consume lots of resources from affecting other services? How can I roll out those applications without breaking production? How can I configure them and so forth? And I think even for this audience, the answer here is no surprise. Today, the most common answer for operating large-scale distributed applications on-premise, on cloud is Kubernetes. So Kubernetes now is over 10 years old, right? 11 years old. And it lets you run distributed applications on, it puts them in pods and runs them on different nodes. I'm curious how many of you are using Kubernetes at work or deploying on Kubernetes? Okay, maybe half, roughly. And I won't go too much into Kubernetes, but just to cover up the basics, so Kubernetes, while it's an operational tool, it has a number of capabilities that helps also with the applications, right? For example, it will use containers to constrain your application in certain boundaries. Then it will use that to place your application, so it can do bin packing. It will find the right node that has sufficient resources. While doing that, it will also, if you have any configurations, it will attach those configurations to you. It can do different kind of deployments, so it can do rolling deployment, restart your instances in a specific order. It can direct traffic to specific services and perform health checks and so forth. If you look into all of these capabilities, Kubernetes capabilities, we'll see that most of them are around the life cycle of your application, right? But if you have an application, whether that's microservice, monolith, it needs more than life cycle. That application will need to talk to other applications. So you need networking. That application needs to interact with different state stores. So that's the statefulness. The application will need to talk to different APIs using different data formats. That's connectors. And these are all the other aspects that Dapper helps with. Right? So Dapper doesn't do anything about the life cycle of your application, but it helps your application to do these other things. Then briefly, let's look into Dapper. So Dapper, it stands for Distributed Application Runtime. It's a CNCF project. So it's an open source project in Cloud Native Computing Foundation where Kubernetes is. And if you look at some of the statistics, it's actually super active. Today, it's among the top 10 top 10% projects there. It's around number 14 out of 150 projects in CNCF. It has over 30,000 stars, 4,000 contributors, etc. So if you're curious how active it is, you can jump on Discord where there are 8,000 people. And really, to understand Dapper, there are two things to know. The first one is Dapper APIs. And these APIs are basically capabilities that you can call from your application. For example, there is an API called service invocation that helps you to connect services with request reply. There is an API called publish subscribe that helps your applications to do asynchronous interactions, right? There is API called state management that lets you access different kind of key value stores and databases. These APIs in the Dapper world, in the Dapper documentation, very creatively, they are called building blocks, but essentially these are APIs. And I think there are over 10 today APIs. In addition to those APIs, you get cross-cutting concerns, such as observability, security, resiliency. We'll look into those. These kind of capabilities that apply almost like horizontally across all the APIs. That's the first thing. And second, and the last thing to know about Dapper is the concept of components. And you can think of those components as the implementation, different implementation for the APIs. For example, if you want to use the state management API, you have to pick an implementation. That implementation can be based on DynamoDB, Cosmos DB, Redis, Postgres, you name it. If you want to use publish subscribe API, you pick an implementation such as Apache Kafka or RabbitMQ or SQS SNS. And all of these implementations, they are within Dapper. You don't have to do anything to add. You only configure that implementation with a YAML file. So from a developer point of view, a component is a YAML file that you configure and you start using those implementations. And you see there are 100 plus components today. Let's see how these two things come together. Right? On the left-hand side, you have the Dapper State API that shows a couple of operations, CRUD operations, right? For example, if you want to use the State API over REST or HTTP, you can see v1 state, that's the API, and then the name of the component. And on the right-hand side, you see the component definition, the YAML file I was talking. You give it a logical name. In this case, it's order store. And then you have a type, which says Redis. And after that line, there are Redis-specific configurations. This is the simplest version, like how do I connect to Redis that runs on Kubernetes in this case. And if I want to swap Redis to something else, okay, here we did it. As you see, nothing changed on the left-hand side. Your application doesn't change. Nothing on the API changes. We only change the component definition. Now it will be using Cosmos DB as its implementation, and you can talk from your application to Cosmos DB straight away. How does that look in practice? Let's say we are working on a couple of services represented by the different colors. Here I have 3 services. I'm running this locally with Dapper. Maybe for secrets, I'm using a local file with passwords. Then for PubSub between the services, I'm using Redis. And I see the third service there is also using some kind of in-memory state store. Right? If I want to move that application to Kubernetes, you don't have to change the application. Instead of local file on Kubernetes, you would be using Kubernetes secret. Sorry, in this case, actually it says HashiCorp Vault. You can use HashiCorp Vault, right? Instead of Redis, I'm using RabbitMQ. Instead of in-memory, I'm using Redis. So you can swap those. And if you want to deploy then on Azure, you can swap those to native Azure services. Like I can use Azure Key Vault for secrets and Azure Service Bus for PubSub and Cosmos DB for storage. And I think you get the idea. If I move on Amazon again, I can swap those to Amazon native services. And same for Google Cloud. So your code, your application doesn't change. You just give it a different YAML file, and the application becomes fully portable and independent. That's briefly what Dapper is. And at high level, you can think of Dapper as a process that runs next to your app. Your app can be in any language, really. You see at the top. From your app, what you have to do is you interact with Dapper over HTTP or using gRPC. And there are SDKs for these languages to interact with Dapper and use those APIs. Now, this raises the question, then what is Dapper? Is it a library? Is it a framework? Is it a platform? What is it? And the answer is it's none of those. It's basically a sidecar. It runs as a sidecar. That's probably the best definition. Now, sidecar is a pattern that was popularized by Kubernetes, but actually it started way before Kubernetes. I think probably one of the first famous sidecars was in Java. Netflix, they put their, I think, Hystrix and one of those libraries for network resiliency into a sidecar called Prana. And basically that was to make these awesome Java libraries available to other languages, right? They put that in a separate process that you can run to your application, and you can access those from other languages, like .NET, etc. And Kubernetes made this pattern much more easier, because now in Kubernetes, in your YAML file, this is how you deploy to Kubernetes, right? If you have, let's say, a Python app, you can easily add next to it a Java app, which would be, let's say, a sidecar. And then these both applications basically share the same life cycle. They are deployed together, they deployed on the same node. That means they can talk to each other over the networking, they can share storage, etc. This is how you would do a sidecar on Kubernetes. In this case, you see they also share a common volume to pass files. Now, you don't have to do all of that to add a Dapper sidecar. Actually, the only thing you have to do is, as you see there are two annotations you have to add to your application. The first one that says enable YAML, enable Dapper, right? And the second one is to give a unique ID to your application. With that, every time you deploy your application, you will get the sidecar running next to it, and you can start using Dapper. How does the sidecar get injected? First, you need to install Dapper on Kubernetes, right? Anyone who is operating your Kubernetes cluster, they would know how to install that, whether you would use a Dapper CLI, a Helm command, or an operator. There is like a couple of control plane services that get added to Kubernetes, and from that point on, you can deploy applications with Dapper enabled. How can you use then Dapper from your Java application? If you want, you don't need to have any kind of dependency to Dapper, right? You can use just the HTTP API of Dapper, so you can just do HTTP calls if you want. Or if you want, you can use the SDK. It's a single SDK that gives you more of fluent DSL to interact with Dapper. And you see there are other optional, Spring Boot integrations, Spring Boot starters. There is a Quarkus starter, test container integrations, IntelliJ setup, and so forth. And on the right-hand side is the simplest example. You instantiate the client, and you start calling the APIs I was explaining earlier. So that is really briefly what Dapper is. Now, I talked about the portability aspect, right? But that's not the only reason, right, to use Dapper. I would say once you have a couple of services running, the very first thing they will want is to talk to each other. And still the most common way is to do synchronous request reply. And when you start doing that, you need a number of things. For example, how do the services discover each other, right? How do I encrypt the traffic between the services? How do I trace that? How do I make the interactions resilient, and so forth? And you can all do all of that with Dapper. Let's say, on this example, I have the shopping cart that needs to call checkout service. And rather than directly calling the checkout service, if you are using Dapper, what you do is the shopping cart calls the sidecar. And the URL that you call the sidecar is typically, Dapper runs on port 3500. So you would call localhost 3500, and then the API. In this case, I want to call the invoke API, which is the synchronous request reply API. Then you see I have the name of checkout, that's the target service, and the order method, which means it will call /order. What will happen in that case is the Dapper sidecar next to shopping cart first will use its discovery method to find out where is the checkout service.
Once it finds that, it will call the checkout service sidecar. The checkout sidecar will check if the shopping cart is allowed to call the service. It will, pass all the traces, populate those, and call the checkout service on /order. If you get back a successful response, then the checkout sidecar passes the data back, and it reaches the shopping cart service. There are other things happening there. For example, if you enable MTLS, all the traffic between the sidecars will be encrypted. If something goes wrong and you have resiliency policies, those will be applied, right? So you get all of those benefits. And how do I do that call? Now, I don't have Java examples. I just have .NET, Python, and various others. But in this example, I have in this example, it's using the .NET Dapper SDK, and you see it's quite straightforward call with the name of the target service and the endpoint. If I want to do the same, let's say in Python, in this example, actually, I'm demonstrating two things. One is not using any SDK, so it uses Python's native HTTP calling capability. And the second thing is I am passing the target application name as a header. You see there is a header that says Dapper app ID checkout. So that's another way. If you don't want to use the Dapper's API with v1, checkout, method, etc., instead you can just pass a header. So this is less intrusive way of passing the target application name, and you call the sidecar localhost 3500/order. That sidecar will make sure the request to /order reaches the target destination with the checkout service. So this is, how you would use the service invocation. Now, why would you do all that? One thing you can do, for example, then is I can now start constraining who can call the checkout service. Maybe I want to allow only to the shopping cart app, right? And here, you see, I'm applying a configuration to the checkout app, and I'm saying by default, deny all access. So by default, you're locking down everything. And then further down, I am only allowing the shopping cart service to make HTTP post request to /orders. So that's the only allowed operation to checking cart app. And no other app using Dapper can access checkout service. Once I secure access, the other thing I can do is, for example, I can add a resiliency policy, such as retries, timeouts, and circuit breaker. And in this case, I'm adding a circuit breaker to the shopping cart app. Basically, what I'm saying is shopping cart app, when you are calling checkout, right? If there are more than 5 consecutive failures, stop passing the request to checkout app for 60 seconds. And only after 60 seconds, pass at most one request to check if the checkout app is back and healthy. Right? This is a typical circuit breaker, but because it's happening at the sidecar, that means it is working with any kind of framework, any language. It works the same way. And similarly, you can configure here a timeout or a retry if that's safe, etc. So to sum up, to use the service invocation, you only change the source application. You need to pass, the target application as a header or as a URL, and you just call the sidecar. The rest happens. Or there is no further, any kind of intrusion to your application. The rest stays the same. And on the target application, you don't have to do anything. It gets sidecar injected, and you don't need any code changes. With that, you get, all kinds of service discovery. Well, for example, you can use HashiCorp console. You can use a database to discover services. You can encrypt the traffic. You can apply access policies. You can even intercept all the calls and plug in, something like OpenID Connect, run WASM scripts, etc. So you can intercept all the interactions. That was basically the simplest, right? How do I do a request reply? But once you start increasing the load, whether that's the number of applications or the number of users on your system, you start facing other challenges. For example, how can I make the application more responsive? Maybe when the user interacts, I just want to return back quickly a response and process that downstream asynchronously? How can I decouple the life cycle of the services and their dependencies? How do I protect the downstream services from any kind of spike in the load, right? And the answer to all of this is put a message broker, right? That's the default answer. And to do that with Dapper, right, the whole idea is if you have some kind of a message broker, the first thing you do is we create a component for that message broker. Here I'm calling, this will be my order pops up. Yes, this is the component YAML file. I'm saying, okay, it's a type of Redis. And after that, I have Redis-specific configurations. Basically, how do I connect to Redis, right? The important thing here is the name, order pops up. From this point on, I can now, if I use Dapper on the publishing side, the checkout service, again, calls the sidecar on localhost 3500. But this time, instead of invoke, I'm using the publish API. That's why you see the word publish there. Then the name of the component, order pops up, and then the name of the topic. With that, the sidecar on the checkout service, when it gets the request, it will wrap the request in cloud events format. That is a common, quite popular envelope format for events. It helps further down, for example, for filtering and things like that. And the sidecar will deliver the message to the message broker. Of course, before doing that, it will check if this checkout application is allowed to publish to this message broker. Is it allowed to publish to this specific topic, for example? If that publishing fails for whatever reason, you again can apply resiliency policies. So resiliency policies are not only for service-to-service communication, but also when communicating with other components like message brokers, databases. If that's on the cloud, for example, you can retry publishing, etc. And the broker. And I think on the consumer side, there is again, Dapper will pick up the message and it will deliver it to your application on a specific endpoint. And here I would say the more interesting part is how the consuming happens. And it can happen in two ways. The first one is you can subscribe. Here I'm using Python, but I think the more interesting part is that you are consuming messages with the push-based approach. So when I say push-based, think about how Amazon Lambda delivers events to your function, right? When Amazon Lambda gets an event, it does an HTTP post call to your Lambda, to your function. And this is how Dapper push-based approach delivers these messages to your application. In this case, Dapper will do an HTTP post to /orders. And if you see the code, the Python code, actually there is nothing about pops up in it, and there is no even Dapper SDK. It just starts an endpoint on /orders that for the post method, right? That's all you need, and Dapper will do a post for every message. And if for any reason that post call fails, depending on your resiliency policies, it will retry. And if that post still fails, eventually the message can even move to DLQ. And that's the post message. So your application really doesn't have to bother about opening up connection, keeping the connections, confirming messages, etc. It just handles an HTTP request. There is also the pull-based approach, which is the more traditional messaging approach. In this case, I have a Go sample, which is using the SDK. You see there is a new Dapper client created, and it subscribes to order pops up to orders topic. This is probably the more familiar approach when you are using messaging. The only difference in this case is your application is not connecting all the way to the broker, it's connecting to the sidecar, and it's pulling the messages. And the sidecars make sure that the messages are delivered. That's the difference. On the publishing side, it's quite straightforward, very idiomatic way of publishing messages to any kind of message broker. The fact that it's just a Dapper client and you are publishing to the sidecar rather than connecting to concrete messaging system. And if you add Dapper into the mix and use Dapper to talk to a message broker, some of the things you can do with that is, for example, you completely can hide the actual semantics of the underlying message broker, right? You can use pull or push. You can do content-based filtering. For example, you can route different messages to different apps, different endpoints. You can also do aggregator splitter. For example, maybe you want to aggregate 10 messages and then join them together, and only then send to the message broker on the publishing side. And on the consumer side, you consume the message, you split it, and deliver each message independently. So you can do all of these things. If the underlying message broker doesn't have a native DL queue, like maybe Kafka, I don't think Kafka has a native DL queue, Dapper, for example, can make sure that any message that's not processed moves to DL queue. If the underlying message broker doesn't have message expiration, Dapper can do that. For example, it will make sure that no messages that have expired, that have a TTL, reaches the consuming application, etc. So you get all of these capabilities that might be missing on the underlying message broker. Now, that was PubSub. Next one is, let's say, accessing to state. I think all services, they need access to some kind of database, right? And some of the questions, for example, is, how do I control concurrent access? How do I expire data if it's used as a cache? How do I encrypt data before and after storing, etc.? And these are the things the state management API does. It's much more straightforward, and I think you're getting the idea now. I need to define the component for the state store. And in this case, very creatively, I called it state store, which is, again, using Redis in this case. Redis can be used both as a state store, and Redis stream can be used as a PubSub. Right? And once I defined the state store, you see I can now start doing create operations, read operations, delete operations, for example, using get. And what you get on top of these abstractions is you can control, for example, the concurrency. Do you want, for concurrent requests, should the first write win or the last write? How should the consistency work? Should it be strong consistency, eventual consistency? That's dependent on the underlying data store. You can set, you can use the data store as a cache. Even the underlying data store doesn't have time to live. Dapper, again, can make sure that the records you put there after expiration, they never reach, they cannot be read, right? You can encrypt the data before sending to the data store and decrypt when you are reading. So all of that is happening in the Dapper layer across different kind of state stores. And I think the more interesting thing here is now you can start combining these APIs. And one of those interesting patterns here is the outbox pattern. Right? The idea of outbox pattern is, Gunnar is waking up. Yeah, is to when you are writing to a database, you're also writing to when you are writing, to a couple of tables, you're writing to a separate table called outbox with the intent of another process reading those and propagating to some kind of messaging system. And to enable this behavior in Dapper is quite straightforward. All you have to do is add those 4 lines. Basically, I'm saying when I'm using this MySQL component, right, in this case it's MySQL, every time there is any kind of update to the data, any kind of change, publish that change to this PubSub component to the new order topic. So what will happen is if your application is using Dapper to write to a database, Dapper will make sure that that change reaches also a message broker. And here you can see you can combine different kind of databases with different kind of messaging system and get basically the outbox behavior. And the next thing, I would say, not all services are stateless and can be scaled indefinitely, right? So there's always a couple of services that are stateful. Typically, they have some kind of business process. In this example, we can assume, for example, the checkout service, maybe when it's processing a shopping cart order, first it has to call inventory service to reserve the inventory, then it has to call the payment service to authorize the payment. And if the payment succeeds, confirm the reserved inventory. Otherwise, release the inventory. And you want this behavior not to be only in memory, but you want it to be durable and persistent. Because if you restart the app, you want that process to continue and not have any inventory that's reserved but not sold, etc. The way to do that would be to use some kind of a Saga pattern, some kind of a workflow engine. And Dapper also has a workflow API. So the idea of workflow API, I'd say workflow is more than an API. It's also a programming model For example, you can have a workflow as shown here. Let's say workflows are, let's clarify what's a workflow. When I say workflow, I mean sequence, a collection of functions, which are called activities, as you here, A, B, C, D, a collection of functions that needs to be executed in particular order. They can be sequential, they can be in parallel, etc. And there might be some conditions, right? In this workflow, for example, I have, the first thing is activity A. That activity gets a secret, calls to some system to get a password, right? After that, there is a waiting for an external event. That typically can be waiting for a human input. Maybe somebody has to approve this action, right? Once you get that approval, then you have activity B and C that are running in parallel. They are doing completely different things. And only when both are completed, there is activity D that sends a message, right? And if this is implemented with a Dapper workflow, the whole execution gets persisted to the state store, to a database. That means it runs, when it started, it runs asynchronously. It can run, for hours, days, years, it doesn't matter. And it will run in a durable, reliable way. So if you restart to something, it will continue, right? And you can define, those in different languages using the SDK. So the first thing is you define the workflow, and then you start it. And you can see the API below how to start that. It's the 3500/workflow, and the name of the business process, and start, and that will start it. Yeah, so when you're using workflows, you can create different kind of patterns. For example, I'll look at 4 patterns. The common one is the sequence, where you have a chain of couple of actions that needs to be executed in sequence, but only, the next one starts only when the previous one finishes, typically because there is some kind of a dependency in the data you're passing. In this case, I need first to execute activity A, get the result from that, execute activity B and C. And these executions, they are not just in memory, right? All stages are stored in a database, and they're executed in a reliable way. Another pattern is split synchronize, right? The idea here is I'm getting a set of tasks that are not defined in advance. You see, I got those with get work batch. Then I want to run all of these tasks in parallel, and where I'm scheduling those activities. And only when all of the activities have finished, the process will wait for all of them finish, and this can take different times. For example, if one of those activities is taking considerably longer, in this case, it will wait for all of them to finish. Only then the whole business process will finish. That's the split synchronized pattern, briefly. And there are others, right? For example, another one is external trigger, when you want an external event to come and approve the workflow and continue. Another one could be timer. You can have some kind of delay between the tasks. You have a function here. You have an activity that after that activity finish, you have some kind of timer. For example, you can say here, wait for a couple of minutes, or don't execute it until a specific amount of time. And then workflow finishes, and you can schedule that workflow to start again as a brand new instance. So these are typical common, workflow patterns, and you can define those using the DSL in different languages. Once you define the workflow, you have a number of, management things you can do. For example, you can start that workflow. This is when it starts executing, and that, as I said, can take a long time, depending what's your workflow, or it can be instant. You can get the details, check its status, suspend, resume, etc. But you can manage the workflow. This also brings us to this common question you get: should you use choreography or orchestration? And I think that different school of thoughts. Choreography is basically using event-based interactions between your systems, between your services, or within the service, and it has certain advantages. You can add more participants easily, but the disadvantage is you don't know what's the overall state, because that's all distributed between the events. And the other approach is using orchestration, which is basically using some kind of a workflow engine to orchestrate the interactions as I showed you earlier. Now, when you're making these choices, you also have to pick different frameworks, right? For orchestration, you have to pick a workflow engine. For choreography, event-driven system. And these different frameworks, they have different programming models. They have different type of errors, etc. So with Dapper, you don't have to do this kind of choice. Basically, you can use one framework that can do both, and you have one way of, one SDK, one way of programming, debugging, and interaction. And typically, you may use, orchestration within the boundary of a single service, because you want to know maybe what's the status of the business process within the single service. And you use choreography when you have to coordinate the interactions between different microservices. And you can combine these easily with Dapper, right? So you don't have to pick one. And I think that's not the right question to ask. And there is more. I would say these are the most common APIs used with microservices. But there are other things you typically have to do. And this is not limited to microservices, by the way. This is valid for any kind of system. For example, very often you have to perform some kind of backup, right? At midnight, you want an app to copy files, to perform database dump, or every morning send emails. That is basically recurring tasks. And you can see here how straightforward it is, for example, to configure Dapper. In this case, it's called binding, a cron binding. I'm giving a schedule of 15 minutes. And every 15 minutes, this sidecar will call the application with the HTTP post telling it to do something, right? And you can use, you can make it daily, weekly, etc. The cron binding is stateless. So in this case, if you restart, or it will lose what has been run before. If you want stateful version, there is a jobs API, and the TLDR here is, it's again the sidecar is calling your application, but behind the scene, the jobs API will use some kind of a data store. In this case, it's etcd to store the jobs, right? And in addition to storing the job, it can also pass specific data. So in this example, I am configuring a job for backing up the database, but I can also give some kind of concrete instructions, some kind of metadata. And when this job is run, I think in this case, it just runs a minute after it started. It runs up to 10 times, right? The sidecar will call your app, and in addition to calling, it will pass the data you told it to do. Then your app can go and do its job, back up something or do something as a cron. Another thing, sometimes you want to protect access to certain sensitive resources. For example, if you have a file and you want only one app to read, right? You want to give exclusive access to only one process. Or for example, when you are consuming messages from a message broker, you want only a single consumer with a single thread to consume that because you want the messages to be processed sequentially. And in this case, you can use distributed lock. So rather than inventing your own locking mechanism, Dapper has the distributed lock API. You see here, it's an alpha, so this is quite a new API. Basically, the whole idea is you can create locks, and if there are multiple applications or multiple instances of the same application that are competing for that lock, only one of them acquires the lock. That becomes almost like the master that can get access to the resource. And this application has continuously has to continue and renew its lock. Otherwise, it's assumed maybe the application is dead and another application will pick it. So behind the scene, this lock will be backed by some kind of storage, such as Redis. But from your application side, you don't have to do any kind of locking logic. You just call the Dapper API and get lock access. Other things, for example, configurations on Kubernetes. These configurations, for example, can be backed by a Kubernetes config, but the same configuration can come from a database, or it can come from in this case, it says Azure app config, so you can use the cloud config. Your application can call the sidecar. In this case, you can see it's the configuration API, the name of the config, the key to get the configuration. Or if the configuration changes, the sidecar can push that change to your application if you want dynamic updates for configuration changes. Secret is very similar to configurations. It works with different kind of secret store, and it doesn't have this dynamic updating. So you can only read, and if any secret changes, your application has to read it. It cannot push the changes to your application, but it gives you access to different kind of secret stores on cloud services. And what about AI? So I'm curious how many of here are doing something with AI, like using chat API, agents. Okay, 2 people, not many, but Dapper also have a conversation API. This is quite a new API. Basically, it gives you access to different chat models. You see which ones here, Anthropic, Bedrock, etc. That means you can use the whole tracing, authorization, resiliency features. Plus, on top of that, it has, masking of PII data, etc. But you can talk to various LLM APIs from the same system instead of adding different libraries. And lastly, agents. If you are actually developing agents, you can use Spring AI, you can use LangChain and Crew, so there are many frameworks. But Dapper also has for now, it's limited to Python, Dapper agent version, a Python version that helps you create agentic applications. So if you look into agentic applications, actually, behind the scene, they are distributed systems, right? They use messaging, they use workflow, state store, and this Dapper agent is a Python wrapper on top of the Python SDK that helps you create agentic applications that can interact with the LLM, call various tools, etc. So if you are into that, that's the URL to check. And lastly, I think the way I look at Dapper is almost like a cloud-native middleware. So I was just putting some examples here. For example, if you are writing a distributed application, what kind of things you would need? First, you would need some kind of a runtime, like Spring, Quarkus, depending on the language, it can be .NET, Django, etc. And Dapper has nothing to offer here. It doesn't run your application. As I said, it runs next to your app. But then you need the application to do synchronous calls. You need various HTTP, gRPC, REST clients, or maybe service mesh. Then your applications will need asynchronous calls, right? You may need a workflow for some of the applications, and there are different workflow projects, access to different data stores, cron. I used in the past, Quartz. You can use cloud services, etc., etc. You see there are resiliency libraries and so forth. And I think if you're using Dapper, you can get maybe 80, 90% what those libraries can give you. And you don't have to add all of those libraries. And you may have to do these kind of things for different languages, right? With Dapper, you get all of that for all languages, and it makes the whole operations and monitoring uniform. And closing thoughts, I think we see different languages now becoming popular in different domains. For example, Java is still the best for business applications. Python is becoming the de facto language for AI applications, Go for more low-level stuff, .NET for anything to do with Microsoft Cloud, etc. And I think as developers, you will end up using more than one language pretty soon, if that's not already the case. And I think Dapper really makes it kind of handles most of these cross-cutting concerns for all languages. So check it out. And if you want to check it out, that's the last slide. Here I have a couple of links. Basically, dapper.io, where you can find all the others, YouTube channel, Discord channel, etc. That's all I have. Yep. If you have any questions around Dapper, Kubernetes, AI, I'm here to chat. So thanks.
Now and it still feels stuck in my lungs. And usually I go out at night and I think of you once. But if they start playing that song, I can't help but to think about us. Really thought I'd be done with the hardest part when I pulled myself out of your arms. Wish I knew that was only 'cause your hands are on my waist. You know how to do it so well. Really thought I was done with the hardest part. When I pulled myself out of your arms, wish I knew that was only the start. And now I'm falling apart 'cause last night was the very first night you didn't even try to go. I thought I might die. I couldn't even sleep at all. And maybe I'll get used to it. Oh, right now I just feel like shit. Now if I get
No matter how hard I try, you keep pushing me aside and I can't break through. There's no talking to you. It's so sad that you're leaving. It takes time to believe it, but after all is said and done, you're gonna be the lonely one. Oh, do you believe in life after love? I can feel something inside me say, I really don't think you're strong enough. Do you believe in life after love? I can feel something inside me say, I really don't think you're strong enough. What am I supposed to do? Sit around and wait for you? Well, I can't do that. There's no turning back. I need time to move on. I need love to feel strong. 'Cause I've had time to think it through, and maybe I'm too good for you. Oh, do you believe in life after love? I can feel something inside me say, I really don't think you're strong enough, no. Do you believe in life after love? I can feel something inside me say, I really don't think you're strong enough. Do you believe in life after love?
Fish swam out of the ocean and grew legs and they started walking. And the apes climbed down from the trees and grew tall and they started talking. And the stars fell out of the sky and the seas rolled into the ocean. And now I'm looking for a reason why you even set my world into motion. 'Cause if you're not really here, then I don't wanna be either. I wanna be next to you. Black and gold, black and gold, black and gold. Black and gold. Black and black and gold. I look up and see the night sky and see 1,000 eyes staring by. All around these golden beacons, I see nothing but black. I feel a weight of something beyond them. I don't see what I can feel. If vision is my only validation, then most of my life isn't real. 'Cause if you're not really here, then I don't wanna be either. I wanna be next to you. Black and gold, black and gold, black and gold. Black and gold. Black and gold. Black and gold.
My baby, my Valentine. Girl, I Girl, you don't make him have to play JD well. If you leave me, I go die, I swear. You are like the oxygen I need to survive, I'll be honest. Loving they got dirty me, I'm so obsessed. I want you to know, all day fucking in see you, open up, make I see you, my love one TT, we for make that Batman sing, oh. For your head, don't only one that don't care what they said. Cause your mother, now you the girl we carry to my head. Every night, now you I want to carry to my bed. Oh, no, no, tell me no, no, no. You can be my partner, never run you solo, low. I can do a blow, you know, to party go. I'm feeling what you're doing, oh, baby, carry go, carry go. I'll be honest, loving, baby, touching me, I'm so obsessed. I want you to know, every day, fucking me, see you, but now make I see you, my love, one TT. Make that Batman sing, oh, and she'll always get the best of me. The worst is yet to come, but at least we'll both be beautiful and stay forever young. This I know, yeah, this I know. She told me don't worry about it. She told me don't worry no more. We both know we can't go without it. She told me you'll never be alone. I can feel my face when I'm with you. But I love it, but I love it. Oh, I can feel my face when I'm with you. But I love it, but I love it. Oh, and I know she'll be the death of me. At least we'll both be numb. And she'll always get the best of me. The worst is yet to come. All the misery was necessary when we're deep in love. Yes, I know, yeah, and I know. She told me don't worry about it. She told me don't worry no more. We both know we can't go without it. She told me you'll never be alone. I can feel my face when I'm with you. But I love it, but I love it. Oh, I can feel my face when I'm with you. I can feel my face, but I love it, but I love it, but I love it. Oh, I can feel my face when I'm with you. But I love it, but I love it, but I love it, but I love it. Oh, I can feel my face when I'm with you. But I love it, but I love it, but I love it. I can feel my face when I'm with you. But I love it, but I love it. Oh, I can feel my face when I'm with you. But I love it, but I love it. And I know she'll be the death of me. At least we'll both be numb. And she'll always get the best of me. The worst is yet to come. All the misery was necessary when we're deep in love. Yes, I know, yeah, and I know.
You are a child, crawling on your knees, distorted, making mama so proud, but your voice is too loud. We like to watch you laughing, touch of paradise. Every inch of your skin is a holy grail I've gotta find. Only you can set my heart on fire, on fire. Yeah, I'll let you set the pace, 'cause I'm not thinking straight. My head's spinning around, I can't see clear no more. What are you waiting for? Love me like you do, love me like you do. Love me like you do, love me like you do. Touch me like you do, touch me like you do. What are you waiting for? Love me like you do, love me like you do. Love me like you do, love me like you do. Touch me like you do, touch me like you do. What are you waiting for? You're tryna put me in a worse mood, P1 cleaner than my church shoes, Really point two just to hurt me, All red lamb just to tease me, None of these stories on a list too, Made my whole year in a week too, Main chick out of your league too, Side chick out of your league too, You're so empty, need a centerpiece. 20 reps a table, girl from Ebony. Cut that ivory into skinny pieces, then I'll sign it with my name, say you love me, baby. You're talking money, need a hearing aid. You're talking about me, I don't see the shade. Switch up my style, I take any lane. I switch up my cup, I kill any pain. And look what you've done. I'm in love with a star boy. And look what you've done. I'm in love with a star boy. Every time my boy try to test me, Every time my boy try to end me, Pull up in the roadster SV, Pockets overweight, getting hefty, Coming for the king, that's a far cry, I come alive in a full-time mind. No competition, I don't really listen. You're in a blue moon, some up in your edition. House so empty, need a centerpiece. 20 racks of table, girl from Melanie. Cut that ivory into skinny pieces, then I'll sign it with my name, say you love me, baby. You're talking money, need a hearing aid. You're talking about me, I don't see the shade. Switch up my style, I take any lane. I switch up my cup, I kill any pain. And look what you've done. I'm in love with a star boy. And look what you've done. I'm in love with a star boy. Let me take a breath, babe. Let your number fall. Took a year like a bandit. Pop on my crib in a brand new vegan. Now she hit the grocery shop looking lavish. Star Trek roof and the wraith of calm. Boys get loose when they hear the song. 100 on a dash, got me close to God. When I pray for love, you just pray for cars. House so empty, need a centerpiece. 20 rents a table, cut from ebony. Cut that ivory into skinny pieces, then I'll sign it with my name, say you love me, baby. You're talking money, need a hearing aid. You're talking about me, I don't see the shade. Switch up my style, I take any lane. I switch up my cup, I kill any pain. And look what you've done. I'm in love with a star boy. And look what you've done. I'm in love with a star boy. And look what you've done. I'm in love with a star boy. And look what you've done. I'm in love with a star boy.
I've been trying to call. I've been on my own for long enough. Maybe you can show me how to learn. Maybe I'm going through withdrawals. have to do too much. You can turn me on with just a touch, baby. I look around and since it is cold and empty, no one's around to judge me. I can see clearly when you're gone. I said, ooh, I'm blinded by the lights. Now I can sleep until I feel your touch. I said, ooh, I'm drowning in the night. Oh, when I'm like this, you're the one I trust. I'm running out of time, 'cause I can see the sun light up the sky. So I hit the road in overdrive, baby, yeah. Since it is cold and empty, no one's around to judge me. I can see clearly when you're gone. I said, ooh, I'm blinded by the lights. No, I can sleep until I feel your touch. I said, ooh, I'm drowning in the night. Oh, when I'm like this, you're the one I trust. I'm just coming back to let you know I could never say it on the phone. We'll never let you go this time. I said, ooh, I'm blinded by the lights. Now I can sleep until I feel your touch. I said, ooh, I'm blinded by the lights. Now I can sleep until I feel your touch.
But it's the problem of
Been a long day without you, my friend. And I'll tell you all about it when I see you again.
Okay, so we will give additional.
We've come a long way from where we began. And I'll tell you all about it when I see you again. When I see you again. When I see you again. First you both go out your way and the vibe is feeling strong and what's small turns to a friendship and friendship turns to a bond, and that bond will never be broken and love will never get lost. And when brotherhood comes first and that line will never be crossed, established it on our own when that line had to be drawn, and that line is what we reach, so remember me when I'm gone. How can we not talk about family when family's all that we got? Everything I went through, you were standing here by my side, and now you gon' be with me for the last time. It's been a long day without you, my friend, and I'll tell you all about it when I see you again. We've come a long way from where we began, and I'll tell you all about it when I see you again. When I see you again. When I see you again.
Okay, please take your seats. Everybody who is going from the left door, there are lots of places on your left, by the way. So please don't stay there. Take your seats. There are tons of them. And there are very good displays. So you will see everything in details. So yes, this finally happened. This is the first talk for the conference about spring. Applause. Yay. Yay. Spring is everywhere. Okay, let's be honest. Who of you code for money and do it with Spring? Okay, lovely. So you came to the right place, I guess. I'm on Jakarta EE guy. I don't like Spring, sorry. But everybody knows that the Spring is the framework. I have nothing else to say about it, and I'm really, really happy that today Sébastien Deleuze from Lyon, wonderful city of Lyon, has come to make a talk about runtime efficiency, and he is the guy from the source who actually makes this efficiency. So I'm really happy and excited to present you Sébastien. Please welcome, applause, and the stage is yours.
Okay, thank you. I'm Sébastien Deleuze. I'm working in the Spring Framework team as a Spring Framework core committer. So my day job is to fix issues, bugs, implement features on the Spring Framework and in the wider Spring portfolio. You can find my social media account on seb.deleuze.fr, Mastodon, LinkedIn, and Blue Sky. Today we are going to talk about runtime efficiency with Spring, but I'm not only working on that. So if after the talk you want to talk about Kotlin, I have introduced Kotlin support in Spring, so I may provide information to you. I'm also working currently on bringing null safety on a Spring Framework and the wider Spring Portfolio API with gSpecify. I recently merged what is probably the biggest commit ever on Spring Framework to migrate to gSpecify notation to provide null safe API, so it looked like people are excited about that. I'm also recently, like just yesterday, I merged the Jackson free support. This one was split into multiple commits. And I'm also working on the GraalVM support for Spring. I work on that with the wider Spring team. But today, we are going to focus on optimizing your Spring Boot application with a regular JVM, with two technologies, CDS and Project Laden, and we are going to go more into the detail of those technologies. But first, let's talk about why do we care about runtime efficiency. Typically, when I talk with open source user, customer, it's about getting cheaper hosting. We all want to reduce the cost of the hosting of our Java and Spring application, either in the cloud and premise. Usually, this is done by using smaller instances, less CPU, less memory. And typically, this goes well with improving the sustainability of our workloads, because usually using cheaper server is basically consuming less resources. And also, we are in a world where the Java workloads, we deploy them as containers. And with containers, the Java ecosystem is a bit challenged by other technologies like Go, Rust, and other technologies that allow pretty good efficiency. So this is also why we want to optimize the efficiency of our Java workloads. Today, we are going to explore three variants. First, we are going to talk about CDS, class data sharing, which is a pretty old technology, but it has been recently more and more used. And then we are going to explore AOT cache, which has been introduced by Project Laden, which it tends to provide more efficiency with a regular JVM. This is available in Java 24, so it's available on production right now. And after that, we are going to see AOT cache with experimental Project Laden features, profiling, and code compilation. And this part is experimental, but is progressing pretty fast. We are going to talk about various ways of doing training runs. So training runs, the principle is that you are going to start your Spring application, potentially not entirely, but just the first part of the startup, in order to create a cache that will typically contain the classes that will be loaded by your application. And the goal here is to make the deployment run, typically on production, start faster, in order to be able to deploy your workloads on cheaper servers, even scale to 0 if the startup is super fast, consume less memory. So this is another way to reduce the cost of our hosting, and also to get a faster warm-up. We all know that it takes some time for a JVM to be warm, to provide the optimal peak performance. And so here the goal is to get to the peak performance super fast. So we are going to start with optimizing our Spring Boot application with CDS. So the requirement for Spring Boot plus CDS is Java 17, because this is the baseline for Spring Boot 3, excuse me. And we are going to require Spring Boot 3.3 because it provides a new feature that I'm going to explain just after. You will see that sometimes in my demo, I'm going to use java-d spring context exit equals on refresh. The goal of this flag that you can use on any Spring Boot application with Spring Boot 3.2+ is to basically begin to start your Spring application, but not doing the whole Spring lifecycle. So the goal here is to instantiate the non-lazy singletons, invoked after property set, which is the initializing bin method, and then exit. The goal here is to only get the application loading the classes in order to allow CDS or AOT cache basically be aware of the classes that are concretely used by your application to cache them, but not doing the rest, like contact, remote services, etc. So we cut the startup at the middle just to get enough information to get an efficient cache. The second feature that we are going to use, it's a teeny feature, but I really like it. It's a way for Spring Boot executable jar that you typically build with Maven or Gradle to self-extract itself into an efficient layout. Because if you are on production and you are not using build packs or you are doing custom Docker files, if you are just doing java-jar, the executable jar, you are not using the most efficient way to run Spring Boot application on production. You are consuming more memory, and the startup is longer than it could be. So you can extract it yourself using unzip or jar, etc. But it's better to use this provided command that requires no other tooling. So in your container, you don't need unzip or other tooling. You just do java-jar mod equals tools, the -jar, the name of your jar, extract, and then it will create a directory with the libraries that are directly in a directory, and then a tiny jar that will only contain the application classes and the class paths defined in a manifest file. And if you start with this tiny jar that will use the libraries in the libs, your application will start faster. It will consume less memory, even if you are not using CDS or IoT cache. So I recommend, if you are not using build packs, which is Spring Boot default way to create containers, I advise you to use this executable jar self-extracting command for any production deployment. So we are going to see a demonstration of CDS using the special flag that I show and this extract command. The goal here is to start faster our application and consume less memory. So we are going to use Spring Pet Clinic, which is a typical example. Maybe one day I will build a more recent example, but we are going to use this one. We are using Java 21. We could use Java 17 as well, but here 21 because this is the latest LTS. We build Spring Pet Clinic in order to create the executable jar. And then we are going to we are going to run it with the executable jar just to show you the baseline, okay? So if I directly run the executable jar, my application starts in 3.2 seconds. This is our baseline. Then we are going to use the extract command in order to extract our executable jar into an efficient layout on file system, no nested jar anymore, etc., just plain file layout. If we check the directory structure, you will see that we have a tiny jar and then a lib directory with all the dependencies. So it's pretty simple. Again, you can do it with unzip, but there is a few specific things in the way how it is architecture that it make it CDS and AOT cache friendly. Okay, now we are going to create the cache using the Spring context exit equal on refresh, and we add a CDS parameter to say create the cache when the application exits. So the application begin to start, automatically exit. CDS is creating the jar, so we will see that we have a .gsa file that will contain the cache, that will speed up the loading of the class, etc. And then we are going to start again our application using the cache that CDS has created, using this shared Rchef file equals Spring Pet Clinic GSA. And then you can see that our application starts twice faster with not much effort. We had no involved things to do. It's pretty simple. So I'm going to share various data points in this presentation. So here you can see that if we take the executable jar startup time as a baseline, just unpacking it, zero effort, zero CDS, nothing, it already starts faster, okay? And if you are using CDS, that can be potentially combined with another optimization that I will detail a bit after Spring IoT. basically, you start your application twice faster, and this is on local machine, but also in the cloud. I have been able to verify it in various environments. Of course, it depends on your application. It may be faster, slower, but the key point is that you have an extra boost, a significant extra boost with very low constraints. On memory side, we see lower memory consumption, not at the level that we see with GraalVM native images, but still interesting to get 20% reduction. It's more memory available for your heap, and so you will be able to get better performance, or you will be able to use smaller instances. A lot of people ask me why CDS is not used more, because it's available since Java 9, I think. It's pretty old technology. So the first reason is that CDS has been maturing a lot since Java 9, since introduction, and in Java 17 and Java 21, it's much, much better. Also, initially, it was mostly designed to share multiple Java applications running on a single instance, but now with container, we have one Java instance per container. And so the technology has evolved to adapt to modern constraints. The other reason is that there is a lot of CDS rules to follow in order to make it effective. If you are not following those rules, your application will start, but you will see no gain. And so a lot of people, before we provide this support, try to use CDS, see no gain, okay, we stop using it. So the first rules of the game between the training and the deployment run, you need to use the same JVM on the same operating system with the same patch version. You need to take care about the class path, and this is why we created this efficient extracted format that follows the CDS constraints. The class path must be specified as a list of jar, no directories, no star wildcard, no nested jar. So if you are directly using a Spring Boot executable jar, it will not work because it is a nested jar. And also the deployment class path must be a superset of the training run 1. So you may have the possibility to add more library during the deployment run compared to the training run, but it must be a superset and the new libraries must be added at the end. Also, there is some simple things that could break CDS assumption, and this is why this is a good fit to put everything, I think, in a container to basically be in control of those constraints. If you just copy the files between the training run and the deployment run, it will not work, simply because the copy will basically modify the timestamp of the jar, and CDS requires the timestamp to be the same because this is a fast way to check the files have not been modified. SHA-1 computation will be too slow. And so if you copy the files, take care about using the small argument to keep the timestamp, otherwise CDS assumption broken. And lastly, the training run is not obvious. When should we run this training run? How should we run it? It may try to connect to remote services. So I think this is for those reasons that CDS has not been used very widely before today. So the main side effect you should take in account is that potentially the database, your application may try to reach the database because it happened pretty early in the Spring lifecycle. So we try to stop the Spring lifecycle pretty early when we use the special exit flag, but you may have some database connection. So this is why we have documented on this page how you should configure your database to avoid early database connection. And even without CDS, that could be a best practice that your application do not try to contact your database when it's starting. For GPA, for example, you can see that it's about configuring explicitly the dialect. Here, this is PostgreSQL. And also disabling the JDBC metadata at Hibernate level. And of course, you should not try to initialize your database during the startup because otherwise, of course, a connection will be made. And you can just define that by default, and you won't have any side effect for most CDS use case. But there's still a lot of integration. So we have tried to provide the CDS support in Buildpack, which is the default way to create container images with Spring Boot, to have everything included. Like if you are enabling a special flag that I will show in my demo, you just run Maven Spring Boot build image or Gradle boot build image, and Buildpack and Spring Boot will automatically do the training run, create the CDS cache, put it in a container image, potentially with the Spring IoT optimization, and use automatically the CDS optimization when you run your container. And I think that's pretty neat. I'm going to show you that in a demo. So here we are going to first build our container with Buildpack without CDS enabled, just to have a baseline in terms of startup time. So yeah, Maven boot build image. We are basically building our container image automatically. Okay, it has been built. We are going to run it with Docker run to have our baseline for the startup time. And our application starts in around 3 seconds, okay? Now, to show you how it is easy, I'm just going to enable CDS with a Buildpack flag that we set at the level of the Spring Boot Maven plugin. Just CDS enables equals true, okay? And then I'm going to rebuild exactly the same command, Spring Boot build image. And here, Buildpack will automatically perform the training run, put the file, the cache file in the container image, and configure everything that when we run our container, the Java command will use the cache that has been created. So the cache file is within the container, so you can deploy it on any kind of run platform. It's a bit longer because there is a training run. And we are going to run again this container image that is self-contained. And we can see that our application starts in 1.8 seconds, which is much, much faster. And again, not a lot of constraints. It's pretty easy. So the benefits are a bit lower than GraalVM native images, but the pain is much lower, and it's still regular Java, so you don't have any compatibility issues, etc. So that's CDS, that's the old technology. Let's see what we can do with Java 24 and AOT cache. So before going more in detail, AOT is used in various contexts for various different things. When I see AOT cache, it's the CDS successor that has been developed as part of Project Leiden and that has begun to be available as part of Java 24. Okay? AOT cache, JVM technology, successor of CDS. When we are talking about Spring AOT, I don't go too much into the detail of Spring AOT in this talk. It's mostly CDS and AOT cache focused. Spring AOT is a feature that we have developed primarily for the GraalVM native image support, so it's mandatory for GraalVM support. It's basically compute a static version of your application context to speed up the startup time and provide native compatibility, and you can optionally use it on the JVM. But it introduced some side effects and constraints, like you need to pre-compute the configuration file for specific Spring profiles. So this is why, with the open source stuff, I advise you to use primarily, initially, just AOT cache, and then you see if Spring AOT could be a good fit. AOT cache has less constraints. So AOT cache is coming from Project Leiden. It has been integrated into Java 24, recently released, the last version of Java available. With this JEP 4.8.3, ahead of time, class loading and linking. And this is mostly an improvement of what CDS provide. But this is the beginning of the story. Java 24 is the first version to provide AOT cache, but AOT cache will get improved in Java 25, 26, 27. So I think this is a good investment for the future. The requirements for IoT cache are Java 24, because this is the first version that provides it, and still Spring Boot 3.3+. We don't provide Buildpack support, so here I'm going to show the demo with just the manual version that I showed previously with CDS. So let's see what changed compared to CDS. We are going to do the same thing. We are going to start our Spring Boot application with IoT cache instead of CDS. So it begins the same way, just we use Java 24 instead of 17 or 21. We then build our pet clinic application. Nothing changed. We are going to use extract command that we use because it's CDS and AOT cache friendly. If you try to do stuff manually, it won't work, believe me. So here we have an AOT cache friendly layout of our Spring Boot application. And then we are going to use the record mode of AOT cache, which is not going to create directly the cache, but it's going to create a kind of profile of the classes that are used, etc. So it's kind of intermediate step that will create an AOT conf file that I'm going to show you. Okay, so pretty small AOT conf file. And then with this file, as a second step, I'm going to use the AOT mode create in order to create the cache. So instead of CDS that does that in one step, here, almost the same in 2 steps. But interestingly, you could potentially just do the first step on production and then create the cache that is taking more time and more energy on your CI, etc. So more flexible. So the .iot file is the equivalent of the GSA file that we had previously. And if we start our Spring Pet Clinic application with this command, so we just remove the other parameter and we just keep the name of the cache. So pretty similar to CDS, you will see that we start our application in 1.3, 1.4 seconds, which is faster than CDS. The difference is not huge, but again, this is the beginning of the story. IoT cache in Java 24 is the first incarnation, and the difference between CDS and IoT cache is going to be bigger and bigger. But still, it's still a boost. We are now at 2.2x faster startup time compared to executable jar with the same low constraints. In terms of memory consumption, the same. I hope that IoT cache will provide more memory reduction benefits in the future, but right now you can expect the same thing than CDS, 20% reduction after startup and after GC to get things easy to compare. Yeah, hopefully that will provide more benefits in the future. So this is what you can use today in production. Of course, it requires a bit of integration because you need to do this training run, etc. But again, this is actionable even on big historical legacy projects, even on a recent one. But if you just migrate to Spring Boot 3.3+, you can use that even in big projects. And I would say that the benefits will be even bigger on big projects with a lot of dependencies because that will speed up the loading of all your classes. It also caches the class path checks, etc. So it can really be pretty nice on big application deployed on the cloud on small machines. But more is coming. Like I said, IoT cache in Java 24 is just the beginning of the story. So the upcoming features that are coming, there is this JEP 5.1.5, ahead of time method profiling. This one may arrive short middle term. It's a way to get the profiling data from your production. So here you will typically get those profiling data directly for your production deployments in order to warm up your JVM faster, okay? The second improvement is JEP 5.1.4, ahead of time command line ergonomics. This one is to allow to create the cache with a single command. You have seen that with CDS, 1 command was required to create the cache. IoT cache, 2 commands, record and create. This JEP is just a quick shortcut to be able to create the cache with 1 command. And the last one, which may happen more long-term because it's more involved, it's more experimental, it's ahead of time code compilation. It's about taking the native code that the JIT has compiled on production and directly use it in your cache in order to speed up the startup time and warm up your JVM much faster. We are going to see a demo of that, and here I just take a bit of time to say that here we are not going to use the exit flag and doing stuff like that. Here I'm going to do a demo of what I would expect you to deploy on production, like the profiling data, the code compilation required to have a realistic workload that is applied to your application. And so the easiest way to do that is to basically generate the IoT conf file that will profile your application on production. Some people try to do that with tests. Disclaimer, it does not work because the class path is not the same and various other constraints. So don't try to compute CDS or IoT cache based on your test. I understand that that could be attractive, but that does not work at all, okay? So I think the 2 options are really what I showed previously. You are doing in a kind of automated way, even like Buildpack with no connection with your remote services. You try to compute the CDS or IoT cache just for startup time and memory consumption. Or what I'm going to show here, you try to deploy it on production to get the profiling data and the code compilation directly from production. So here I'm going to use a special build of Project Laden. So this is the experimental one, not available into a regular Java version. I'm going to build my pet clinic application like I did previously. Okay, I'm still going to use the extract command because, again, it is AOT cache and CDS friendly. So I'm using this optimal layout that will allow to take advantage of the AOT cache optimization. Okay, and now I'm going to do things a bit differently. So I'm trying to start my application in record mode, but here, no exit flag, so I will keep it running to simulate a production application. And to simulate the production workload, I'm going to use a little tool that I like a lot, OR, in order to apply a fake workload. And here you will see that your application is going to warm up progressively, so we see that the throughput of the requests are improving because our JVM is getting warmer. In practice, you will just apply some production workload, so you don't have to apply this kind of thing, except if you want to do it on staging. And so here, I have recorded a profile that includes some information from the production, that includes the profile and the AOT code compilation. Then I'm going to use the create mode in order to create my cache. But here, I'm taking benefits of both AOT profiling and native code compilation. Okay, so here the cache is a bit bigger, but it will be potentially directly present into the production. And so I'm going to start my application using this .aot cache. And we are going to see a few interesting things. So same, I'm remove the over parameter. I'm just using the cache that has been created. Okay, and now I see that I'm able to start my Spring application in 0.9 seconds, so much, much faster. And I think that's pretty cool. And even more interesting, the warm-up of my application is almost instant because my Spring Boot application has been warmed up on AOT side. And so when I deploy it, it provides the peak performance almost immediately. So if we see related data points, we see that with this experimental version of AOT cache that basically will be available in a few months, year, not sure, we are able to start our application 4 times faster, again, without that much constraints, if I do the integration of that with my production. So that's basically twice faster than the current incarnation of AOT cache. And even more interesting, and I think this is the most interesting diagram of this presentation, this is basically showing the throughput of my Spring application after the startup. The blue line is the baseline. The blue line is a regular JIT that we all know, and here I'm just exercising a single endpoint, so it just takes 30 seconds to warming up, but in practice that may take much more time on a more complex application. And you can compare it with the red line, which is just with AOT profiling, okay, from the production, and we can see that it's able to warm up your JVM much faster. And this one could arrive, could be available short middle term, so that's interesting to see. And if I'm using the code compilation that has been done on production, here the warm-up is even faster, but this one will take a bit more time to be available in the GA Java version. You can see that there is a difference of peak performance between the blue, red, and yellow line. It's a kind of limitation, a bug, that will be fixed by the Java platform team, hopefully. In theory, when this will become available in a regular Java version, the peak performance should be the same. It should only provide benefits to have faster warm-up. And faster warm-up is pretty cool because we can potentially scale our application to 0 and just start them when basically some workload is coming, kind of serverless mode. It can allow us to scale from 1 to 2, 3, 4, 5 much faster and be able to absorb a lot of workload. So imagine that you have a website that takes a huge peak of workload. It will allow to add instances and have them effective super fast. And that's pretty cool to be able to do that with a regular JVM in the future. So if we want to compare the GraalVM, Project Crack, and AOT cache, I have not put CDS because AOT cache is the CDS successor, so I want to simplify a bit. Graal VM native, I like it. I mean, I have been spending so much energy and time to provide Spring support for Graal VM native images. It's pretty cool. It allows to have instant startup, so dozens of milliseconds, much faster than what we have seen today. Instant warm-up, super cool. For peak throughput, if you just use the community edition of Graal VM, you get lower peak throughput because there is no JIT involved and the optimization done are less effective. So the peak performance can be significantly lower. It's possible to do a training run to get closer to the JIT peak performance, but that involves some pain using Graal VM, so not the open source version. You need to do a training run plus the other native image constraints. So in practice, what I see is that almost nobody is doing training run with Graal VM because this is too complicated. Memory consumption is reduced, so that's pretty cool. But there are pain points that limit Graal VM adoption. And again, Graal VM native image is a good technology, but it's maybe not for every project, not for everybody. Compilation is very slow, and there is compatibility issues because Graal VM require explicit configuration of reflection, proxies, resources. And so in practice, you need to have native support for the libraries that you are using. Spring is going to automatically create the right reachability metadata, but still, you will likely have to do some extra configuration to get native support and combine with the slow feedback loop because very long compilation plus manual hints, the developer experience is not crazy good. And I think this is what is currently limiting Graal VM native image adoption, but still interesting and useful for some projects. And that's a good technology. Project Crack, I think, yeah, it has stronger issues. So initially, Project Crack looked like the best of the two worlds. It provides instant startup like Graal VM, but it's on the JVM. So you say, yeah, no problem. Why do you need AOT cache? The reason is that when you are deploying your application in production with Crack, you are not starting it. You are going to restore it, basically, to resume its execution. And so there is a lot of issues that are coming from open file handle and sockets that need to be closed after the training run, reopen after. Some libraries do not provide the right APIs for that. So in practice, it's very hard to have the right compatibility. It's Linux only. So if you are on Windows or Mac, you need to use Docker. And the most important issue, Crack is a bit hardcore. It's going to serialize your JVM memory on disk, and so including your secrets, your passwords, etc. So you can't ship the cache file of Crack usually with your container because that will be a terrible security issue, and it limits its adoption. So personally, it's not an official Spring advice, just my advice. I do not really recommend Crack on production. I would either use Graal VM if you are OK to swallow that pill and accept the constraints, or use AOT cache to optimize. And I think AOT cache got some inspiration from Crack, but in a more first-class way. It's not just serializing the memory representation. So AOT cache 2x to 4x faster, fast warm-up with the training run, when basically it will be supported. Memory consumption is slightly reduced, fast compilation, and there is some side effect, but very few, like this early database connection that can be fixed by customizing the configuration of your Spring Boot application, or just if you are using the production deployment that I showed, basically you don't care because your training run is your production run, so there is no really side effect. There is just a work to integrate AOT cache with your production. And before stopping, a few more things about the future. First, AOT cache is going to be combined with various other improvements of the Java platform that are coming, and that are coming pretty aggressively because I'm not sure if you have seen, that's pretty recent. Compact object headers, that is a way to reduce the memory consumption of the JVM, is going to ship in Java 25 before the end of the year without an experimental flag. So there is other improvement like stable values and over JEP. So IoT Cache is going to be combined with other Java platform improvements, and together, I think that will provide a pretty nice efficiency improvement. There is also other technologies that I do not cover in detail today, but in Java 24, one of the main painful issues with virtual threads, the thread pinning issue that was preventing wider adoption, has been fixed. That means that in the next LTS 25, Java 25, I think virtual thread will be ready for wider adoption, and we will be able to enable in most of our projects. So that's pretty cool, and that's a good combination with IoT Cache, even if the two are not directly related. And if you follow a bit the work that is done on experimental side on Project Leiden, there is some very interesting discussion. For example, here we have Alexei Chiplev, who is basically merging an IoT-only mode that do not perform any JIT during the runtime and only rely on the IoT information of the profile and the native code. So it's a bit like if we want to make the JVM work like native. Of course, it will be slower because there is less imprecise optimization, but there is also lower memory consumption because you don't have to activate all the JIT, etc. So I don't know if that makes sense or not, but what this discussion show is that Project Leiden may allow to make the JVM more flexible. You will decide how much basically infrastructure you chip to do the JIT optimization, how much optimization you are doing ahead of time, and so potentially you will be able to configure that and get the behavior that fits with your needs. So again, maybe that's just an experimentation, but I think that's pretty interesting to see that they are exploring various options. And lastly, and that will be a bit of a teaser, Spring IoT, which is not very detailed in that presentation, we are going to announce next week at Spring I/O some very interesting improvement in Spring IoT that will bring significantly better benefits with Spring Boot 4. I can't talk about that because that will be announced next week, but follow the upcoming announcement. And Spring IoT and IoT Cache combines together very well. And so if you combine both, you should be able to have very interesting benefits with Spring Boot 4, which we will release in November this year. Thank you a lot. You can go to sep.deleuze.fr if you want to see my social media, etc. And thanks for your attention. If somebody has some questions, we have maybe a bit of time. Otherwise, feel free to come discuss with me after. I'm here today. Thanks.
There goes my mind, 'cause there's magic in my bones.
All my friends are heathens, take it slow. Wait for them to ask you, you know. There's nothing
All my friends are evil.
after all I said, please don't forget. All my friends are heathens, take it slow. Wait for them to ask you, you know. Please don't make any sudden moves. You don't know the heart or the abuse. We don't deal with outsiders very well. They say newcomers have a certain smell. You have trust issues, not to mention. They say that they can smell your intention. You'll never know the freak show sitting next to you. You will have some weird people sitting next to you. You will think that I get here sitting next to you. But after all I said, please don't forget. All my friends are heathens, take it slow. Wait for them to ask you, you know. Please don't make any sudden moves. You don't know the heart or the abuse. Why did you come? You knew you should have stayed. I tried to warn you just to stay away. And now they're outside ready to burst. It looks like you might be one of us.
Easy, oh, I'm drowning, let me breathe. I'm better off all by myself. Don't feeling kinda happy without somebody else. So I hear you crying out for help, but you never showed for me when I was waiting your cell phone. No, you don't know how it feels to be alone, baby. Oh, I'll make you know, I'll make you know. I'm drowning, let me breathe. I'm drowning, let me breathe. I'm drowning, let me breathe. I'm drowning, let me breathe.
But life is immaculate, backing and up a bit, counting my hours and knocking the wood. Finding my opposite, showing the chocolate. Had to be limited time, but it should. It good for a minute, to want to admit it. I'm running up seconds of rigid, I'm screwed. Don't know what to do, I'm thinking of you. I'm drinking up bottles and bottles of booze.
I'm better off all by myself. Don't feeling kinda happy without somebody else. So I hear you crying out for help, but you never showed for me when I was waiting your cell phone. No, you don't know how it feels to be alone, baby. Oh, I'll make you know, I'll make you know. I fell into your living. That's where you told me lies. You said that I feel so high, no lie, feel like the blue sky. Had you on my line, only short time, yet you know you find her. Gold eye, use every color, it's so fly, taste every color, taste the whole rainbow. Oh,
I drink
oh,
till
oh,
I'm drunk, smoke till I'm high, castle on a hill, wake up in the sky. You can't tell me I ain't fly. I know I'm super fly, I know I'm super fly. The ladies love luxury, that's why they all fuck with me. I here with the move, like I'm in the smooth. You can't tell me I ain't fly. I know I'm super fly, I know I'm super fly. Now watch me fly. Now watch me fly. You can't tell me I ain't fly. I know I'm super fly. I know I'm super fly.
yeah, fly like a pilot, she like it when we talking private. Yeah, ain't gotta buy you expensive things. I like your confidence, and I can't lie to you. That body unstoppable. I'm just tryna see it through. Let a nigga know what's up with you. Yeah, fuck with the drip, yeah. I was supreme, designer D's, ice on my neck, yeah. Do what I want, out of the stunt, give me some respect, yeah. If she on the team, that's CCV, what you expect, yeah. No bitch. Was up like a beast, so high, no lie, feel like the blue sky. Had you on my line, only short time, yet you know you find her. Gold eye, use every color, it's so fly, taste every color, taste the whole rainbow, oh, 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 my.
I drink till I'm drunk, smoke till I'm high, castle on the hill, wake up in the sky. You can't tell me I ain't fly. I know I'm super fly, I know I'm super fly. The ladies love luxury, that's why they all touch me. I'm out here with the moves, like I ain't been this smooth. You can't tell me I ain't fly. I know I'm super fly, I know I'm super fly.
Been a long day without you, my friend, and I'll tell you all about it when I see you again. We've come a long way from where we began, and I'll tell you all about it when I see you again. When I see you again. When I see you again.
First you both go out your way and the vibe is feeling strong and was smooth. Turn to a friendship and friendship turn to a bond, and that bond will never be broken and love will never get lost. And when brotherhood comes first and that line will never be crossed. Established it on our own when that line had to be drawn, and that line is what we reach, so remember me when I'm gone. How can we not talk about family when family's all that we got? Everything I went through, you were standing here by my side, and now you gon' be with me for the last time.
It's been a long day without you, my friend, and I'll tell you all about it when I see you again. We've come a long way from where we began, and I'll tell you all about it when I see you again. When I see you again. When I see you again. Without you, my friend, and I'll tell you all about it when I see you again. We've come a long way from where we began, and I'll tell you all about it when
Me and I was smoother. You want cleaner than my gym shoes. Really point to just to hurt me. All red lamb just to tease me. None of these stories on a list you. Made my whole year in a week too. Main chick out of your league too. Side chick out of your league too. So empty, need a centerpiece. 20 racks a table, girl from Ebony. Cut that ivory into skinny pieces. Then I'll sign it with my name, say you love me, baby. You talking money, need a hearing aid. You talking about me, I don't see the shade. Switch up my style, I take any lane. I switch up my code, I kill any pain. And look what you've done. I'm in love with a star boy. And look what you've done. I'm in love with a star boy. Every time my boy try to test me, every time my boy try to end me, pull up in the roadster SV, pockets overweight getting hefty, coming for the king, that's a fuck.
Does not come without pain. So, and really, one of the best, I think, specialists in the world about troubleshooting is again with us this year. So Ram Lakshmanan, I said it correctly, yes, has made his all the way from the US to Sofia, once again to share his opinion, and not opinion, but like his experience. And yes, we're writing not only good code, sometimes it's terrible, and sometimes we have to troubleshoot it. And I believe that Ram knows very good stuff about it. So please warm welcome Ram Lakshmanan.
Before I start, let me share with you something I read recently. It seems in your hand, there are a lot of acupuncture pressure points. And when you clap like this, all those pressure points gets activated, and it really relaxes whoever is clapping. It really regulates your blood flow, and it's good for your art. So all throughout this session, feel free to clap whenever you wanted to, right? Maybe you can start with once now. So, friends, it is, let me say what I'm going to be talking. So here I'm going to be talking about 3 real-world problems that happened in a major Fortune 500 enterprises. So we are going to be discussing what artifacts they captured, how they went about troubleshooting it, and we're going to be looking at the real artifacts that was analyzed, and then how they got to the root cause of the problem. So that's what I'm going to be talking. In case if this sounds boring, the outside sun is very nice. They have beer, so feel free to leave the room right now, right? Okay. Okay, so let's get started. See, the first problem, what I'm going to be talking about is, this is a problem that happened in a very major financial institution in North America. So this financial institution serves its products and services is used by 1 in 3 households in North America. And this problem happened in their middleware platform. So you can see if a middleware has any issues, none of the channels will work, right? The online banking will not work, the mobile banking will not work, the stores, ATMs will not work. So the availability has to be 99.999, right? So this middleware platform started to suffer from unresponsiveness. What will happen is, it will run fine. After some time, it will become unresponsive. It will not crash, or it will not respond to any request that is coming in. And then once they recycle, it starts to go through fine, right? So this was the problem it was happening. So, friends, whenever we confront these kind of problems, right, the best way to equip ourselves to troubleshoot these kind of problems are, see, we have APM tools. So the APM tools will tell, yes, the application has got unresponsive, the response time is degrading. But to get deeper and to see what is actually going on, we need to equip yourself with 360-degree data. So the way, the analogy I would give is that APM tools are like kind of general physicians, the general doctors, you go to clinic. But this one is kind of a surgeon, right? You have to go a little bit deeper to do the surgery. So whenever these kind of problems happens, here is an given here. If at all you guys want to take a photograph, you may want to take a photograph here. This is a good one. Take a photograph here. This is a good one. So this script, when you can trigger it like this. You can say, it's called as a YC script. It's a GitHub, available in GitHub. When you trigger this script, YC-P, process ID, the Java process which is slowing down, this is going to capture a 360-degree artifact from the application stack. Right? So the best way, whenever there is or any production problem happens, we need to equip yourself with enough data. And this is the data which gives you that, the script captures you the 360-degree data. So what helped them to save the day for this enterprise is a thread dump. How many of you here analyze thread dumps? So we'll look at how a thread dump is going to look like. See, friends, whenever any performance problem happens in your application, 99.9% of the case, it will be reflected in the threads. The threads are kind of a blood system of the body of the application. So in case if garbage collection is repeatedly running, the threads wouldn't move forward. It will be stuck. Say if the backend is slowing down, then a set of threads will be getting stuck. So if CPU is spiking up, the threads will, we can see what are the threads that are going on a loop. So if we can try to understand how to read a thread dump, we can solve several of the performance problems that we are facing in our enterprise. Okay? So now let's look how does a thread dump looks like. So friends, this is how a thread dump looks like. It may not be that visible at the back, but I'll try to read it out. So what are the elements which is there in a thread dump? The very first element, what is present, is a timestamp at which the thread dump was taken. Right? It says it was taken at so-and-so date and time. And the next information what is present is, it says what type of JVM from which this information was captured. Whether it was captured from a 64-bit JVM, 32-bit JVM, whether it's a server side, client side gives that information. And then, friends, our application has hundreds of threads, right? Each thread will have a segment, will have this kind of a segment printed. So if you have 100 threads, if my application has 200 threads, the 200 segments are going to be repeating. So now let's zoom into this one segment to see what information is present there. Okay, these are all the information that is present for one thread. The first information, what is present, is called as the thread name, the name of the thread. That is, we as a developer, we give names to a thread, right? In the Java lang thread, we can say set name. Whatever the name we give, that is the name which shows up here. And then the priority. A thread can have a priority from 1 to 10, 10 being the highest and 1 being the lowest. So when there is any CPU contention, the JVM tries to give more priority to thread with high priority to run. Okay? And then next is the thread ID. So this is the ID given by the JVM to our thread. Right? And then what is the next element? Next element is called as NID, which stands for native ID, which is the ID given to the thread by the operating system. Because thread is basically, at the end of the day, is an operating system resource. To operating system to keep track of things, it gives its own ID. See, the analogy I typically tend to give is the name. Say, what is my name is Ram Lakshmanan. This is given to me by my father. Right? So here, I have my driver's license, which is given by my state government. Right? And here is my passport card, which is given by my central government, federal government, right? But everything finally points to me. Similarly, a thread has 3 IDs, name, one given by the JVM, and one given by the operating system, okay? And then next is the name of the state of the thread. That is, in what state the thread is, whether it is running, blocked, waiting, it tells us that. And the most important one is the stack trace. There is a code execution path. What path the thread is executing. So this tells what is the very first method the thread executed. And then from there it went on to progress, execute. It started executing these methods. And finally, at the time of taking a thread dump, this is what this is the method it was executing. This is the method, this is the class, this is a line of code it's working. So friends, that is all the information which is there in the thread dump. But with this thread dump, we can do wonders. We can find several performance problems. Let's look into this one. So friends, the thread dump, you can open up in a text editor, and then you can look into it also. But also, there are also some of these tools are also available, which you can use. You can upload your thread dumps to these tools, and then you can see what's going on to report, right? It can find and tell you what's going on. Now, let's open up this financial institution's thread dump, which was captured at the time of when the problem was happening, when it was unresponsive. And then let's look into that. So here is a tool. To this tool, you can upload the thread dump. Once you upload, the tool is going to analyze, and then it's going to give you the result. See, here is the results, what it has produced. So let's look into that. Friends, look at this. This application, this financial institution middleware, is having like 1,859 threads. Typically, on a normal time period, it has only like a 200 or 300 threads. Now it is having like a 5x or 6x more threads. This itself is a warning sign. Okay. So there's multiple sections here, but one section here, it's called as last executed methods. So friends, whenever there is a bottleneck in the application, right? Whenever there's a bottleneck in the application, let's say here is a bottleneck in a particular method or a particular part of the code, then what will happen is multiple threads will start to navigate, and then they will go and they will get stuck on that particular method. So, whenever there's a bottleneck, let me repeat, multiple threads will start to navigate, and they get stuck on the bottleneck. They wouldn't be able to move forward. So when you take a thread dump, you want to be looking at what is the last executed method of the threads. If multiple threads starts to exhibit the same method as its last executed method, then that is the area of concern. That is something you want to be looking at it, right? You don't have to use these tools. You can just look at still in the text editor. You can look into it. But this tool, what does it do is it tries to group the threads which is executing where multiple threads execute the last method. It groups and shows. So here it shows like 1,700 plus threads, which is almost more than 92% of the threads of this application is executing this particular method. That is 92% of the threads are executing this method. So now let's see what is the stack trace of this method. Okay, so this is the stack trace of those 1,700 plus threads. All of them are ended up with this stack trace. Look at it. It is originating. Wait, let me make it a little bit bigger so that you can see it. See, if you see, they are originating from the Oracle package. So since this was a middleware platform, it talks with multiple system of records. There are multiple system of records it talks to, and one of the primary system of record is an Oracle RAC cluster. So the Oracle, the database vendor, told to this middleware platform, hey, hello middleware platform, on your JDBC driver, enable this flag called ONS. That is, the flag called ONS stands for Online Notification Service. When you set this flag to true, what will happen is, since Oracle RAC cluster, it's a multi-node cluster, if any one node goes down, immediately the JDBC driver will send the transaction to other active nodes in the cluster, so your availability will get better. So enable this flag to be true in your setting, so your availability will get better. So this financial institution middleware also, okay, they enabled it. But once they enabled, actually the contrary happened to what the database vendor told. What happened was, when they enabled it true, for whenever every call was made, a new thread was spawned and it was never terminated. For every call, a new thread was getting spawned. So of course, when multiple threads are going to be spawned, JVM is going to choke and it's going to get unresponsive. And that's what was going on. So once they captured this thread dump and then they showed to the Oracle team, then they told, oh, sorry. Since you are a middleware, we thought we wanted to pilot this new feature on you. So we piloted, but it seems like it's not working. So they gave a patch. When they upgraded the JDBC driver, then the problem went away. Right? Okay. So this was the root cause, and this is how they went about solving the problem. Okay. So now let's move on. See, friends, like this, there is multiple such patterns how you can go about analyzing the thread dump. In the interest of time, I wouldn't be able to go into all the patterns, but here is a video clip which is available on YouTube. If at all, you can look at it offline. Okay. So the next problem, it was confronted by a very major cloud service provider. There is a good chance several of us are running our service on this cloud provider. So they were having a poor response time. That is, one of the critical service was having a poor response time. It is a cloud service provider. It's not a general business application. The cloud service provider itself, their critical service was having a poor response time. So this was happening because of garbage collection. Right? Let's talk about it. So friends, what is garbage? Some people say my talk is garbage. Okay. So what is garbage? Let's look into that. See, friends, all our application as memory, right? All our applications as memory. We set our XMX as 2 GB, 6 GB, 10 GB, 20. Even if you set it to 500 GB, even 1 terabyte, still it is a finite space. Still it is a finite space. So let's see, when a new request comes to our application, let's say a new sign-on request comes to our application. Friends, all our modern applications are becoming inefficient day by day, day by day, day by day. We are creating more and more objects, right? We are creating thousands of objects even to service a simple vanilla sign-on request, right? So when a new vanilla request comes, see, think about, just let me highlight some of the important objects. Let's say new vanilla sign-on request comes. I'm running on a Tomcat server, right? It has its own set of objects. It's creating a servlet request object, servlet response object, filter object, session object. Then if I'm using Spring Boot, it loads its own set of context dependency objects. I'm creating a workflow manager object, data access object, connection object. I'm making a backend call that's giving me a result set. I'm creating lots of objects. Okay, so now I created all these objects. Now with these objects, I've authenticated the customer. Yes, the customer is authenticated. Now the request goes. What will happen to these objects that has been created? These objects doesn't have any more reference in the memory. So this is now garbage. This garbage has to be removed from memory so that the room is created to service new incoming requests, right? So how is this garbage reclaimed? How is this garbage collected? Let's look at the evolution. Friends, 3 decades back, exactly 3 decades back before Java was invented, the predominant programming language of those days was C, C++, or even predecessor languages. They didn't have this automatic garbage collection. See, today as a Java developer, we create objects. I say new customer object, new account object, new array list. That's what I create. I don't remove those objects from memory. I don't deallocate them, right? But if you are a C, C++ developer or any language before that, you need to be removing those objects from memory. Friends, think about it. Think even in a Java code. Our business application is very complex. There is multiple use cases, there is multiple workflows, there is multiple methods. Even if I forget to deallocate an object, a customer, or any object in one particular scenario, those objects will start to build in memory. Friends, if there are developers who are working on the predecessor languages, you know how memory leak was very pervasive back in those days. Memory leak was very pervasive. So I was speaking with one of the engineers. He was saying, if you write a program, C, C++ back in those days, it's a very high chance that there is a memory leak going to happen, unless it is very carefully done. So Java came in 1995. Java told developers, you don't worry about doing this deallocation. I will take care of doing it at runtime. And really, this automatic garbage collection took off. Even before that, in 1950s itself, this automatic garbage collection was there in a language called Lisp. But once Java came, it really championed it. Since then, all the modern programming languages has this automatic garbage collection capability. Like Go, Python, .NET, all of them do have. So what I'm talking now is not specific to Java, to all modern languages. So, friends, this automatic garbage collection sounds good, right? Because it makes me focus on the code. I don't need to worry about all those deallocation, right? I can focus on the business logic. But friends, this automatic garbage collection has a couple of side effects. The first side effect is it stops our JVM application. It stops our application. So when my application is, think about it, I'm watching a YouTube video. What if I go and click on the pause button? The movie will not play, right? Exact same thing happens in JVM. When this garbage collection run, it stops your JVM. That means if any customer transaction comes, he's not going to get response. So if your customer says your application was running fine, but all of a sudden it was not responding, very likely the garbage collection was running in the background. And friends, the second side effect is it has a very high CPU consumption. It has very high CPU consumption. Say if your application is consuming 60% CPU, probably 40% CPU consumption is going to garbage collection. Because think about it, your application is creating millions of objects concurrently. So your garbage collector has to run in the background to keep scanning all those millions of objects to see what is that object, and it has to walk through that object tree. Oh, this object is referenced by another object. That object is referenced by another object. It has to walk through the entire tree to see whether it has any active reference or inactive reference. To do that, it consumes enormous amount of CPU cycles. I have some case studies to show. Uber, a very large car ride-sharing app, they optimize their GC settings so that they can reduce their CPU consumption. And then they are able to save millions of dollars in computing cost because of that. And think about this, this pause time. Let's come back to this pause time. Friends, I want to ask you to visualize what I'm going to say. Just visualize what I'm going to say. Think about your dream car. Let it be whatever the dream car it is. Europe is known for manufacturing a lot of great cars. Think about a dream car. Now you are buying the dream car. You're taking the car out of the showroom. Now you are driving on the road. A car goes for 5 kilometers and then stops in the middle of the road for 5 seconds. And then once again it drives for another 5 kilometers and stops in the middle of the road for 5 seconds. Even though I'm keeping my leg on the accelerator pedal, how will you feel? You'll feel pretty disappointed, frustrated, unhappy, right? Friends, that's what JVM is doing today. It's not disgrace to JVM. All modern languages, platforms are doing that. It is involuntarily stopping. But we cannot see that. Can you see JVM? We cannot see JVM. It's not visible. So when we run into these kind of problems, we want to get the 360-degree data. So what helped this cloud service provider to solve the problem is the garbage collection log. This is what helped them to solve the problem. Friend, this is how a garbage collection log looks. It is pretty cryptic, very tedious file. And trained eyes can still read and interpret. But there are some tools are available in the industry, which you can take this GC log and upload and then look into what's going on, right? So now let's look into the actual garbage collection log of this cloud service provider. So here is that tool. So to this you can upload the GC log. It's going to analyze and then it's going to tell you what's going on. If there are any problems, it says, there are long pauses. And it also gives you the recommendations of what needs to be done. But look at this, my friends. Here, there is an interesting metric, what it reports. Let's focus on this. It says, what is my average GC pause time? What does it say? 12 seconds. My average GC pause time is 12 seconds. That means the JVM, whenever an GC event runs, it's stopping for 12 seconds. Now, he's taking photograph. Okay. So let's look at it here. So this graph shows how much time this JVM is stopping. Let me zoom in a particular section maybe. Okay, look at this. This garbage collection event ran at 10:58 a.m. I don't know whether it's visible that much for the people in the... Okay, let me zoom. It ran at 10:58 a.m. and it is stopping for 14 seconds. That means if any customer request comes during that time, he is not going to get the response for next 14 seconds. How does it sound? We are all running our application on top of this cloud provider. Now, I'm moving to the next data point. So this happened at 10:58. Next GC event ran at 11:04. That is 6 minutes later. It is once again stopping for 14 seconds. And once again, another 6 minutes later, it's stopping for 14 seconds. Right? So, friends, look at this. When you study this garbage collection, there is a metric called GC throughput percentage. What does GC throughput percentage means? And friends, I don't know who reported this as in percentage. I want to see that gentleman or that woman once in my lifetime. He's a very clever person. I want to meet him. See, what does this throughput percentage means? What does this 96% throughput mean? See, when I hear a number 96%, it sounds good, right? Because if my daughter, who is in high school, if she gets 96%, I'm very happy. But let me break it down. What does this throughput actually means to us? See, when someone says your garbage collection throughput is 96%, it means this application is spending 96% of its time in processing the customer transaction and remaining 4% of time in processing the garbage collection activity. That's what it means. Let's break it down in terms of minutes. One day has 1,440 minutes because 24 hours multiplied by 60 minutes. 4% is spending in garbage collection. What is 4% of one day? It is 57.6 minutes. That means one day, your JVM is stopping for 60 minutes. This JVM, 60 minutes. Of course, it's not stopping 60 minutes continuously. It is stopping, running, stopping, like that it's doing. So it's stopping for 60 minutes. Friends, think about it. Basically, when it's stopping means it is not doing any customer work. Think about, you all go to work tomorrow. You sleep there for 1 hour in the office. What will happen? Probably we'll lose our job. But application JVMs are doing, not JVM, no, I'm not doing any disgrace, I really love JVM. All modern platforms are doing it. This is a little bit of worst case, but all our applications are sleeping. So think about the cost. 1 hour, it's not doing any productive work, but still my application, even if it's not doing any productive work, I need to pay to my cloud provider. Cloud provider is not going to stop billing for me. He's going to continue to bill for me. Wait, let's now look at. So now let's look at let's look into the data. So this is where it had a problem. So this cloud provider, look at their setting. What had happened? They were kept their XMX were set as 28 gig or 29 gig. You can see the young generation is 14 gig. And old generation is 14 gig. This is what their settings are. Now, look at this. They made a minor tweak. What they did, they changed their young generation size to 1 GB and the old generation size to 28 GB. This is what the setting change they made. Once they made this change, look what happened to the throughput. 99%, 99.36%. And the average pause time is 138 milliseconds, right? So tomorrow I'm giving a talk on this GC tuning. If at all how you want to go about improving GC tuning, there I'll go into the details of how we can go about improving your application GC performance. How did they discover they need to change the generation size? All those things we'll discuss tomorrow. Okay? In the interest of time, I wouldn't be able to go this further. But GC tuning can give you a phenomenal improvement. Friends, two things. If I'm going to stop my application sleeping for 1 hour, that means my response time is going to get better. Right? Because any transaction comes during time, it's not going to get response. So when you optimize it, your response time is going to get a lot better. And this is a very effective way to improve your response time and also cut down your computing cost, right? So look at this. Here are some of the case studies that I would like to share. Uber saves millions of dollars in computing cost because of GC tuning. There's a very large automobile manufacturer. They are not headquartered in Europe, but they are in Japan. So they were able to optimize the GC performance, and they were able to improve their response time significantly. These are some of the case studies, right? Okay. So let's move on to the third case study. This was a problem that was encountered by a travel service provider. So this travel service provider, they were running on-prem. So they migrated from on-prem to a cloud infrastructure. Once they migrated to this cloud infrastructure, they started to see intermittently 502 errors. Not always, intermittently, and that too not very aggressive, very infrequently. Probably in a day, they may see for a handful of transactions. They were processing several millions of transactions. Only for a handful of transactions, they used to see this intermittent 502 errors, and then after the problem evaporates. Right? The problem goes away. But this was happening for weeks, months. Right? So let's dive into this case study. So friends, where they migrated is they started using an AWS service called EBS, Elastic Beanstalk. Right? So it is basically a simple container service. Let's just quickly look into that architecture, nothing fancy. So this EBS service has an load balancer at the very front, which is going to distribute the load to the EC2 instances. So each EC2 instance has each EC2 container has an Nginx web server, which forwards a request to Apache Tomcat server. The Apache Tomcat server is where the Java logic is there, which processes the request. And then the request is sent back to Nginx, and then the Nginx sends back to the customer. Right? This is how the setup was. And intermittently, they were getting this 502 bad gateway errors. It was going on for weeks or even a few months. They didn't know why. Friend, this is where equipping ourselves with a 360-degree data will really help. What helped them to save the day was this dmessage. What is dmessage? Let me tell. Dmessage is a Linux command. When you issue that, it's going to give me a kernel logs. The kernel does logging. As our application, we do logging. Kernel also does logging. This dmessage command is going to give the kernel logs. And friends, in the kernel log, I don't know whether it is visible. In the kernel logs, sometimes what will happen when there is a lack of RAM capacity, the kernel will kill our Java application. Kernel use some internal heuristics to decide when there is a lack of RAM capacity, it decides which process to kill. Most of the time, it turns out to be a Java process because Java process tends to be the largest memory consuming process in that container. And also the Java process, we set the XMX and XMS to different values. So the memory scales up and scales down. Right? So when it sees that, it thinks as a rogue process and it kills. When it kills, it will not be reported anywhere other than the kernel log. It's going to kill with this out-of-memory error, kill the process or sacrifice the shell. That error is going to be printed here. When they saw this, then they realized, oh, the kernel is killing the process. So let's go back here to this architecture diagram. Look at it. The request came. The load balancer forwarded to this Nginx server. Now Nginx sent it to the Tomcat. And now when Tomcat is processing the request, the kernel killed the Tomcat because of lack of RAM capacity. When it killed, that means this request, the Nginx is not going to get back the response within the stipulated timeout period. If it's not going to get a response within the stipulated timeout period, it's going to return back 502 errors. So now, this brings a question, okay, if this Tomcat server is down, why I should see more 502 errors? Any request that comes to this EC2 instance should get more 502 errors. And why my alarms or nothing is not triggering? What's going on? Friends, our modern infrastructure is getting complex and complex, right? See, look at this. What was happening? This is running on a container service. EBS is a container service. So this EBS container orchestrator, as part of its self-healing mechanism, it would restart the Tomcat process if it's down. So this kernel was killing the Tomcat process. Now this container orchestrator, as part of a self-healing mechanism, it sees the Tomcat is down, so it's going to restart the Tomcat. So once restart comes up, it starts to take traffic. And then when it goes beyond a limit, up and down in production. So this led to this problem. So after discovering that, okay, the dmessage, the kernel was there, so they didn't do a proper capacity planning. So once they allocated bigger size RAM, bigger size EC2 instance, then the problem went away. So, friends, this comes, we just already discussed 3, but since we have time, let's discuss one more. It's called as a CPU spike. So this was a problem encountered by a trading application. You know trading application? The response time has to be in milliseconds. So what was happening was, with this application, this trading application would go smoothly. For hours and hours, it will go smoothly. All of a sudden, the CPU will spike to 100%, and then it will remain there. It will never come down. You have to recycle the JVM to make it come down, and then it will go smoothly. But sometimes, after you restart, maybe after even few minutes, it may go to 100%. In few minutes, it may go to 100%. Sometimes it can go for several hours. So it was very sporadic behavior. So how did they go about troubleshooting the problem? See, friends, I'm going to be showing you a very effective and very simple technique to isolate CPU problems if it happens in your enterprise. So, friends, whenever a CPU spike happens, there's only one reason for that. See, if your application goes unresponsive or it's slowing down, there could be multiple reasons. But when CPU spikes, there's only one reason for that. That reason is a thread. If your thread starts to execute your programming code or instructions continuously, that's when the CPU will start to go. Say, if there's a thread goes on an infinite loop, there's a while loop which turned out to be true or something, infinite loop happens, then if a thread starts to loop infinitely, then the CPU goes up. So the only reason why CPU will spike up is because of threads. The threads is something, it starts to execute your code continuously. That's when the CPU spike goes up. So now, how do I go about troubleshooting is, I need to isolate which is the thread which is causing the CPU to spike, because we know the thread is the reason. My application has hundreds of threads. From these hundreds of threads, how will I narrow down and isolate which thread is causing the CPU to spike up? So friends, we all might have used the top command. The top command is a Linux command. When you issue that command, it's going to give me all the processes running on the device and what is the CPU and memory consumption. Friends, this top command has one secret option. I'm going to share that secret option with you now. This is what it is. If you say top -h, uppercase H, and -p in the process ID, when you give this top command is going to display all the process that is running, all the threads that is running within this process, what you have specified, and what are those threads and what is the CPU consumption of those threads within that process. See, here you can see, when I issue this command, it is telling, oh, there is one thread called 31 with a thread with an ID 31306. This thread is consuming 69% CPU. There is another thread consuming 65% CPU. The third thread containing 64% CPU. All other threads are consuming only 0% CPU. So it tells what are the threads which is causing the CPU to spike. So now we know, okay, these are 3 culprit threads which is causing the CPU to spike. Now I isolated these 3 threads. Now next step is I need to know what lines of code this thread is executing. See, our APM tool gives you the overall process CPU has spiked to 80-90%, which is a good information we need to know. But what I need to fix it is what threads is causing and what lines of code is executing. That's what I need to know to fix the problem. So to do that, we can use this. So now I isolated these are the threads. Now how will I know what lines of code the threads are executing? This is where the thread dump is going to help us, because the thread dump tells what lines of code the threads are executing. So when you take these 2 information, when you marry these 2 information, then we can get to the root cause or what threads are actually causing a CPU to spike. See, look at this. That's where when you get the 360-degree data, it really helps. The 360-degree data captures you a set of thread dumps, and simultaneously it also captures the top-h. Right? It captures these data. And once you have this data, then you can, when you upload it to this kind of analysis tool, or you can open a text editor and you can look into this. Let's look into from the tool here. So let's look here. So here, the tool tells There is a section here called a CPU consumption by thread. At the thread level it shows. Here I can see, oh, there is a thread called web container 18, and this is consuming 60.9% of CPU. And this is the stack trace. It is executing. And then here it also shows there are other more threads, which is consuming 26%. It shows at the thread level. It's very powerful, because I don't want to see at the macro level. At the thread level, I'm able to see what lines of code it is consuming. So now when I click here, I can see the stack trace. You can see this application was running on IBM WebSphere server, and then it is progressing, executing. You see, my friends, it is executing this weak hashmap.put code. You can see it is executing this weak hashmap.put. Why does weak hashmap.put causes CPU to go high, 60%? And also looking at also other threads also, see this thread also is also in that put, weak hashmap put. All thread top CPU consuming threads, everyone is at the put, right? Weak hashmap put. See, friends, there is this interview question, right? What is the difference in between hash map and hash table? Or we ask. So we all say, oh, hash map is not a thread-safe implementation, right? So friends, when this is an interesting thing to know, when multiple threads starts to do a concurrently, they starts to invoke a get or a put operation on a hash map, the thread will go on an infinite loop. Let me repeat. If a hash map, if multiple threads starts to invoke the get or a put at the same time, it will start to go on an infinite loop. That's why you should never use hash map. Instead, use concurrent hash map. Today morning, there was a concurrent talk, right? So use a concurrent hash map, which is a thread-safe implementation. Its performance is almost comparable. It's almost same with hash map. So the thread will go on an infinite loop. So when they saw this, oh, okay, this is the problem, then they replaced this hash map with a concurrent hash map. Then the problem went away. Right? Making sense? Okay. So friends, now I'm going to tell you all a good news. My talk has come to an end. So thank you. Okay. So if there are any questions, you're welcome and ask me. I'm here. Oh.
Chefe. Okay. Now go back to stage. Okay. Now, this is the final talk for the day. And I'm completely sure that you're not here for the talk, but for the raffle after it. Yes. But we have prepared a really, really stylish talk for you. Yes, and as Mr. Lakshmanan was fixing troubles, this guy will fix the full Java for you. And he's going to do it in the most stylish way. But to welcome him in our very good way, I want you to sing with me. Are you ready?
Да по тебе ще си остана, дори да бъда жива рана. Да по тебе, дори да зная, че ти с мене си играеш.
Welcome!
Thank you, thank you. I can see that, probably I can see you without the glasses. In the winter I was attending a talk here in the same hall, and the projectors were doing this industrial white right in front of my eyes, so I was prepared, but it was unnecessary. And I think I don't need my jacket as well. Shall I also take my shirt as well? Sorry, mister, can you take this one? Yeah, thank you very much. Very nice, guys. Do I see my presentation there? No, because I have no presentation, probably. Okay, so thank you for having me. Last year I was in the smaller hall, so now Ivan gave me the opportunity to be on the bigger hall, but I think for compensation he did it on the last talk, so probably you hate me, but it's transitive, hate Ivan Ivanov as well. My name is Ivan Yonkov. So just to be, what are you doing with my presentation? He's doing stuff on my computer. I don't like my computer being touched. People saying viruses. No viruses, right? You're not for North Korea. No, okay, great. Sorry, no racism. Everything okay? This was just black screen. I think they thought that nothing works, but it's black screen on my presentation. Let me do a check. Okay, so it's working. Okay. So what we are going to do? We are going to deal with some spaghetti with a fork. Or we will try to fix Java with compiler plugins, whatever it is. And I have truth that nobody told you. That's what people say on LinkedIn, right? The truth that nobody told you. The fix Java was a clickbait. You cannot fix Java. That's not possible. That's why we were just going to talk about compiler plugins. So sorry if you were misled, but Java is unfixable. And I can say that for 15 years of experience or more with Java, and it's kind of unfixable, but there is things that we can do, and I would try to show you some of them, and some projects that are here for a while that are actually trying to fix Java. So not that kind of a clickbait, right? So who am I? Well, I'm this guy. I know how it looks on the picture, right? So let me say I'm no ordinary guy, and I'm from the geek computer world. Pascal or C, I called in hour, no memory leak. No ordinary guy. You know, there is another song. If you're a kid from the 90s, you probably know it. I paraphrase it. So let's get serious. My name is Ivan Yonkov, and I'm the founder and the CEO of the software consultancy Codexio. So a bit more for us, a little talk for this. We are, let's say, you know Netflix? We have nothing to do with Netflix. But we are trying to be with the same level of engineering, but on the service space. So what we're doing is low latency, high scale systems for customers. That's our differentiating model, let's say. And since I'm not here to promote my company, I will just tell you one word for me. I'm a Java archaeologist. So what I do is dig deep with very old Java, because my customers are there from the 90s. They have very old Java. They never upgraded it. And they see no reason, because Java is unfixable, right? So I need to fix it, and the team behind me. Enough for me. Let me tell you what we are going to talk about seriously this time. Of course, we're going to talk about compiler plugins. but also about how to modify the abstract syntax tree. There is one more truth here. I was preparing for this talk a couple ago when there was an introduction of some tools in Java, and these tools severely shifted to Java 24. I was kind of surprised when I was attending Java 1 in San Francisco. So we will still modify abstract syntax tree with some hacks like back in 15 years ago. And also we will see these things, the class file API, which was made official now, kind of official in Java 24, and of course some non-modifying use cases of how to use compiler plugins, which is probably what compiler plugins are used for, but still we're going to push it to the limits. So what problem you can, let's say, address with compiler plugins? I'm trying to make a very small example of something that you may see in a large scale with different examples in your projects. Let's say you have this code base. This code base is assigning on a public field some values. So imagine this is some violation or some anti-pattern that was in your project. And this anti-pattern is not only on 1 or 2 places, this anti-pattern is on several places. And you want to address it. You want to introduce a setter, or the setter is there, for instance, but you need to use it. So what's your go-to solution here? I can see some things that you can do on these thousands of occurrences, right? You can do massive find and replace. But let's think out of the box. Sometimes it's not that possible to make it with a regex pattern to find and replace dot something with set something. Sometimes it's not possible. Sometimes it's bigger than that. But for the simplicity of the example, I'm using this one. So I want you to abstract away from that example and see it as some violation that you need to fix in 15 years, 20 years old code base that you cannot touch everywhere else. Sometimes it's some jar files in libraries that you don't have the source code, so you cannot just go and do massive find and replace. You need to do it the other way around. So how you can do that? You can modify the abstract syntax tree to replace the assignment with a setter. So one operation, the assignment, this is something that's from the syntax of Java that you can plug into and make some changes while the program is being compiled. So your program will actually be compiled with the new code base, with the setter. Not something that's happening like reflection, not something in the runtime, but something that's happening as a compilation phase during your program is being compiled. Okay, so let's imagine we have the code base from above and we run the JavaC compiler. Usually, we will produce a bytecode for the specification of Java that's doing actually the same things that you've written on a human readable code. But this class file that's going to be produced, you can plug into the compilation and add the so-called plugin. This is a compiler plugin, another class file or jar file that's written also in Java that can intercept what's happening in the compiler and do some modifications. So usually you cannot do modifications. Back in the days you could, but the Java team said, okay, this is compiler that you should not use, and they closed it. But people found ways to do it. We will still use these things to achieve that goal, and then I will show you some cases that you can do not only modifications, but other stuff. So what is this plugin doing? Actually, there is a task listener that listens for the compilation phase starts or the compilation phase finishes. And you can introduce one more thing that's called tree visitor. This tree is actually your syntax tree. You can visit every operation that happens during the compilation phase. It's a method call, it's an assignment, it's an operator that's other operator, like summing operators. Whatever you want, from the syntactic point of view, you can intercept it. And this expression, you can do something without. You can, with it, you can modify it, for instance. That's what will be our first example. We will modify the so-called abstract syntax tree with compiler internals. That's a very important point, because you're not supposed to do it, but you see projects here and there doing it, and I think it's valuable for you to know how, even though it's kind of a violation of what the Java team thinks, but unless they introduce some API to do it the correct way, we used to use this way. Okay. So our code base of a compiler plugin should have this resource file that's using the plugin interface as a full qualified name. And this full qualified name should be a file in your metainf directory in the services folder. This is something that Java uses for a lot of other operations like annotation processing. Again, you need to introduce your annotation processor the same way. And in this file, you need to put your full qualified name to the plugin that implements the plugin interface. So here, bg.qtexu.plugins.filtersetter plugin is actually a class file, a Java class that is implementing the plugin interface and is doing the work. Actually, this one. As you can see, the filtersetter plugin implements the same interface plugin and have this method init. In the init method, we're actually adding a task listener for the Java compiler task. There are some classes that implement the Java-C or extend the Java-C task, the Java-C task abstract class, and you see in the next slide which one we are interested into. So now we need to address this listening by adding another object. This is from the type of the task listener interface. And I can show this on the next slide. You can see, as I told you before, the task listener has the started and finished phases. So we need to plug with one or the other and do some stuff. Usually, we go to the phase and we get the compilation unit. And this compilation unit, we can give it an object of type treeVisitor. So when it accepts the treeVisitor then will be notified by all the methods of each and another operation inside the abstract syntax tree. And how this is treeVisitor? Why a task listener is treeVisitor? It's not. We just implemented both interfaces. So our filtersetter transformer is actually a task listener and a treeVisitor. And what it has? Well, it has some convenient fields that are from the compiler plugin, from the compiler internals that you can usually cannot import into your code base. So these things, in order to be green and not red, you will need to add some compiler arguments while you compile your code. You need to add exports to all these packages where these classes are. So com.sun.tools.javac, .tree, util, API, and others are containing these classes, and you need them. And on the left side, I think it's the left side on my perspective, at least, on the left side, you can see that we need to intercept the basic Java compiler task to obtain these objects. The tree maker object, the symbols, the symbols object, and the names object, where we will extract some names. After that, you will see that in action on the next couple of slides. So given we have all these fields there, I will just make them stay there in order to have them. We need to visit some expression. And you can see that our treeVisitor will be notified for each and every expression statement, giving us the concrete expression statement tree that will be sent to our method. So here is the interface expression statement tree, the first argument of the function. And this interface can have all the expressions that you can imagine in the syntactic way of Java. But we are only interested in the assignment. And what we are not interested in is also the assignment should happen from the outside. We don't need this dot something or some members inside the class, right? We need this to be member select tree, but you don't need to be this dot something. It should be another object dot something. So only if this condition is satisfied, only then we need to continue. Otherwise, we need to skip all other expressions that are assigning internally. Otherwise, you assign setters inside the internal this dot assignments, and probably it will lead to something that you don't want. Also, one more thing, sorry about that, but you know what I explained. Also, one more thing. What we also need to do is to do it for certain classes. Probably we don't need it for all classes. Probably we need it. But let's say we need it for our classes from some package structure. So we need the package to be starting with bg.codexio.dto. In the first slide, I will not go back, but in the first slide we had an entity and a DTO. We don't need to modify the entity, we want to modify only the DTO. Hence, this is the package that we did there. Okay. Then this is the real magic. Now, casting to JC3 is something that you cannot do unless you do the add exports that I shown before. So you need to cast the expression to the Java compiler expression, and then you need to do your stuff. And what is the stuff here? So here you can see that the setter target that's obtained by the get expression is actually the object that's containing the assignment. In our case, in the first slide, it was the user DTO in a variable named DTO. And then we need the value, which was the string test in our case. Then we need to create, or we need to find, because we will not create this setter, it should be there. We need to find the set username method. So we select this from a named target, and you now can see the names object. So with the names object, you can find this from a particular string. Now, given the fact that we have the variable DTO, we have the value test, and we have the method set username, we now can construct this. But this is not enough. Once you construct the call, you need to assign back some stuff, because a new construction will not have the same type, because it's not deducible from the expression. The expression is something that actually returns what you assigned. You know the expression, you can do something equals something, something equals something, you can do it transitively, so it returns, but we need to return void. That's what the setter was doing. And you need a method that accepts a string as well. So how we do that? Well, we need to set a list of arguments, because your method, the setter method may accept 5, right? It now accepts only 1, so it's a list of 1 argument type. And the argument type, it can be taken from the value expression. So the value expression, the test string, is of type string. But if we cannot deduce that, let's say it will be the string type. You can do other logic if you want, but in our simple logic, that's something that we can do. And the other thing that we need to say, that our setter method we will actually have a return type void and not the return type of the assignment operator. The other thing that we need to do is to get back the ownership. So we need to find the parent symbol owner and set it back to the setter target. Now the method select will have the same owner as the target of the setter, which is the DTO. The target of the setter is the class that contains actually the setter. Only at this point, the actual call can happen. Otherwise, it will try to cast something to something that's not castable, and you will receive very strange exceptions during the compilation. Because it's not a runtime, you will not see exception like class cast exception, you will see something like the compiler failed. And it's very hard to debug such kind of code, so you need a lot of logging here and there. If you go down this rabbit hole, you should know that you will have lots of headaches. But at some point, at some time, maybe it's justifiable. As I said, probably you can have a client or a project that's having 20 years old of code base, and you just need to do it. Okay, what's the real call here? The real call here is that we need to actually apply the method select with the value. And now, this original statement, which is the expression statement 3, which we know that was assignment, its expression inside will be changed. The expression inside was actually assignment, but now it's a setter call. Very nasty hack. And then you give it back to the visit expression statement of the superclass, where it will be propagated back, and the compiler will compile it the way you see it here, and not the way it was originally. So this was our original code base, where we have an entity and a DTO, both referencing a public field username. But only one of them needed to be intercepted. So now you can see what we have after compiling this code base with X plugin, field setter plugin. We still have the DTO package and the entity package. Inside each of them, we have the user and the user DTO. But now, if you go to the main method, you can see that the decompiled code actually have set username only for the DTO instead of .username, and only for the DTO instead of the entity. So we actually did it. We intercepted the assignment and produced a setter call. This is your .class file, main.class file, that's produced, and when you run it, it will use the setter. And maybe you don't remember the first slide, but in our setter method, we had an if, which says, if our username starts with test, we don't allow test users. So what should be the result of this main method if we run it? Anyone? Yeah, it should be erroneous, right? No test users allowed. How cool is that to see an exception on your screen that denotes your success? I like that very much. So we succeeded creating a compiler plugin that actually modifies the abstract syntax tree of the cost of exporting some things that Project Jigsaw back then in Java 9 disallowed us. Well, it's a hack, but sometimes you need to do it. Sometimes you don't need to make modifications. Sometimes you may want to use compiler plugins for other things. But this is a very simple example, or not that simple, but the simplest example that I could show you, how we can modify some fraction of our code base. Now, when you know that you can plug into each and every phase, you can do whatever you want. You can change assignments to setters, you can change pluses to minuses, you can do whatever you want with your compilation. It can be one Java code that produces complete gibberish if you want to do it. But you need to be very strict for that. And if I get back to fixing Java, because I said it's a clickbait. Well, it's kind of a clickbait, but there is still projects that are fixing Java. There is one project called Manifold, which is very cool. I'm not the author of it. I just use it in some projects. I'm very pleased by what they're doing. They actually have lots of stuff that's fixing Java. For instance, you're writing bare SQL strings, and they're making a kind of object mapping there. Or you may have how it's called, extension methods. That's not possible in Java, right? You can have it in Kotlin, you have it in C#, but you don't have it in Java. You cannot add new method to an existing class. If it's not yours, you cannot do it. If it's final class, like the string class, you cannot extend it even. So in Java, you cannot have extension methods, but these guys did it. So you can say, hello world.print. There is no print method in the object string, right? But they made it. You can have string.line separator, a static new method that's there in the string. And they did it by their convention. You can introduce a new class that's called myStringExtension, and you can add these methods. And somehow, they modify the compilation phase, add it inside the string object, or the string static table, virtual method table, and then you can use it in your code base. So you can actually fix Java. If you want, you can do it. It would be 2 hours or 3 hours demo if I were to show you something like that. So I decided to show you something simple, and then you can go home and try to explore it and fix Java, if it's fixable, of course. But let's jump to our third topic that I promised you to explore. And it's the new Java class file API, which is coming from some versions so far. And it's rapidly changing from 22, 23, and 24. And since I haven't touched my presentation since April, I hope that nothing changed since then. But if it changed, probably you will be the ones that will somehow find what are the new things, because they are severely undocumented. So we can manipulate now bytecode in safe fashion. What I mean by safe fashion? If you were attending my talk last year for annotation processing, we were doing one bytecode manipulation while we were reading the byte stream of the class file and doing first byte, is it the magic string cafe babe, then the other 4 bytes are the minor version of Java, then we need to change some bytes, but we need to change the array length, and you do something that may do something dangerous in your class file, because there are a lot of vectors for failing there. But with the new Java class file API, you can do these manipulations with some human-readable code instead of manipulating bytes on the position 1073, for instance. And then we can return new bytecode by that. And this is very convenient for some operations. It's not tied to compiler plugins. You can do this manipulation wherever you want. You can do it in annotation processing. You can do it in compiler plugins. Or even you can do this in your runtime code. You can produce new classes by that. If you want some user input counts, you produce new class. Why not? But let's have a minimal example. Let's say that we have objects that have constructors, and this is all the objects. Yeah. And we need to intercept the constructor and add one line in each constructor. Even if the constructor does not exist, it's still an init method that's implicitly there. And print that the object is instantiated. So we need to manipulate the bytecode of the constructor call. It's not, let's say, it's not now some expression that we need to intercept. We need to manipulate how a method acts. That's a different game. And very simple example of adding one new line of system out print line in it. So the class file API starts from the fact that you need to parse the byte array of a class file. So we need to find your class file and get the byte array. How you find it? You can find it in the target folder. You can find it wherever it is. It should be compiled once. So we need to compile our class, then parse it, and then give it to the class file API. Now, you can transform whatever you have parsed. You have parsed it. It returns you a class model from the first line, and this class model is then sent as a baseline to the transform class. And now, in one lambda, where it accepts the class builder, which can transform methods, fields, and other stuff that are inside the class, you can do the transformation. Inside the class builder, you can transform everything. As I said, you can transform fields or, let's say, methods. In our case, methods are the thing that we need to transform because we need to transform the constructor, and the constructor is a method. So how this will be handled? Let's say we will do this inside a compiler plugin, probably inside the same compiler plugin or another one. Let's say this is another compiler plugin that's adding the system out print line to the constructors. So when we receive the task event, we will find what is the target class by getting the type element and the full qualified name. Then this full qualified name, we will find it inside target classes. And now we can use some utility method in Java Neo or IO to read all bytes of the physical class file that's already compiled. When we have that, we can give it to the parse method of the class file API. Now, giving the model, we can go to transform class. You say, Ivan, you put some comment, you need us to implement it. Don't worry, we will implement the part that's crucial for this. But let's continue for the fact that we need to go from all methods and find the one that's constructor. It's called init in the method table. It's not constructor, setor, or whatever it is. And now you need to go to all constructors. You see for each method here, You know, you can have multiple constructors, method overloading, right? We need them all. We don't need to find the first one. It can accept things, it cannot accept things in all the constructors. We need to put system out printline. And what we do there, we need to find the code attribute. Yeah, it's some transformations, probably it can be no, so we need to go to this transformation where we have the code attribute. That's why we have this defensive programming there. And now you can see the implementation of the transform method. The transform method itself have a method builder, and the method builder can transform the code. The bytecode there, you can transform it by the same instructions that you know that the class file API has there, which is get static, or invoke virtual, or whatever of the instructions that your Java version supports. For instance, invoke virtual might be supported in some Java versions or not, but from 10 or more years, it's something that's there. And we need to find the descriptor of the Java Lang system base class, where we get the out object, and from the out object, we get the print line method, which is doing the print string. So we need this one. Of course, we need to still use some of the Java class file method references, like when you say something is string, you need to do it with this, let's say, string symbol like L/Java/lang/string, you know, this weird thing almost at the bottom right. So these are the things. Probably if you have some class file compiled and you run the strings utility from Linux, for instance, you see lots of this stuff there. So these stuff, we use them to make a descriptor for a method or to make a descriptor for a class file. And now this will actually transform the code. What we need to do is just to write it back. If you're doing annotation processing, you cannot write it back to the same class. But from compiler plugins, you can write back to the same class. So this is a crucial part that differentiates compiler plugins from annotation processing, where annotation processing only produces new classes, and you cannot modify the existing ones. Here you can do that one. In my demo last year, if you were there, we were writing a new class with a new name, then we were renaming it, which is a hack that you can do, of course. But here you can just write a new class. And let's see what are the other non-modifying use cases. So this use case where we printed the object instantiation is very simple, but it's the simplest one that I can show with an example. You can do lots of other stuff that will be very useful. So you can have any code analysis, like you can enforce some internal rules. Maybe you can forbid the import of a service inside of a repository. Some people still do these things, like I need this repository to do something, some transformation, some argument before setting it to the SQL. Maybe I will import a service there. But it's dependency inversion, solid principle that you need to follow. You can enforce it. You can enforce it by forbidding the import. You can find the import from the symbol table, and you can throw an exception. The code will never compile. You put this in Jenkins or whatever you use, GitLab CI, and then it will never compile to your Artifactory. Simple as pie, right? You can disavow some code blocks. For instance, up until the recent version of Java, synchronized blocks with virtual threads were doing a lot of problems, and you could disavow them if you're not using Java 24 or whatever they fixed it. You can say, okay, no synchronized blocks because you do a deadlock, because no platform threads will be left to be given to a virtual thread, and the virtual threads will be waiting for platform threads, and they will be waiting for one another. You can have some metrics or reporting that you can extract for each another method call. For instance, you can see how arguments are distributed across any methods. You may see that the average method arguments are 7, which is too much. You can forbid the compilation and say your developers, okay, guys, somewhere you have 20 arguments method which is exceeding our threshold. You need to fix it. Or the method size is 50 lines code. You need to fix it. Yeah, I know there are a lot of tools that are actually doing this already, but you can add your internal rules that these tools may not provide. locations. We saw them, and you may name whatever you want, whatever you imagine inside your own code base. This is something that, depending on what's happening inside your code base, is something that your team already know that, this one guy is violating some principle, and you can do it. All these classes there you can use, but all these in red you cannot. So with the tree scanner, you can scan whatever you want and see some things. You can see and take decisions, like all these code analysis and reporting methods, but you cannot modify. If you want to modify, you need the GC tree, or you need the tree maker, and these classes are actually closed. So how you can use them is by adding exports. If you need to fix Java, you need the red line. If you need a non-modifying use case, you need the green lines, which means that you may not be, you may not need to add any exports, any other things. It will not be considered as hack. Let's say that using the green classes like the tree scanner and the trees, you're not violating anything. You're not doing a hack. You're doing a good thing for your team. And this is one very big use case for compiler plugins, where your team actually can benefit from that. So I know you're here for the raffle, and then I will thank you for your attendance. My name is Ivan Yonkov. You can find me on LinkedIn, or you can find our company on Facebook, LinkedIn, whatever it is. I think Instagram as well. Doesn't matter. We're starting to publishing some stuff. Recently, LinkedIn deleted all our posts, so we're starting a fresh start. Okay, any questions? Yeah. Yeah, is there a mic for this guy, or should I repeat the question? Okay. Yeah, but the stream would not, if there is a, okay, so are there any security concerns using this thing? Depends on what you mean by security. You may expose something on your code base, like let's say, if you're modifying too much your code base, you may modify it in a way that someone can inject your remote code execution. So you should be very picky on how you modify it, and you need some pen testing for that. If you're just collecting information and reporting, probably not. Depending where do you report, of course. If you report to a remote server directly during compilation, there are also a lot of vectors to fix on the security side. Probably you need, yeah, another question?
About those plugins that is adding new methods to the existing class.
Yes, manifold.
Does it really add methods to the class, or just is doing some kind of articulation on the color side?
The question is whether manifold, when they are adding extension methods to the string object, are they doing new method addition, or they are intercepting the method call and doing some stuff? I would bet that they are intercepting the method call and say, okay, if this is a method call and the method name is this one, you need to do some stuff instead of making a compiler error, but I'm not sure about that. So I've never seen how this is implemented actually inside their code base. Both ways are valid, I think, but yeah, please again. Yeah, I think you have a follow-up. Before the follow-up, please. If it modifies the string class, well, is it a really big security issue? Yeah, so when you use such thing, you need to be, your security team needs to scan this library. You know, you add a new library, this library is doing some stuff. And it's not only for compiler plugins. There are a lot of libraries from Maven that are actually adding to your class path some annotation processors. And up until some versions, I think 17 or 21, annotation processors and compiler plugins, if they are in the class path, they're automatically executed. You don't need to add them. So if they put it in your class path, you receive an annotation processor that you don't want to receive. So your security team needs to scan all your dependencies and see if they're legit. Manifold is widely used by a lot of enterprises, so probably they're not cheating you. You need to scan the code base. Still, you need to scan the code base, the correct version, and see whether they are adding something in your string, like every new string, like a password, we are sending it to a remote server. because they can do that, right? Every string object, when it's instantiated, sent to a remote server. If it's a password, very good. So you need to scan it. It can be a security issue, of course. Every library. It doesn't need to be a compiler plugin to be a security issue, but this is a good vector as well. Question behind you? So the question is how the IDE knows that there is another method in the string class, that it shouldn't be underlined, even if it's adding it to a string class as a new method or intercepting it. In both ways, it will be in red and underlined. I think Manifold has this plugin for the major IDEs, like IntelliJ IDEA, where you install the plugin and it's doing this kind of compilation, passing the compiler plugin during what you're seeing on your IDE. So it transforms the code base by their plugin, and then you see what's the result in IntelliJ. Otherwise, it will be what you're saying. Great questions. That's very good. I thought that there would be no questions, which is beyond my expectations. Now I will want from you more questions. Only this part of the whole. This part? Any questions there? Come on, you lose on the raffle. I know because it's already. Don't listen to me. Don't listen to me. Do you see any reason hand? No? No? Okay. I know that it was quite a long one, even if it was on time, I believe. Well, at least nobody taken me from the stage. So yeah, I will again say to you, thank you very much, and we can speak outside the hall if you have any questions.
I don't like your little games, don't like your tilted stage, the role you made me play, the fool, no, I don't like you. I don't like your perfect crime, how
DJ Silviu M.
Sitting eyes wide open behind these four walls, hoping you come. It's just a cruel existence, like it's no point.
Така. Къде е Ванката? Окей, Ванката пие бира. Няма ли да идва за рафала? Поне един организатор има ли или аз съм тук само? Добре, пускайте пак музиката. Ванката! Ванка, чакаме те! Виж, 1000 човека те чакат! Okay. Малко да намалим. Okay. So these guys are fixing the website again. Because it's written in spring, you know. It is the way it is. Yes, for me now, I just want to ask you. Actually, I'm quite happy that so many people want to win prizes. Yay! Like we do it every time. So what do you want? PlayStation? Huh? Huh? Yes? What else do you want? Xbox? iPhone? Android? Or iPhone? iPhone, yes, of course, iPhone. Who the fuck uses iPhone? No, who the fuck uses Android? iPhone is prettier. What else would you like to win? MacBook Pro. Champions League. Yes. It's very achievable exactly in Bulgaria. Yes. And you know who is going to win it? CSKA Bace. In Manchester. Yes. Okay. Did you like it? Was it fun today? I want you to make more noise. Was it fun? Yeah. Was it better than the year before? Yeah, so. Was the food okay, by the way? Everybody got his food? Okay. That magnificent technology with, you know, making marks on the food worked because no other people from the offices come and grab our food. Yes, now we have food for all. Good. Фиксахте го това, бе. Пускай музика. Айде, жик-так! Съвсем малко намали. Хора, там правостоящите. Има купища места още за седене там. Нали, ще ни направят от пожарната охрана, ще ни викат и ще ни изгонят сега всичките. Има места, заповядайте, не се притеснявайте.
So now you can see an example of 3 people fixing a bug. In fact, 2 people watching, 1 person trying to do something. You can observe live debugging. No AI.
Yes, this is what happens when there is no AI, only... Yes, there are several Java champions on the stage trying to fix the website. Yes. This is what happens when you use Linux on your laptop.
So it turns out the jPrime website is so secure that Mishu cannot log in even with a password. So that's and trying even with several browsers. Yeah.
We can just use ChatGPT, come on.
Човека, който казват, че преба машините за гласуване, може да влезе в сайта на jPrime. Такива са и политиците, толкова разбират.
Окей. Чейнджваме лаптопа. Сега това е с Windows. Тук вече няма шанс. Някой да има Mac. Човек, почисти си този десктоп, бе. Okay, Windows as a B. Почти. Още. Yes. Добре. Yes. Така, може ли на екрана да сложите карта?
You need to scan this QR code, and when you are asked for your name, basically write the name that you have on your badge. Okay, so the QR code is coming. So the idea is, as you know, in the first years of jPrime, we usually selected people that were not present. So the way how this works is you just set a flag that you are here and only you are included in the raffle. There might be an ID. I know that you have no idea what your ID is, so just write your names the way how they are written in the badge. On the badge. Yeah, you should see something like that, but go back to the QR code. Yeah, or you can just write jPrime.io/QR/tuk, because why not? So you just write your name, submit, and it says your presence has been registered, blah, blah, blah. Da. So people getting 405, we also get 405, and Няма company. So you don't have to select a company. You can just write your name or your name and company. Okay. So why this company has been added? For the special cases of Ivan Ivanov, where everyone is Ivan Ivanov, and if you want to filter which Ivan Ivanov you want to register. But if you just write Ivan Ivanov, all Ivan Ivanovs will be registered.
Okay, raise your hand if you are able to register.
Yeah, so if you do receive 405, turn off the Wi-Fi. I'm guessing that something is wrong with the router or whatever.
Yes. Misho, you spoiled the Wi-Fi.
So the idea of the ID was that it will be printed on the badge, but for some reason this year it is not printed on the badge. So just no, I think the last year it was printed.
Okay, who was not able to register? Okay, try again, please.
Try without Wi-Fi. Write your two names.
Turn off the Wi-Fi.
Yeah. So just ignore this.
Almost there. We are debugging.
Just ignore this and ignore this for now.
Yes, it's just because we're using Spring technology for this.
Okay? Also, if you have some shady, strange name like Maria, which is super strange.
Okay. How many of you are still not able to register?
If it is written like that, write it like that. If it is
Turn
like
off
that,
the
write it
Wi-Fi.
like that. So it should be...
Have you tried turning it off and on again?
Okay, are we done? Everyone registered? Okay, waiting.
Who's playing? Okay, Steve.
Everyone cannot do it
By the way,
on Steam.
just a second. There is an official information that tomorrow there will be another strike. There is a possibility. So if you still want to listen to our famous...
Zor. Okay, so maybe tomorrow there will be strike, and KNSB are saying that even the underground may also So yeah, just to know it.
Okay, are there still people which are not able to register? Okay, there are too few people who are not able to register.
Okay, if you cannot register, register another name and remember it.
Vrni QR code. Okay, this is your last chance to register.
Again, you can just type the URL jPrime.io/QR/tuk. Yeah, but that's because we will be called mafia if you register. It's weird that I can register, but that's a different story. Okay, is everyone done? Okay, one person is not done. I guess he have a very long name.
Okay, are there still anybody not able to register? Okay, no hands up. Go ahead.
We done? Okay. So, there will be 8 companies that will be giving gifts, and we basically... What's so funny?
I just left our webpage.
We will basically help them to just choose the winner. Ivane?
I'm trying to accommodate the speaker. You are accommodated. Okay, so before I accommodate the speaker, the first company, they can't be here. It's Flutter, or maybe you know them as Poker Stars. And yeah, as they are a poker star, they are giving away a poker set, which is very heavy. Yeah, you can also do some workout. So let's start the raffle. Okay, so the winner is Virginia Voucheva from IBM.
Please come here. Where are you? Hey.
Congratulations, it's
Okay, big applause.
Okay, and
big applause, you.
And next is Okado. Where is Kotseto? Not Kotseto. I always ask for Kotseto.
Hi everyone, we are Okado. It was really nice talking to all of you who came by our booth today. If you didn't or wasn't able to, we'll be here tomorrow as well. You know us probably by our very cool robots, also because we usually give away Lego sets on these raffles. Well, this time we chose to do differently and provide a more practical reward, which is this Kindle. And yeah, let's pick the winner.
Push the space button.
Kostadin Dimov.
Pak je koctu. Ajde, tempo, 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 tempo. Tempo, tempo, tempo.
So, guys, feedback. Who is for Lego set? And who is for Kindle? So this is the feedback next year, Lego set.
So Kustodin may stay here, or maybe some of his colleagues can come. Next is Commerzbank.
It looks not like Lego set. Hello everyone, it's nice to see you all here, and I will be proud to representing Commerzbank. And a little bit more about it, we have a digital technology center here in Sofia that opened in 2020, and we have more than 700 people, and we're hiring more than 500 with very diverse tech stack. So please, if you didn't have the time today, come check tomorrow our booth. Thank you. Oh yeah, what are we going to give you? We have this battery over here, 65 watts, that gives you the extra time that you need for those production fixes that you are on the beach. So yeah, you know how it is. Don't tell anyone.
Space emojis.
Okay. Should I wait for a friend or something? Not space. Димитър Стоянов.
So next is software IBM, sorry.
Здравейте, радвам се да ви видя. Както разбрахте, ние сме от IBM. За първи път сме тук на конференцията, представяйки IBM. Подаръка, мисля, че го виждате какво сме подготвили.
Боже мой, боже мой, боже мой!
Сега, играта не е Лего, обаче може да си вземете игра за Лего, така че ако искате Лего, ето вариант.
Чакай аз да се регистрирам.
И така, I was supposed to do it in English?
No matter, it's okay. There's no recording.
Okay. И така, много се радвам, че ви видяхме тук през деня. Очакваме съответно да ви видим и утре и ще се радвам да ви видим, да се запознаем, пък и някой ден да работим заедно. И да пристъпим. Петър,
Your stare was holding, ripped jeans, skin was showing, hot night wind was blowing. Where you think you're going?
Mafia.
Hey, I just met you, and this
We call this night and random.
so call me maybe. It's hard to look right at you, baby, but here's a number. So call me baby.
Thank you. Next is AmuseNet. They have 3 prizes, right?
But they don't look like Lego set or PlayStation, so...
If we knew that the software is so buggy, we would have given only one prize. Hello, thank you all for being here. Thank you all for spending this day with all of the companies that we sponsor this amazing event. For us at AmuseNet, it's a great pleasure to be here for several years in a row, and we hope that we were able to talk with many of you today. For all of you, we are still here tomorrow. We have another raffle on our booth as well. We are giving 2 tickets to the Robbie Williams concert in the end of September. So everyone who wants to come, just come to our booth. We have a QR code, you can scan it. It works better. I promise. So now let's pick the 3 winners. We have 3 summer kits. Each kit contains a power bank, a Bluetooth speaker, a towel for the summer, and a nice hat. So We only need some cold beer, but you have this from the
Beer is
organizers.
downstairs. It's free.
Yep.
Thomas? Borislav Donev. Hey.
I think that everyone was excited for the last winner, Persuav. Thank you all, and we'll see you tomorrow.
Okay.
Thank you, Musenet. Thank you, Philip. And next is DXC, Manchester United.
Okay, Robbie Williams or PlayStation?
Hello everyone, my name is Elisabetta. I'm leading the Software Services Department of DXC. This year we are really proud to be part of the co-organizers of jPrime for the first year. Thank you. I'm sure all of you have heard of DXC as an outsourcing company, the largest one in Bulgaria, but we also have a substantial software development department, more than 300 colleagues, and a large part of them are working on projects with Java technologies. So we would be happy if you come to our booth. We are here tomorrow as well and speak to us. In the meantime, enjoy, and now we have a small prize for you. This is a professional backpack with a Garmin smartwatch. Virginia Baucheva.
That's nice and random.
Ladies and gentlemen,
thank you guys. See you tomorrow.
welcome to DJ Silvio M.
Okay, thank you, DXC. And now, for the first time, sponsors, Cognite.
Здравейте на всички! За нас е чест да присъстваме за първи път на тази конференция jPrime. По-високо и по-близо. Благодаря на всички ви за днес. И това, което ние правим, е Investigative Analytics Software. Ще се радвам да се видим и утре. Благодаря ви за днес. Подаръка ни е ваучер за ивенти.
Една книга и... Okay, thank you, Cognite. And next is Experian.
Hi everyone, what a great day. I want to thank our great hosts for today's session's agenda and every one of you who stopped by our booth to meet us and play some fun games. For you today we have prepared Sky Vision voucher for your next adventure.
Кристина Спасова.
So our next gift is from the Java community. In fact, it's a book that's originally signed by the authors, which are Heather Van Koor and Bruno Sousa, given at Java 1. And it's about developer career master plan. So even if you think that you've already reached a stage where you don't need to read about developer career, you can give it to someone that's starting his career. So.
Pavel Paunov, IBM again. Huh? I don't know. Okay, and last thing. We are giving away 3 IntelliJ. Okay, last but 3 thing. We are giving away 3 IntelliJ DL licenses from our partners from JetBrains. So you don't have to come to the stage now. Just come to us after everything finishes, and you will give us your emails where we will send the licenses. So the first one is Sanja Stevanovic from Wiser. Just raise your hand to see it. Okay. Okay, you're here. Next one is the promise is spacията, не. Stefan Dimitrov from VMware. Wow, VMware.
VMware, they still exist.
Все още има такива. And the third one is Maya Metodieva from PaySafe. Okay, so after the raffle, please come to us and share your email addresses so that we can send you the licenses.
Yeah. Okay, something final from me. So as you know, usually I'm giving tickets for Polyglot for Dev. However, there won't be any more Polyglot for Dev conferences.
Look,
so
he's using Bing.
we are setting this conference. At least that's the idea. If you want to know why or whatever, I can explain you. However, together with few friends, we will make a data stack conf in October, so at the same time. The website is datastackconf.com, if I can write correctly, /jPrime. Everyone who have a ticket for jPrime can register with their names and email for the DataStackConf, and basically they will have a free ticket, and they will receive more information when So, come on. Super up. So let me.
Okay, the most complicated way.
What the hell? Okay, so you can scan this QR code and just use the names that you have on the jPrime. You can write whatever email you want. It doesn't have to be your company email, especially if you plan to leave the company till October. There is no limit in the tickets, so some information about the organizers. The organizers are trying basically to create and to have a Postgres user group in Bulgaria. Currently, one of the people behind the conference is kind of in a team that is managing more than 100,000 logical instances of Postgres. So it's a huge volume. Also, they have a lot of experience with Oracle, so you can expect all sorts of data-related talks, maybe data lake stuff, maybe things about Aurora and AWS and so on and so on. Again, the conference will be in October. The actual date is not yet decided because it depends on the venue. And again, if you work in a company that have some investment in data stuff, for example, Infinite One, I just know that they have. You can even join as a sponsor. There is an email on the datastackconf.com. Okay? So we will leave this so you can register. In the meantime, the 3 people that actually won IntelliJ licenses can come to give their emails so we can send the license. Just something is that the license, I believe, is personal IntelliJ license.
Please stop.
So you cannot
know how to use
in
licenses.
a company. Okay, no, that's important. The license is a personal license for IntelliJ Ultimate. So you cannot use it if you work in VMware, for example, right? But yeah, just VMware. But
okay.
Yeah.
Okay, thank you for being with us. Good luck with the public transport. See you tomorrow.
Thank you, everyone, and see you tomorrow.
Maybe go to my place and just kick it like Chavo and possibly bring it over. Look back and watch me.